Hey guys, welcome to Intellipaat. In today's world, machine learning has revolutionized how we approach and solve a problem. It is one of the hottest skills to have, not just for getting a high-paying job, but also to build something really cool. But as a field, machine learning is really vast and difficult to wrap your head around. So keeping that in mind, we came up with this video on machine learning. This video will teach you everything which is required to learn as a beginner to get started with machine learning. So now, before we get started with the video, do subscribe to Intellipaat's YouTube channel so that you never miss out on any of our upcoming videos. Now, let me walk you through the agenda for today's video. We'll start by understanding what is machine learning and why is it being used. Then, we'll look at some of the key moments in the history of machine learning. After that, we'll learn about the several types of machine learning algorithms such as supervised and unsupervised learning. Then, we'll dive into coding and learn how to use several Python packages for machine learning like NumPy and Pandas. After implementing all that, we'll learn how to implement machine learning algorithms like linear regression and naive Bayes. And then we'll implement an end-to-end machine learning project for book recommendation system. Also, we will look at some of the most common and important machine learning interview questions to help you ace your next machine learning interview. After the end of this video, you would have a solid foundational knowledge of machine learning and all its concepts. Now guys, if you're interested in getting certified in machine learning, then Intellipaat offers a great course on machine learning. You can check the details in the description box below. Now let's get started with the video.
Well guys, the first question we all obviously have to answer is what is machine learning, right? Well guys, let me give you the textbook definition first and we can break it down later. Well, the textbook definition says machine learning is an application of artificial intelligence that provides systems with the ability to actually automatically learn on their own and improve from previous experience without being programmed by a human being. This is the actual textbook definition. But to break it down, in my personal opinion and in the opinion of a lot of data science professionals, machine learning is basically one of the ways that we can go about achieving artificial intelligence, guys. Well, machine learning right now, if you think about it, let's say past few years or right now or probably the next few years from now, it's all about mathematics and the mixture of mathematics and a lot of algorithms mixed together, and these put on some sort of massive steroids, guys, basically. So when you think about it that way, this is where we are right now. But if you're wondering where we're going to go in the future, well, in the future, it is definitely going to be achieving artificial intelligence on the whole. Well, you might be thinking we are almost there, right? So, we have amazing chatbots, we have very good robots which can go into the war, and, we have robots in medical sciences. And we have machines doing so many things faster than us. So why aren't we achieving artificial intelligence yet? Well, guys, I've covered about this in an entire video, which is what is artificial intelligence, which was my last live session. So I suggest you go watch that video after this video to get the answer to just that. But then you will have to know this point, guys. To achieve artificial intelligence, you have to train a machine to think just like a human being. I mean, in a lot of people, in billions of people's of opinions, a human being is the most evolved, most intelligent species out there. So unless the answer of that changes to a machine, which is the most intelligent thing, right? Sure, it might be faster than a human, but is it the most intelligent thing? Is it self-capable? There's a good side and there's a dark side and so much more. But until we go there, we're going to be still stuck with mathematics and statistics and so many of these concepts on steroids, guys. So basically, you might be wondering where machine learning fits in this entire picture of artificial intelligence. Well, as I've already told you, machine learning is one of the ways we can go about to achieve artificial intelligence, guys. But then you can see the other term, deep learning, as well. Again, deep learning is another subset of machine learning itself, which itself is a subset of artificial intelligence, right? So we have three sets going on. Deep learning being the most internal thing, which is a part of machine learning being a part of artificial intelligence, as you can just check out on the screen. Well, consider this very simple scenario, guys. As humans, let us say, we can pretty much go about doing very simple mathematics, multiplication, right? So let us assume y is equal to 2 and y is equal to 4 is the answer that we know. So the data can be x is equal to 1 and x is equal to 2. So what is the rule that you apply on the data to get the answer? If you can figure that out, then you can pretty much know how that answer came by, right? So if you multiply the x value by 2, it's going to become 1 into 2, 2. So we got the first y value, then x is equal to 2. If you multiply this by another 2, we got the second value, which is y is equal to 4. As humans, we have been trained for a lot of years to do just this. But then now think about the machine's perspective. The machine doesn't know how you can get y is equal to 2, right? There is millions of ways you can bring the value of y to 2, but it doesn't know how to go about doing it. But then you can say that, hey, look, you're going to tell your machine that this is the data that you're going to get and this is the answer that I want. So how are you going to do it? So you're going to teach this machine how it is supposed to take that data and come up with the rule and give you the answer. It is as simple as that. So if your machine, let's say you apply machine learning, and at the end of it, if you're right, if you've done it well, then pretty much your machine will tell you that, hey, the rule I applied is y is equal to x into 2 to convert the data into the answer that you required. And this is exactly what happens in machine learning, guys. So basically, to learn the rules which governs an entire phenomenon, machines have to go through this entire process, what we call as learning. And after this, basically, they will try out different rules, different learning procedures, and this will basically govern of how the machines want to perform. Do they want to perform well? Are they performing well? And so much more. And this machine's learning to convert data into the answers that we require. This is why they are basically called as machine learning, guys. And I hope this simplification actually made complete sense to each and every one of our viewers who are very excited, as I can see in the comment section, for the machine learning videos, guys.
Just a quick info, guys. If you're looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. Now, let's continue with the session.
So again, guys, I want to know your opinion about machine learning, past, present, future, and whatever it is that you want to convey. Please head to the comment section. Let us keep it very interactive, and it's going to be an amazing session, guys. So on that note, the next part of simplification is pretty much the terminology. In case you're a student of machine learning, or if you've ever heard of machine learning in your life, there is a very good chance your friend, your colleague, your superior, someone would go about talking about these terminologies as well. So let me tell you the 3 good terminologies that you should know in case you're interested in machine learning. That's it. So basically, first one is data set, guys. A data set is basically a set of a lot of data. So what does this lot of data mean? Well, at this particular point of time, it might be data examples in the form of a list, or it can be in ordered collections. And this will basically contain features or data or more data, let's say. So this data will contain certain information which is required to solve a problem. This is as simple as a data set can go, guys. And the next thing is features. Well, what are features? Features of a mobile phone, features of a television, we sort of use these to describe the object, right? So you might look at the brand new mobile phone which is launched in the market, and you can talk about all the features of it. So features are description of that product. Again, here as well, features are pretty much the important pieces of information in the data that help us understand, how we can go about solving a problem. Instead of analyzing a product, we're analyzing a problem here. And a data set will have a lot of features, and these features can be used to train your model as well, guys. So train your model. So what does the model mean? Well, the model basically, when you talk about a machine learning model, this model is basically what you can call after the output of the entire process of it being trained, it being learned, and it being ready to use. So that's as simple as it is. So your machine learning model, your machine learning algorithm has learned something, and it can give you a valid output, a correct output. It might be the wrong output sometimes as well, but it gives you an output which you can use, and this is the product of training. This particular phenomenon, after your model is trained, we call this the after the algorithm is trained, we call this the model, guys. And there might be other terms as well, something like losses, something people can talk about fitting, underfitting, overfitting, and so many other phenomenon. People talk about generalization, people talk about normalization, hyperparameters, how you can go about tuning these hyperparameters, and so much more, guys. So I suggest you do not be overwhelmed by the terms in case you do not know what they mean. And that is one of the reasons why, actually having a process of structured learning in machine learning, having to master machine learning, being certified in machine learning adds so much value to your resume, guys. So on that note, what is the exact process of how machine learning works? Well, guys, we're going to work from the top down, right? So the first process you see, data collection, is step number 1, and then step number 2, 3, 4, 5 as we go down. first step is to pretty much go about with data collection, guys. Well, data collection is pretty much the process where we collect the data through which the algorithm will actually learn. Data can come from your neighbors, the data can come from any data sets, the data can come from Twitter, Facebook, WhatsApp. I mean, you can pick up data from any part of this world and you can go about collecting it, storing it, processing it in a structured way, guys. So this is data collection. The second thing is data preparation. So all this data you have, right? So it might not be in a very usable friendly way for a machine to go about using, because a machine is again, a dumb coded machine by an intelligent human is how I would put it. So you need to prepare this data. You need to format this data, bring it to a point where we can engineer the data into the optimal format that we can go about using, guys. This brings us to the third step. The third step is actually training the process where the machine learning algorithm actually learns. This is the process where the training happens. And then the next process is evaluation. Evaluation is basically where we test the model to see how well it performs, and then at the end of the evaluation we actually tune this model. Now we know where the model stands, so let us tune it to make sure it performs better. If it can do 80%, let us tune it to make sure that we can get 100% out of it, right? When you think about it that way. So next up, we need to discuss the key moments of machine learning, guys. So the first important, the timeline of machine learning started in 1959, guys, because the term machine learning was actually coined by Mr. Arthur Lee Samuel in 1959, guys. So it was, think about it, 1959 is such a long time ago, right? The world was a very different place back then. But then people were sure that, especially Mr. Samuel was sure that the world is going to see machine learning sooner than ever. So he was an American pioneer, and during the 90s, he was very famous for his works in the field of computer gaming and bringing artificial intelligence to the table as well, guys. So him along with other pioneers such as Alan Turing, John McCarthy, and so many more actually came together in conferences, and I've again discussed this in my previous What's Artificial Intelligence video. So they came about and they give us all the terms we see now, guys: artificial intelligence, machine learning, and so much more. And again, fast forwarding all the way from then to 2012, our first machine learning product was Google Brain. Google Brain was basically a deep neural network created by this person called as Jeff Dean at Google, and this person basically created a neural network which could detect patterns in images and videos, guys. And since it was using the resources that the biggest company Google had, it was no match for any of the other small neural network companies to actually compete with, to be honest. But then it was later actually used to detect objects in YouTube videos. And guess what was the first detection made by Google Brain, guys? So Google Brain actually went about detecting an image of a cat in a video, and that's how our machine learning journey started, guys. So on YouTube, we went to go about, the model basically detected a cat successfully. And then from then on, we are doing binary classifications with cats and dogs and whatnot, right? So fast forward to 2014. The amazing people at Facebook created another deep neural network, and they called it DeepFace. DeepFace is basically using deep learning for face recognition, guys. And then Facebook made a claim which the world had never seen before. They claimed saying that we can recognize people with your photos with the same precision as a human being can do. Think about our original terms of artificial intelligence. Achieving AI is basically making a machine think equally good as a human. And that is the same with the Turing test as well. Again, regarding the Turing test, I've covered it in the previous video, guys. So basically, when you think about it, when they claimed it to be this, then it had to be amazing, right? So then again, the same thing happened in the same year actually by DeepMind. Well, the people at Google again said, hey, if you can go about recognizing images, we can go about playing video games against the best professionals in the world. This had already been done by IBM Watson, but then people at DeepMind took it to another level, because in 2016, it managed to beat the world champion at this game called Go. But what is famous in that is Go is considered to be one of the world's most difficult board games, guys. So on that note, we come to 2015. Well, 2015, OpenAI, the foundation, basically it's a non-profit organization, was co-founded by Elon Musk, guys. So Elon Musk is the billionaire entrepreneur person who's heading Tesla, who's heading SpaceX, SolarCity, and so much more. So he pretty much founded OpenAI as well. And the goal to OpenAI was to basically create a safe artificial intelligence platform that can actually benefit humanity, guys. See the highlighted words safe and benefit, because Mr. Elon Musk again has two views about artificial intelligence, and one of it is the negative aspect where he thinks that artificial intelligence might turn out to be bad at the end of it. But then hey, it's his opinion and we need to respect that. But again, I've covered all of this previously, guys. So this brings us to the perfect Go example that we just spoke about, guys. Because again, when you think about it, in 2016, AlphaGo basically became the computer Go program which beat an unhandicapped professional human player. So this professional human player was the world champion multiple times, and it beat it like there is no tomorrow. I mean, to say it a little informally. But then this was done using basically a lot of machine learning techniques and a lot of tree searching techniques as well, guys. If you do not know what tree searching techniques is, you do not have to worry, guys, at this point of time, because again, when you come to think about it, AlphaGo actually went another step ahead, and it went to be generalized to the world of chess as well. And there's something called Alpha Zero now, which concentrates on many more two-player games where artificial intelligence brings its best and challenges the best human beings across the world, guys. So this brings us to the algorithms.
Just a quick info, guys. If you're looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. Now, let's continue with the session.
What do you think is the need for something called as an algorithm? Well, consider this situation, right? So let's say you're either baking a cake or you're driving your car, you're even walking or singing. Well, your body is continuously executing the set of steps that you have already trained it to do, and then this is what we call as an algorithm. So basically, when you're driving your car, your brain is already programmed to do all the tasks that are required to pretty much help you to drive your car. And then when you're walking as well, how do you maintain balance? Well, as a kid, if you could realize that maintaining your balance as a toddler was very difficult, but then you trained yourself every day, and then now you can walk very easily, right? So this process, which involves learning and then this repetitive process, is again pretty much can be termed as an algorithm as well, guys. Well, if you've been wondering if algorithms are new concepts, well, they're not. Algorithms have been used for decades together. Well, back to this person on the screen called Alan Turing. This person, here's a good fact, this person was the reason probably why World War II ended. He was the one who decoded the very famous encrypted Enigma messages from Germany, and then this person decoded that. And then and all the code breakers and so much more, right? So the entire point here is to tell you that algorithms have been used, is an age-old tradition that's being used, and these days we've been pushing it to our computer science field as well, and then making sure that we make full use out of it, guys. And then again, why would we require it? Well, think of the huge amount of data that's being generated these days, and then think of the methods that we need to process it, to understand the data, to process the data, and then to pretty much clean up the data and work with it, right? So for all of these, we have something called as algorithms, guys. So on that note, what are algorithms? What is the formal definition of an algorithm? Well, guys, algorithms are as simple as this. They are just a set of rules, or you can call them as processes as well, to be followed in calculations or any other problem solving operations when done by a computer. Well, how simple is that? Well, this is exactly what an algorithm means. Well, you have a symbol on the left hand side. That is pretty much what a flowchart looks like as well. Don't worry, we'll just be checking out the flowchart sections in the next set of this slide. But then right now I want to tell you guys that you guys are using algorithm as is. Well, step one, you're looking at your screen. Well, you've programmed yourself to look at the screen. That's an algorithm. And YouTube is running a recommendation algorithms where you just, let's say you search for something, Python tutorials or anything for that matter, right? Intellipaat's videos are up there. So how does YouTube know that, it should recommend Intellipaat's videos to its learners? Well, again, an algorithm is being set there. And every time you check your mails are filtered in your inbox, in your spam folder, and so much more. So how does Google or Gmail know what mail is a spam mail and what mail is not a spam mail, right? So that again is an algorithm right there. And no matter what operating system you're on, Windows right now, or let's say iOS, let's say Mac OS, Android, whatever, right? So all these operating systems are using algorithms right now. On that note, we need to check out what the types of machine learning are. So we have three main types of learning which happens when we talk about machine learning, guys. It's supervised learning, it's unsupervised learning, and it's reinforcement learning, guys. So if I were you guys, I would just suggest you guys just take a minute, pause on the slide to note these three types of machine learning, guys. So supervised learning, unsupervised learning, and reinforced learning. If you're already familiar with the concepts, or if you think that you got it in the bag, well, let's move ahead to check out what supervised learning actually means. Well, supervised learning, as the name suggests, requires some sort of supervision, right? Let us talk in terms of variables so we can understand it easily. Again, in supervised machine learning algorithms, let's say we have input variables and our output variables. These input variables are denoted by x and the output variables are denoted by y. So x is input, y is output. The goal of any supervised learning system is to understand how your output variable y changes with respect to the change made in terms of x, guys. So how does the output variable y vary when we go about playing with our input variable x is pretty much the goal of supervised learning system, guys. And then here we'll also be approximating the mapping function to a point where we'll have new input data coming in which we haven't seen, which the machine hasn't seen, and then we can predict new output variables y with respect to all the new data, the new x data that the machine just saw. So we've trained it for a particular amount of x's, and then it saw a new amount of data, a new amount of input variables, and then it trains itself to pretty much give us new y output values, guys. So how cool is that, right? And then we need to also know that we have dependent variables and the concept of independent variables, right? And our aim here is to pretty much understand how our dependent variable will change with respect to one independent variable. So we have a couple of dependent variable which goes hand in hand with the variable what we call as the independent variable. And then we need to understand what are the changes that goes into these dependent variables when they are mapped across and compared with respect to our independent variables, guys. Just to make sure that you guys are getting the concept out here, here's a very simple example showing you the same. So again, here our independent variable in a particular case is, let's say, our gender of the student. We have a girl and a boy here. The dependent variable can be the outcome of the educational qualification of the student. So let's say if the student either passed an examination or failed an examination, this becomes our dependent variable. So the independent variable is our gender. The dependent variable becomes the output of what the student is trying to do. And at the end of it, what we're trying to do is basically trying to determine whether the student would pass the exam or not based on the person's gender. Let's say we are doing a survey where we need to find out how many girls have passed or how many boys have passed. Here again, the gender becomes the independent variable, and all of that depending on it in our particular case is the outcome. The pass or the fail becomes dependent, right? So here again, we're trying to find out if the student would pass based on the gender or not. So the dependent variable would pretty much here be again, as I've already been mentioning, it's going to be the outcome, and the independent variable is going to be the gender, guys. So do we have anything more in terms of supervised learning? Well, yes, guys. Here is more classification with respect to supervised learning. Is we have something called as classification and something called as regression. Let us quickly check out what regression is, and then we can come talk about classification, guys. Well, regression is a type of supervised learning where the output variable is a continuous numeric value. So what do we mean by a continuous numeric value, right? So let me again take another quick example to make sure you guys understand this better. I have images of two apples for you guys. One apple costs $4, the other apple costs $3. Here the output variable is the cost of the apple. It is a numeric value, which is a continuous value. You can predict it, right? Is the apple ripe? If it's yes, then it's costly. If it's not yet ripe, then it's cheap. Well, is it a Shimla apple? Is it a Kashmiri apple? Is it a Washington apple? Well, you can pretty much go on adding so many factors around this apple and then come up with one particular outcome out of it, which would be the price, right? So the price depends on all of these factors. And in our case, the price is the output variable. So we're trying to predict the cost of the apple with respect to all these other factors, right? So again, doing this in a real world or in a mathematical situation, and in this situation, pretty much we call it as regression, guys. So with respect to regression, again, there is another type of regression, which what we call it as the logistic regression. And this is basically just a technique, where our dependent variable, instead of it being a continuous numerical value, it is a categorical value, guys. So again, what do we mean by this? Time for an example. If you can take a look at the example on your screen right now, what we're trying to do is we're trying to predict whether if it's going to rain on that particular day or not. And this is being done with respect to two independent variables, right? So how do we check rain? Again, pretty much it's usually done by checking the temperature, checking the humidity, and if all of this is good, we probably just go out, take a look at the sky to check for clouds and so much more, right?
Just a quick info, guys. If you are looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. Now, let's continue with the session.
And here, coming back to logistic regression, the dependent variable is the categorical variable, right? So it can have only two values. A categorical variable can only have two values. It is mostly binary, guys. So it's going to be either 0 or it's going to be 1. And in this logistic regression model, what we call it, depending on all of these attributes, we get the probability our final answer is going to be either yes or no, right? So if you ask someone a question, is it going to rain? Their answer might be either a yes or a no, right? So it's a binary answer. Again, here it's the same as well. To pretty much to graph out what it would look like, we have an S-shaped curve out of this model, what we call as the logistic regression, guys. So on the left, we have a linear relationship between our dependent variables and the independent variables. It is just a straight line. On the right, since it's a binary value, binary outcome that we're looking at, the curve looks like an S. So again, guys, take a moment, pretty much pause on this slide to understand what a linear regression graph looks like versus what a logistic regression graph looks like. So on that note, let us quickly come back to check out the next subdivision under supervised learning, which is called as classification, guys. You pretty much, as the name suggests, you might already know what classification means. In literal terms, well, again, classification, here the output variable is categorical in nature. So again, it's going to be a binary value. So you can just have a look at the picture on your screen, and then we can categorically analyze if that person is a male or a female, right? So here the binary outcome is again the gender of the person, if the person is either a man or a woman. And then again, the output variable is the gender of the person, which is a categorical value, and we're trying to classify this person into a specific gender, based on all the other factors as well. Well, how do we know it? Well, we could see the beard on the face. It looks like a man. So our brain pretty much told us it is a man, right? Simple as that. So on that note, we've pretty much checked out what supervised learning is. So what is unsupervised learning? Well, guys, in unsupervised learning, here all of the algorithms that we have, right? We have input data which has no labels. So when we mean that the data does not have any labels, then there is nothing that the machine can map to understand the data offhand very easily. So if you can take a look at the raw data ourselves, right? So we can probably tell that there's a couple of fishes in there, there's a couple of birds in there. Well, we know it because we have trained ourselves for that. When the machine sees this, there's not going to be any label which is going to tell that this is a fish or this is a bird. So our unsupervised learning algorithm is pretty much going to run through this again, and at the end of it, with respect to clustering, what we call is the process of clustering, it's going to divide all the fishes for us, divide all the birds for us on its own. So here the input data has no input labels, has no class labels, and it doesn't know what's a fish and what's a bird, right? So again, building a supervised unsupervised model on top of this input data is again very interesting and very fun, guys. So here again, it's going to pretty much be giving out two clusters. First consists of all the fishes, and second consists of all the birds, guys. So coming to clustering, which is again a major part of unsupervised learning, the most important clustering algorithm, the most simple one, is the k-means clustering, guys. Well, k-means clustering again is an unsupervised machine learning algorithm where the aim is to pretty much go about grouping all the similar data points, just like fishes and birds, and making it into one cluster, guys. So again, there must be a very high intra-cluster similarity and low inter-cluster similarity out here, right? So what do we mean by that? Well, all the data points within a cluster should be as similar as possible, and all the data points in between two different clusters must be as different as possible. So all the data in one cluster is simple and similar. All the data when you compare two different clusters are very different to each other, right? So this is pretty much the k-means clustering in just a sentence, guys. Well, what does the K stand for in the K means clustering, right? Well, K is the number of clusters that you just want the outcome to be. In our particular case, we have cluster A, cluster B, and cluster C. So the K value here is 3 because we have 3 different clusters, right? Very simple as that, guys. So on that note, the next type of learning that happens is what we call as the reinforcement learning, guys. Again, in reinforcement learning, there is something called as an agent, and this agent pretty much runs up and returns up most effective actions for us by mapping its state at every single moment, guys. So to give you a better clarity, just I hope you guys have played Pac-Man in your olden days, guys. So in this particular video game, the space around the figures would what we call as the 2D game space. Again, you have something called as pack dots, you have enemies, you have walls, and so much more, right? So the action here is to again just pretty much move around and make sure you don't touch the bad guys and just finish your entire goal. Here, how do you know who the good guys are and where you need to move and how you're not supposed to get out every single time, right? So that particular thing, you've been playing this game for a while. Let's say you've been playing this game for a couple of hours, couple of days in your childhood, and then you realized how the game actually works. Well, that exactly is reinforcement learning, guys. Again, to give you another example, reinforcement learning is pretty much how a dog or a cat is trained in its real life as well. If the dog does something right, if the dog is given a handshake, let's say we're training a dog to give a handshake, and then if the dog is given a handshake, you might see that the trainer just feeds a biscuit that instant, right? So the dog knows that the outcome of giving a handshake is pretty much the right thing to do because there is a biscuit at the end of it. So the reward is being hunted by the animal, right? So again, to put it all in one single picture, this is what a reinforcement learning environment would look like, guys. So we have an agent who performs an action in an environment, and then here we can actually have two tracks where if the agent does it right, if the task is being performed right, there is a reward with respect to it and everyone's happy. Else, if you do not have that particular reward, then it means that something went wrong, and this will have a state. Because something went wrong, you're eventually not getting the reward. Let's say the dog did not give you a handshake, or if you pretty much give it a biscuit at that moment, it will not realize if it's doing the right thing or the wrong thing, right? So that we can have a state of, let's say the dog did not give a handshake, and that's pretty much what ST means, guys. Reward is RT, and this keeps on going in an iteration where you're just training your model better and better and better to hunt more rewards. The more the rewards, then the machine's doing the right thing. It's as simple as that, guys. So on that note, I have two very simple demos which are in Python that I just quickly want to run it by you guys to tell you the use of machine learning algorithms anyway. So on that note, let me quickly jump into Google Colab. Google Colab is basically a Python Jupyter notebook hosted on the Google Cloud, and I use this for most of my Python coding as well. So anyway, coming back to it, here's the first example that I'd like to discuss with you guys. Well, just give me a second. The runtime is being connected, so it's almost connected now. It's initializing, and then it's gonna say connected any minute now. And there it is. So first, let us take out a k-means clustering demo, right? So pretty much we're going to import a couple of packages such as NumPy, Pandas. We have matplotlib to pretty much give us the output in terms of graphs. We have sklearn to pretty much import what we have the sub library called as the k-means library, and then go on working with it. So let me quickly import all of these libraries that we'll be making use of and then go ahead with that. So to generate data of our own, instead of just picking it up from any data set, for this particular case we'll be making our own data using something called as make underscore blobs, guys. So we'll have 300 samples here, and then we'll have 4 clusters each. So this is what we means. N underscore samples is 300. We have 300 dots on your screen right now, and these dots are divided pretty much into 4 clusters for us. So let us use something called as the elbow method, where pretty much it's called as WCSS. I would recommend you guys pretty much Google it. What if you want to know what WCSS means. It is again a very complex part of the k-means algorithm, and I would just suggest you guys to check it out on your own because it is not in the scope of this particular tutorial. And then so we'll be using that particular method, and we're going to train the entire model for us to make it understand what's going on. So look at this, right? So what is the optimal number of clusters again for us is somewhere around say 3 or 4 as well. So we have 4 clusters, and we have the WCSS all the way from 2500 till 0, right? So we're gonna have to categorize. This is just a graph to tell us what the data might look like, right? So we need to find out the centroid of what we call as the centroid in the k-means clustering algorithm of each different cluster, and then we need to mark that centroid, right? So this is exactly the red dot. What you see is again exactly what's going on there. So we've pretty much found out that there are four clusters that exist, and then we've pretty much marked the centroid of the four different clusters that you see using k-means clustering, guys. It's as simple as that. So that was a very simple first demo, right? For our second scenario, I will be checking out our logistic regression, and in this particular case, we'll be going on to predict heart disease prediction data set, and we'll be performing our machine learning algorithms, and we'll be using machine learning here to predict if a person is going to have a heart disease or not. And we're going to be doing this entirely using the process of logistic regression, guys. Again, we're importing a couple of libraries here, pandas to handle the data, numpy to handle mathematical operations, scipy to go on to do our computations. Then we have matplotlib and seaborn to pretty much give us visualizations, and we have sklearn, which is a scikit-learn, which is again a very important machine learning library of Python, and we're going to import all of these, guys. So just before that, we need the dataset file, which is called as the Framingham dataset. Well, the dataset is from the town of Framingham in Massachusetts. So let me just quickly import the file, which is called as the Framingham dataset, and then we can pretty much go on to working with it, guys. So it's gonna take a second to pretty much get uploaded. It's a small file, and as you can see, it's been uploaded. So now I can go on to pretty much run this code, where this is what our dataset would look like. If it's a binary value for male, it means if it's male equal to 1, then the person is male. If male equal to 0, it means the person is a female. It has the age. It has if the person is a current smoker or not, and how many cigarettes per day. Do you have BP medications, and then blood pressure basically. And then, have you had a stroke in your life? Are you diabetic? What is your total cholesterol? What is your systolic blood pressure? What is your diastolic blood pressure? What is your body mass index? What's your heart rate? What's your glucose at? And then it's gonna check your CHT as well, and so much more. So this is an amazing data set to work with, and pretty much we're gonna be just replacing the column of male by sex underscore male. That's about it, what we're doing here. And then we need to find out how many missing values we have in this particular data set, and there are so many values with zeros in it, right? So we have about 388 missing values when it comes to glucose, 50 missing values when it comes to cholesterol, and so much more. So let us go on to remove all of these missing values and say, hey, look, it found pretty much about 500 total number of rows with missing values, right? And it's fine in our particular case because it's only 12% of the entire data set, so we can exclude that and we can pretty much drop it, and it wouldn't hurt our analysis at the end of it. So to begin with, you have to perform some exploratory analysis where we need to show what the data is being distributed like, and we need to just hunt into our data to find out what the data is telling us, right? So here's a couple of quick charts which pretty much give us all of our numerical data with respect to graphs. So we have again the sex distribution, we have the age distribution, current smokers, BP medications distribution, cigarettes per day, diabetics, total cholesterols, BMI, systolic blood pressure, diastolic blood pressure, and so much more, right? So we're just pretty much performing some quick exploratory analytics on it, and then we're going to be going about to find out what the actual this is just a 10-year CHT that I'm printing out, and then we need to go about finding out if the person has a rate has a chance of getting a heart disease or not. Well, here we can check out the count, right? So there are about 500, let's say 600 people who are in risk of getting a heart disease, while there are about 3,500 or let's say 4,000 people who are healthy and quite well. This is what exploratory analysis pretty much helps us to do. It gives us a sort of an analytics number where it can find out if the person might suffer from a heart disease or so in the near future, and so much more, right? So let us quickly go about plotting that, and we can go ahead from that. Well, as you guys could see, that pretty much took about a minute of processing because it has to plot so many values for us, right? I'm sorry, let me quickly scroll down so we can get a better view. Again, this is respect to this is a seaborn axis grid plot, and then you can see all the concentration of all the values at every particular instant, right? This is for every single aspect that we're using to compare. So let us quickly use describe to pretty much tell us what we're just looking at. And yeah, so we have a count of about 3,751 males. It's going to give you the age of so many people. It's going to give you all the cigarettes, BB meds, prevalent stroke, and so much more, right? So coming to the process of logistic regression out here, from all this data set we need to have an inference at the end of it, right? So to do that, we pretty much be running a couple of functions. One of those functions is a lambda function, and then we can have this very nicely optimized output printed for us. And then, as you can check out, as it already says, the 10-year CHDs pretty much are dependent variable. We'll be using logistic regression, so much more, right? So it's going to give you all the standard errors, all the values of we call it the Z method. It's going to give you the Z method value. It's going to check if your probability of your outcome is greater than the value of Z with respect to all of these single categorical variables that we're checking. And then when it comes to backward elimination, we'll pretty much be using our feature selection to go about doing it. And the end of it, we can have a summary, a very nice looking summary printed for us. Well, again, the summary looks nice, right? So we need to make more sense out of it, such that, okay, this is the odds, this is the ratio and all. So here we have something called as the p values. We have the odds ratio and the CI 95% values out here. So here we can pretty much go on to analyze what actually causes the outcome of, let's say, a heart disease. And so well, we can make sense out of it. To use our model to make sense out of it, let's quickly split our one single data set into a training data set and a testing data set, and let us make our model give us the answer for us, right? So checking out model accuracy using our scikit-learn library, again, you can pretty much find out that our model is almost accurate for about 90%, right? So 88.14% is a big number, and it's been training, well, not for many times, right? So the number of iterations again is very less. So here's a subplot, is what we call as an axis subplot. And here as well, you can pretty much check out the actual predicted outcome values, which is predicted 1, predicted 0. The actual outcome values is this color, while the actual value is blue color, right? So the color distribution here again will let you know of what's going on there as well. Well, here is another step to pretty much print out what's what's a true positive rate of the data, true negative rate of the data, and so much more. To put it all into one single print statement to make it sure it looks very nicely, the accuracy of our entire model is about 88%. The misclassification is pretty much 1 minus what the accuracy is, right? So we've missed about 11% of accuracy. True positive rates, we have somewhere about 4%. True negative rates, we have somewhere around 99%. Positive prediction rate is 80%. Negative prediction rate is somewhere around 88%, and so much more, right? So look at this amount of data. Look at this amount of data that our machine learning algorithm is pretty much giving us, right? So if you put it literally, in terms of use cases, in terms of medicine, then that's going to help a lot of people, right? So that was a quick walkthrough, pretty much on how you can go about using k-means clustering and logistic regression algorithms, guys.
Okay, let's get started with NumPy. So I believe you guys already know like what Python is capable of, how powerful it is. So we can use Python for all sort of things, right? From desktop development, web development till data science, we can do anything and everything with Python in the programming world. And next thing is Python builds upon its functional modules. Okay, so it has all core constructs of programming. Like there are three types of programming that we have: structural, object oriented, and functional. So it is capable of doing everything. Okay, next is when we work with anything in Python, we have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to, I mean, play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with pandas and, I mean, NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, I mean Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have a alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's how why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am writing it again and again, pip install numpy, so it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it, we write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists, so it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in numpy. That is how we create arrays in Python. So that's how we do it. So now next will be how, where it is, and I mean, where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by numpy you are changing yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Right, next is nd array object. Okay, so in NumPy, as I have shown you, two 2D arrays, right? It can go up to n and then can have any number. So in real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is, and next is like why we use NumPy arrays. So in NumPy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to, it all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property, it has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see first, sorry, if you want to see the first column, you need to do this, right? Sorry, so you need to do this, so you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays I will be coming, okay, I am working on 2D array, sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names, A and B, right? 2D arrays I will be showing you, not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print whole. If we do this, that also will mean the same, and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now numpy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than numpy array. Okay, now next is, if you go into check the individual, yes, right, so it will be begin colon n minus 1, that is how. So right hand side will always be excluded, like that. Okay, next is numpy array initialization, right? So how do we initialize numpy arrays? As we have already seen, right, how do we do that, but still this is how you do it. Okay, so initialize means what we want to do is, we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is, we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing and for data processing, we will do that a lot of times, we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to, come on, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in numpy. So what you do, you write np dot zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np dot zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in numpy. So that's how you print zero arrays in numpy. Okay, next is, if you want something with the interval, right, so how you do, you write like this, np dot array, within bracket we pass, so it will print you another new array. So what we are doing, we are sorry, in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's a range, so it's a range actually. Okay, so what we are doing, we are passing three variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having five, we want lists to be five separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have three numbers, right, 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in numpy. Now this is the same thing. Okay, now next thing is, this arrange is done, right? Now let's say we want we want to spread some points over a straight line. Okay, so how do we do it? We want to I mean, what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line. Okay, so what we will do then, like we want some points between range a and range b. Okay, So here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise. Okay, we want it to spread along a line like this. So for between 5 and 10 we want 6 numbers. It is almost same as numpy, but it has a bit difference. So how it is differing, I will show you. Okay, so
Just
this
one
links.
doubt in the arrange. The last, the end number can we put as 19 instead of 20 in the last example?
Yeah, then it will print only single number,
No, no,
right?
no.
Then
No, the second argument.
yeah,
Yeah,
this one
and
we can do. It will go till 18 only, not an issue.
okay, thanks.
Yeah, you can put anything. So the logic is when it reaches the end number, right, with interval, if it goes past or if it goes till the last number, then that number will be I mean that number will be excluded, right? So let's say 18 plus 2 will be 20, right? So 20 will be excluded. Okay, so that's how it works. Okay, so for 19, 18 plus 2 is 20. So anyways, 19 will be excluded, right? Nothing is there to print it out, right? So that's up. Okay, so we are not into loops, so I won't go in that. Okay, next is this lean space. Okay, so lin space and arrange, right? So arrange, what it does, it takes in three numbers: so start number, end number, and so what we do in arrange, we have three numbers as a parameter. We take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals. Okay, but in lin space, what we take three parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there. Okay, number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linspace and arrange, and all these functions we will be using heavily when we go for data science. Okay, because these things we will need, and you will see how do we do that. Okay, these things we will be discussing when we discuss about the data science concepts. Okay, now next is how do we do array with the same number. Okay, next is how to create an array with the same number. So this is same for same uses like that, like for zeros, right, formats for carving out some masks like that. Okay, so if you use this keyword, then if you pass some values, so come on, if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up. So np dot full, it will take up first a tuple, the tuple of row numbers, column numbers, and it will take up the number to fill that array with. Okay, number to fill, like that this thing works, this full function works. It can be anything. Okay, it will give you a array full of that kind of numbers of any dimension. Okay, any dimension can be given. Okay, any real world numbers can be given, I mean, sorry, any integer number can be provided as a dimension. Okay, so that's how this full function will work. Okay, next is to randomize an array, again for, I mean, that masking only. So how we do, let's say we want a 3 by 4 matrix to be randomized. So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, in that way it will be organized. So random is this thing. Okay, now we go to how do we access this numpy arrays. Okay, now let's say we are creating two arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do print a, so that's how the shape function works. Okay, that's how we can access a shape of an array. So shape function will return tuple of its row number and column number. Okay, so a dot shape returns tuple row num, column, like that. Okay, so it will be returning like this. Okay, now the next thing is, what is the use of the shape function? Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it and we can change the values. Okay, even now we can access like a, no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is happening? Okay, so we can access individual elements of the shape tuple that is being written like this. Okay, like we use, like we access normal tuples. Okay, so we can, what we can do with this a dot shape, we can we can get the tuple, I mean tuple of row number and column number as an output. We can change the access, change the shape of the shape of the matrix with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in a data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all, so that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just, I mean, sorry, for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay,
Just a quick info, guys. If you're looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. Now, let's continue with the session.
okay, one thing, so you guys are acquainted with, I mean, you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back the zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's going to be
No.
one. Shape is always gives only the columns and rows here. The 0 will give the rows and 1 will give the columns. That's it.
With the column. So
Don't-
that is a
you
tuple
don't- you
basic,
don't-
right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
that
got
will be 0 1, like that. So it is an 1D tuple or 1D array, whatever you call it. Okay. So that's
Okay,
how it
thank you.
works. Okay, now we can have several more examples of np, I mean this shape function, but I am not going into the detail. But you need to remember one thing, you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3 3, it won't work because the size of the array is total of 6, right? So we need to have it multiple of 6 only. That's how we can break, that's how we can reshape. Okay, that's what is about this shape function. Okay, next is how to get total number of columns. Okay, so again I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay, so that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values, number of points needed, will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function, it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that, like a shape function. So I will put it right in there, but the only difference, it can be modified. Okay, so where were we? We were with this ndim, right? So how it will work? Ndim will return you the, it is not, I mean it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But ndim will return you the number of dimensions of the array. Okay, so if you see the ndim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2, 2 dimensions, right? So that's what ndim returns. Okay, ndim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So ndim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is the d type. Okay, d type is to give you the type of each elements in the array. Okay, in the numpy array, it will give you type of all the elements, and numpy arrays cannot be heterogeneous, it has to be homogeneous always. So numpy arrays will return you, I mean the return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, I mean sorry, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this t type function. Next is how do we use it for maths calculations. Okay, so any doubts till this part, till this d type? Now if I show you something more, say, okay, next is as I have created now array with like float numbers. So you see the arrays are, the d type is printed as float 64. Okay, so you have you got an array of, I mean the d type as float 64. Okay, so that's how this d type function works. Okay, so and numpy, as the name suggests, it is used for linear algebra. Okay, so numpy is used for number mathematics or linear algebra. So you won't be really having string arrays in numpy. Okay, so you won't be having it, that is not provisioned. So numpy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is numpy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this numpy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how numpy summation function works, and it can add up to different things. Okay. Okay, so sum will return you a sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there. Yeah, it works, right? Why it is not working here? Sorry, I haven't put it in a list. Okay, so now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5 10 2 3, that means 10 5 15 and 2 3 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few flavors in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out a and b for you. Yeah, so see, A and B are 5 10 2 3, right? If we do a sum with x is 0, that means it will do you a column wise sum. So that means 5 2 7 10 3 13. Okay, and if you go for a row wise sum, then it will be x is equals 1. So it will return you 15 and 5, right? So that's how this will work. Okay, add a row wise sum. That's how it will work. Okay, so that's what is the, so that's how this functions work. Yeah, that's how this numpy arrays are array sum function works. Okay, so that's how you can get the. Okay, give me a second. Yeah, Okay, fine. So this is not how it works, right?
Remove the
Okay, let
square
me.
brackets and keep only the circular brackets.
Sorry, no, not like that. It won't take it. Yeah, so x is 1, 5, 2, 7, 10, 3, 13. Yeah, got it. Okay, so two confusions were there. First of all, be like it, like x is 1, why it is not taking up? Okay, let me check for some example in the PPT. Doing some casual mistakes. Yeah, that's what I have written, right? So 0, 0, 0, 1, 0, 5. So it should be 0 plus 1, 5 plus 0, that is 1 and 5. So it's fine, right? 0, 1, 0, 5, so 1, 5. Yeah, correct. 0, 0, 1, 5, 6. Okay, let me copy this exact example, what it does. NP dot sum with x is 1 having some problem. Just give me a few minutes, I will do that. Yeah, now it is working fine. 0. Yeah, now it's fine. So now if I replace it with A, I replace with B, if I remove this, as those are already list, how it works. Yeah, now it is looking good. Again, okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem. I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So sum I will discuss it later. For subtract, we already have discussed. For this division also, it will work in the same way. Okay, what is it with someone? Sure. Check. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise. It will just take in two parameters and it will just divide to the numbers. Okay, row wise it will divide to the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics, the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay, similarly we can see the multiplication being worked on the same thing how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 1030, like that it will work. Okay, so these are a basic few functions that will be needed for our data science courses. And this expa, it will give you e to the power a. Sqrt, it is for square root. Np dot sign is for sign value of each of the elements. Np dot cos for cos value. Log for log values. Okay, so these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this numpy. I am showing that to you. So these are not really needed for being a data scientist, so you can just check these values. Okay, okay, next is the element wise comparison. So we have, so that's how element wise comparison does. So it will compare each and every element of the array with another one, and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you a output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np dot equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called, so it will give you a single value. Okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of false or true or false based on the comparison results. Okay, so that's how it is that's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now if we have already seen this sum function, right? So np dot
Arrays
sum.
are of different dimensions when you use equal, array equal or other things.
Sorry, you mean this, right?
Yeah, so no, I mean when you're doing an equal comparison, yeah, so how did it handle different dimensions of the arrays?
It won't handle, right? It will throw you an error, because that is how matrix works in real world, right? You
Okay.
can't compare, you can't add, you can't multiply matrices of different dimensions. It has to follow some rules,
Yep,
right?
agree. Yeah, I remember now.
Yeah, so same things will do it here. So for multiplication we have a rule, right? 2 by 1, if a matrix is 2 by 2, then the other matrix, the first one, has to be equal to the second one of the first matrix, right? So 2 by
Yeah.
2 will go with 2 by 3, not with 3 by 2, like that.
Yes.
So those rules will apply here. Okay.
Yep, thank you.
That is what the basic things of this. Okay, so np dot mean, max, these are there. np dot mean. So mean, median, mode, standard deviation, this thing you guys remember? Because these are heavy terms that we are going to use for rest of our sessions. Too much. We will use this.
Statistics, yeah.
Yeah, basic stats. Data science is all about that, stats and maths. If you are good in these two, Python is super easy to learn. It won't take you much. And you just need to incorporate the thinking, that how do we think as a data scientist. So these three are main things. Others will fall into its place. But if you have a good base in maths and stats, it will help you a lot. Okay, so what is it? Core QF. Okay, FF not. It's F. Come on. Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. I am forgetting this. If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array, so you can skip it safely. But again, that is a best practice to write it. Okay, so np.sum a will give you sum of all the elements, minimum will give you minimum, max will give you the maximum element, mean will be the mean of the elements. Okay, so mean means the middle element of the arrays. Okay, then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay, so that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay, so it will give you sum of all the elements, minimum of all the elements, max of all, min of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not, let's not worry about it. So except this, have all these things clear. So that's how it will work. Okay. Okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine, mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail. You can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay, okay, so that is like broadcasting. Okay, what is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay, yeah, axis won't work for this kind of cases. Yeah, okay, so let's say we have this kind of an array to work with. So the first array, if you see, the first array is of 3 by 3, right? So 1 2 3 and 4 5 6, it is in 3 by 3 array, right? The second array, if you see carefully, we have passed 4, 5, 6, only 3, 4, 5, only 3 numbers. So that array comes to be of 1
It's
by
2
3.
by 3. How is it 3 by 3?
Sorry?
You said the first array is 3 by 3. It is 2 by 3.
Oh yeah, correct. Thanks for correcting. Yeah, it's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3, 4, 5. Only 3 numbers are in there, so it is an 1 by 3, right? So now when you add it, if you notice it carefully, you will see the second row of the array is also getting added with the same number 3, 4, 5, right? So that's why it is coming 4, 3, 7, 5, 4, 9, 6, 5, 11. Okay, so how this is happening? This is the concept of array broadcasting in NumPy. Okay, so if you see in this diagram, what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down, it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. I mean, this broadcasting is also done for the subtraction scenarios also. Okay, so this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to a integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and it prints accordingly, right? So let's say for this Monty Python, we are going from 6 to 10, so that will take from P till H, right? Because 10 will be excluded. But when we go for -1, then we go from the larger number to smaller number, because as you know, for negative everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do a 6:10, that means that is from 6 till 10, like that indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1 2 3 4 5 6 and 7 8 9, if you go for A0, then it will print all the elements of the first row. And if you, so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking, okay, so these two things returns basically the same thing. Okay, so when we have A0, we return the first element of, I mean, the first row of the matrix. Okay, when we return A:1, what does that mean? Okay, so :1 is for the I mean, so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write :1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1 2 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and I mean list of lists. And the first one of A0, we are just simply accessing the first element of the first row of the array, first row of the 3D array, I mean sorry 2D array, and that's why we are getting 1 2 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see how what all things we can do. So a colon 1 extract till row equals 0. That means it is the first row that is reprinted, right? Now for the second part, if you remember the indexing and slicing thing, so the first one will account for the row and second one will account for the columns, right? So if we do colon 1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1 colon, that means give me all from the first column till last. Okay. So that's where we get this 1 colon will return you 2 3. Okay. Now if you remove colon 1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2 3 5 6 8 9. Okay, so that's how indexing and slicing works for numpy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So I will leave it up to you. You would need to answer this. Okay, so let me explain. This 2 colon means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only one row will get printed out, and we are giving colon 3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why colon 3 returns you 7 8 9. Now let me change it and see how many of you can answer. If we do it like this, what will be the answer? Colon 2, then 2 colon. For row it is colon 2 and for column it is 2 colon. So y3, y6 separately. Okay. So for row we have given colon 2, right? That means we want the second row, right? So colon 2, that means we want till the second row. So the first two row will come into picture, 1 2 3 and 4 5 6, right? Then we have given 2 colon, that means third element onwards. So 3 6, right? Okay, next thing is array manipulation. Okay, array manipulation is to stacking arrays. I mean, like, okay, so what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on two arrays and we are giving outputting a third array. Here also, we will almost do the same thing, but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so okay, the first function is concat. Okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally, and one is out of bound. It shouldn't be. Okay, we don't have any columns in here, right? So that's why column wise is not possible. But if we had 2D arrays, it will be possible. That's what I will create for you. It will be easier for you to understand. Yeah. So this is like column wise stacking, right? So this 1 2 3 in here and this 3 4 5 in here got concatenated together, formed a new row. This 4 5 6 and 5 6 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that, I mean, sorry, this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, Let me print this matrices for you. It will be easier. So see, the first matrix is 1, 2, 3. Second one is 4, 5, 6. When we do row-wise concatenation, right? We just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay. Now, if we go for column-wise addition, column-wise concatenation, then what it will do, it will concat the columns on its own. Okay. It will concat the columns on its own. Okay. So then it will give you a new row output. Okay. So that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in because this is column wise now. So that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay. So that's how the output array output will look like. So the columns will be concatenated to a row. Okay. So that's how this concatenation works. Okay. That's how the concatenation works. Okay. So this is what is about this concatenation property. Okay. Next is VStack and HStack for NumPy arrays. Okay. So what is VStack and what is HStack? As the name suggests, VStack is vertical stacking. Okay, and HStack is horizontal stacking. Stacking means the same thing as concatenation with a bit with just a small difference. Okay, that we will discuss now. So before going into VStack, what I will do, I will show you stack example. Okay, there is another function called stack in NumPy. Okay, so I will show that first. Okay, before going into this normal thing, this HStack and VStack operations. Okay, so what it will do for these two arrays only I will consider. So let's say I am stacking A and B with x is 0. So I am stacking A and B on x is 0. Okay, so it is not a list I should pass, it should be a tuple in here. Was what is happening? Okay. Sorry. This one is there, this one is here. Yeah. So this is how the stacking looks like. Okay. This is stacking horizontally. Okay. And if I go to axis 1, this is stacking vertically. Why the array is not changing at all? Have I changed it? No, right?
It is changed, Abhishek, for the axis one.
Is it? Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1, 2, 3, 4, 5, 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, now I'm having some kind of a problem in
So
here.
you're
Not
not
sure.
running it again. You need to run it again.
Yeah, I ran it, but still it is not working. Not sure why.
It's
But this is
working
not
for us.
returning in the proper stack also. This is not how it should return. That is again a problem. Let me try with 1D array once. 1 second. Yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay. So in horizontal stacking, we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking, what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see in the row equals 0, the output is 1, 2, 3 and 3, 4 columns. So the two 1D arrays have gotten into a sequence. Row wise they have concatenated. But when it is going for column wise, then for 1D arrays, it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay, this stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. Okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created, I mean, stacked array of its own, like of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay. Now here on the contrary, if you see the hstack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this h stack and v stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is okay, let me write it. So let me do it a bit clearly, give me a few minutes. Print vertical concat vertical stack. Okay, let's see the differences. Okay, now axis 0, axis 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1 2 3 2 3 4 concatenated in a same row, 4 5 6 5 6 7 concatenated in a same row. Okay, and return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row, and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased, and those elements are stacked into the columns. So 2 5 3 6 4 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things and these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for H stack, V stack, and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a missed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like. I will show you. Stack, forget about it, it won't work here. So this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4, are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4 5 6 and 5 6 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we are concatenating the rows to the entire matrix. So 2 3 4 5 6 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked in the rows at the bottom of the older matrix. Okay, for vertical stacking, it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation, it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about these four operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides. So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking and there. Okay, that is how it works. So that is not much used, column stack function. Pardon please. So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, I'll show you here. The syntax, how it tells is, for this split function is np dot split. Okay, it takes three parameters into account. First one will be a array, it can be anything. Next one will be index, this I will explain. The next one is axis. Okay, the array, the first one can be any numpy array. Okay, it can be any numpy array. Indices has two forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be, that array will be splitted from that row. Okay, splitted from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is axis, as you already know, that is having 0 and 1. That is the same thing as you already know. 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this a array. Okay, so print a, this will be our a array. Now what we will do, we will split this array. So a, the first second one I am passing an integer, third one I am giving it a column. So see what happened. I provided 2 as an integer value, right? So the array is split onto two arrays. Okay. If I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay. Why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here. So we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits. So the two arrays will be coming out. Now we are splitting it based on x is equals 1. So that means a columnar way. So we have 3 columns, so it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. Critical thing is coming up for you guys. Now let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay. So this is how it will differ when you pass this, like when you pass this pass a list to the integer value. So the array here will be split into 3 parts. Okay, and then those 3 outputs will be given. Okay, so in the list, the first one is an the first thing refers to the column. So the array will first be split into a colon 1. Okay, then the array will be split between these two numbers, that is 1 colon 2. Then the array will split for the last number, that is, sorry, the array will split into the last number, that is 2 colon. Okay, so this 3 thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has 3 elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these 3 parts. That's how split works. Okay, so this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now if we go for column wise, you see something different, right? So what is this doing now? Here everything is given for only row, right? But here everything is done for column. Okay, so see, the first output is 1 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay, so now if you see carefully, these are the splits that you got in there. Okay, 1 4 2 5 and 3 6. Okay, these are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into 3 parts like this. Okay, and then you concat the output of these 3 separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is. What is the advantage of numpy over list? Okay, so this numpy arrays consumes less memory. How? We will see in the next few minutes. Next is, this is faster. We will see an example that how faster numpy arrays can be. And next is more convenient. As you see in list, you didn't had all these methods, right? Sum, min, max, median mode, this concat, h stack, v stack, this all these methods that we have discussed till now. We needed to write those on our own. We need to do this on our own, right? So these are the that's why numpy array is more convenient. And as a data science, And someone was talking about pandas. If you know about pandas already, or if you have read about somewhere, pandas array is only based on numpy array itself. Okay, it is same thing. Okay, pandas array and numpy array will go hand in hand. You will see. Okay, so if you understand numpy array better, it will be easier. It will be cakewalk for the pandas part. Okay, so that is what is about this array part. Okay, that is what is about this numpy part. Without wasting time, I will go into an example first, then I will come to this one. Okay, example will be somewhere down there. Okay, this one. This is a quick example how it is advantageous based on memory space and how it is advantageous based on its accessibility time. We are having time near equals 0. Sorry for that. Let me increase it. We have another 0, another 0. Okay. So see, here is the example for memory size. What we are doing, we are defining a list, right? Range function returns a list, right? We all know. So we have taken a list here. We are getting size of 1, that is 1, and we are multiplying with len of L, right? So 1 is an int, so it will be, so what is why 1? Because L will return a range of range from 0 to 1000, right? L will return that, so 1 will be the element and it will be int, so that's why we have written 1 here, and we have written len of L. So that means L has 1000 elements and it will take 28 byte for each element to store from the list basic. You must know this, so that is why it is printing as 28,000. Okay, for that it is printing as 28,000. So for storing 1000 elements in a Python list takes up 28,000 bytes. Okay, whereas for a numpy array it takes up only 4000 bytes. Why is that difference? So as you know, a dot size is, what is a dot size? A dot size is the length of the array. A dot item size is size of the array stored in the memory itself. Okay, so size of the array stored in the memory, so that's what it gives us 4000. So that is coming as 4000 bytes. So why is that difference? Okay, why is that difference? Why is this huge difference? Now let's go to this PPT. So see, for numpy array, how we store, we directly store the data into the pointer. So forget about this dimensions, right? Focus into this data. So this is a numpy array where we have a data head, and the data head points to the data directly. Okay, data directly. So as you might have covered in the list basics, how lists are stored in Python is not directly. Lists are stored on some memory location, and that memory location is returned to the list element. So that's why that is an mutable one, because you and tuple is an immutable one, right? Because in tuple you can change the value because it directly stores the it doesn't have the memory address of it. It is an immutable one. But in list you will have the memory address stored in it. So whenever you access some element, it is accessing the memory location only, not the direct value. So again, that memory location will have a value. So for storing memory location, it will consider 2 bytes, and for this it will 14. So 14 by 2, 28 bytes for a single memory location it will have. Yeah, list will be having two step of data storage. So first one will be a pointer, second one will be a data. Okay, second one will be a data. And no, numpy is not immutable. Numpy is mutable. We have seen multiple examples, right? Numpy is not immutable. It is not because of this storage that is immutable or mutable. That's what is considered. It is due to some other features. This is just a language construct. So they have made tuple to be immutable, and tuple doesn't store it like this. Okay, numpy is not immutable. Numpy is based on list only, so it is totally immutable. But the storage of data is different. It stores the data directly. Okay, but for Python list, it stores the data in a two ways. Okay, so 14 by 2, 28 bytes will be taken up for a single memory location. Okay, so that's why that's what you saw in the example also, right? In a programmatic example you have seen it. So that is how it is beneficial from the memory location. Okay, now if you see, we are doing some xyz operations, that is adding to list, first adding to list and second adding to numpy arrays. The same thing we are doing. Okay, so here we needed to pass it through a loop, right, for adding. But here we don't need to do that. We can do a clear matrix multiplication by a plus b, and then we are returning the time difference. If you see the time difference here for numpy, for a normal list is 0.005. Okay, but for numpy arrays it is 0.000999, something like that. It is too small, because when I was doing it for 10,000 for my machine and configuration, for 1,000 actually, it was not even coming something. It was coming in a zero value first, not for 1,000. And see, even if you see, for thousand lists, 1,000 values in list and 1 lakh values in numpy array, still numpy is somewhat faster than list, right? If I do a 1 lakh in both, you will see that real difference. You will see it is 41% faster than a numpy array. Okay, now if I just reduce a zero, it is coming in the range of zero. Okay, that's how lightning fast numpy array is, because in numpy array the access is direct, right? So that is just going into the location, fetching the data and doing the addition or multiplication or whatever you want to do it. So that is what is being done in numpy arrays. Okay, that is what is done in numpy arrays. So that
But one
is,
question, like without
yeah.
memory location, how it identifies actually in NumPy array?
In numpy array, the object is directly stored in the memory location. Okay, I mean, in the RAM, right? In the RAM, in a block, it is directly stored. So numpy contains a data head that directly points to that memory location. Okay, but for Python, the items are stored in some other place, and the address of that place is stored in the Python's item head. Okay, so memory location is there for numpy array, but the storage is direct. It is one level storage. Okay, it stores the data directly into the memory location. So it is like in your RAM, in a RAM cell, putting in a direct value instead of putting in another memory address in your RAM location. Okay, so and in that memory location you will find the value. So that's how it works. Okay, so that is what the difference between this numpy storage and like a normal Python list storage. Okay, and for the,
And one more question: is it going to store it continuously in case of list and NumPy? How it stores? Is it going to store continuously, or in the list it will store randomly?
it will get the memory location from the address bus, right? Whatever it gets, it will try and store over there. So there might not be any other pattern, because how, because RAM, it anyways it won't contain lot of values, right? So it depends on the computer system, right? How it allocates the memory to the to the Python compiler, it will keep on storing like that. So you can't control how your, I mean, Python can't control how your system works, right? How the address bus or the how the CPU works, it can't control that part, right? So it based on the entirely based on your system itself. Okay, so we can't really comment on that, how it will be stored. So when you run Python program, if you want to know the backend, what happens, a request goes into your CPU sees if what kind of request it is. If it's a write request or a read request, it takes in the request, it sends into the processor. The processor then processes the request with the help of all the hardwares and the RAMs and all the address buses and the data buses that the computer is connected to. And based on their addresses and their availability and all, it gets written into the location. Okay, it is not really Python doing it. It's ultimately runs into your CPU only. So that's why having a stronger core is always important for data scientists. Okay, like stronger, I mean that processor actually. That's what. Okay, so that's how it works. Okay, so that's what is about this NumPy arrays. So let's get started with this pandas module. Pandas module is for data wrangling or data manging purpose. So what it can do, it can read you a file which will in turn and you can access the data in a lot of variety of ways. This will give you a label and all. So that's why pandas is used. Pandas is basically used for data manipulation purpose. Okay, it doesn't have any machine learning algorithm in this package. We just have the basic stats methods like mean, median, mode, correlation and all, interquartile ranges and all we have. And what we have is we have different functions for reading a file, different method for accessing different kind of columns and rows. Okay, we can do indexing and slicing on pandas, arrays and data frames. So we have different kind of scenarios. Okay, we can perform skill like operations in pandas also. So that's where it is beneficial, and it is basically used for data manipulation. So let's go ahead with this and see. So why, what is pandas? As I already told, pandas is a Python module. So that is open source one, obviously. So why Python is so popular these days for data science and other things is that it has a wide range of libraries, which helps you to get basically anything done in few minutes. You no need to write the codes from the beginning in order to get the things done. Okay, you will get many open source packages available in the market, and they will be absolutely free. No charges will be there for using those, so not an issue. So you can always use those packages. You can write it on your own, but I mean, when something is already developed for you, we won't be that won't be required, right? So you can use that package. Okay, you can use that package. So that is again a very big point for using Python for data science related applications, because when we cover the machine learning algorithms, if you see, for I mean, implementing a basic of it with some good amount of result, it will take a huge amount of time if you don't have the packages. So Python has those, and those packages are really easy. You just need to understand how the algo works and how you need to use it. Okay, you don't need to write the entire algorithm. So that's why Python is again very popular. And for today's pandas module, this has many functions, many things related to data manipulation and data analysis. So that's why we use it, and it's open source. That's the main reason we use it. Okay, so let's go ahead and let's see how this pandas works. Okay, how this panda was derived actually. So this panda's name was derived from the word panel data. Okay, what is word panel data? That was some kind of a tabular data that has multi-dimensional data in it. Okay, and it is kind of a time series kind of a data. So when I say a time series, what does that mean? That means, let's say we are having like male female ratios for last 5 6 years. Okay, or male female income ratios in last 5 6 years, the example that is given here. So those kind of data is called time series data. See, for 2013, for a female age 23, salary was 20,000. In the next year, it got increased by 5,000. Next year, 10. Next year, 7.5, like that. So this kind of things called a time series data. That I mean, where we have a series of data. So the state of the data differs with the time. So that's what is called a time series data. And this is something like that. So for while analyzing that, this pandas module was derived by this guy, Wes McKenney. It was derived in created in 2015 actually, for ease of use. And this is basically built on top of the Python list dictionaries and NumPy arrays and dictionaries. Okay, so that's how this pandas module was created, and these are some basics. So that's why you need to have your Python basics crystal clear in order to grab this pandas module. Now let's go ahead and see what are the features of a pandas module. Okay, first is series object and data frame. What does that mean? So pandas can support multi-dimensional data, 2D data, and one-dimensional data. All these three kinds of data are supported. Okay. So for 1D data, we have a series object. What is it? We will see that in a later. But for just for an review, just for an overview, series object, you can say it is a 1D array of NumPy. Okay, a 1D NumPy array is almost similar to the series objects. How they are different, what are different, we will see in a few minutes. Next is data frame. Data frame means a tabular kind of data. Okay, so it will have some labels for the columns, it will have labels for the rows. You can have it, you can create that kind of 2D data. So how it works, this is a tabular data, right? So this mpg, cylinders, displacements, horsepower, weight, acceleration, here those were stacked into columns, and all these rows have had indexes. Okay, so that's how pandas module can read the data. Okay, that's how pandas module can read the data. So that's where the data frame comes into picture. Data frame is basically for handling two-dimensional data, and for 3D data we have panel data, but we don't really use 3D data nowadays, because that's kind of things we still don't get. That is basically for videos and all, where we have layers of data, right? Pixels are layered, so those kind of data we don't really get it in data science. I mean, video analysis is only used for traffic police purpose, not much, and others very high-end jobs that will be using this kind of data. So for normal usage, we don't have it. So what we have is basically 2D data. So data frame is the thing that we are going to use more frequently, and series object is the next thing that we are going to use. Okay, this is for 1D and this is for 2D. Okay, next is handling of missing data. So what does that mean? We had some NA values in the data set, right? So we cleaned it. So how do we cleaned it? We fired up one command of pandas and it filled in the missing values with the mean of the data set. So handling of missing data is also gets very easy for using pandas. So that is again a good feature of pandas, which will give you a very handy functions to replace missing data or null data or the rows if they're not there having null values, any n values like that. Okay, we will see those shortly. Next is data alignment. For what this means how you access the data, how the data is placed in pandas data structure, that plays a vital role. Let's say for the Python, for the XLS file that I have shown you a few seconds back. So for that, if you had to have all the list, all 1D list stacked into different parts, and if all different lists for arrows, different lists for columns, so they are all pretty messy, right? And it will take a lot of space to store those data. Also it will be really hard to get the data, get the required data that you want to have, right? So that's where pandas makes your jobs super easy. That's where we use it. Next is group by functionality. So not only group by, we have group by, pivot, and all those functionalities is pandas module, which will help you to also join, merge, and all those kind of things are possible in pandas. So without having a database, without having a relational database, you can still perform this kind of operations in pandas module itself. Okay, so that's how you won't be able to write select queries, but again the data set, if you see, you can select the columns as you require, and all those kind of stuff is possible. Okay, so that's another good feature of pandas that we will be seeing in a few minutes. So next part is slicing, indexing, subsetting. As I already told, like this slicing, indexing, and subsetting is a core thing that pandas does. So because this is basically based on Python and NumPy list. So again, this is widely used, and this indexing and subsetting will be used a lot. Okay, so that we will see later on. Next, if we go merging and joining, I have already told. Reshaping means you might not need some columns, you might not need some rows, so you can drop those easily. You can reshape it. That will be pretty easier. Hierarchical leveling of access, that means you will have a properly defined structure of rows and columns. Accessing those rows and columns will be very easy, you will see that. Next is robust input output tools. What that means, input you can provide XLS, XLSX, CSV files, text files, everything to pandas. It will grab those and it can convert the data frames and series objects to Excel file also. Okay, let's say you are processing some data. Let's say we have a Titanic data set. We need to predict the output of who survived and who didn't. So you predicted the output, but you need to present it to client. How you will do it? You can just have that data from data frame and write it to Excel file, and you can show that to your client. Like let's say this is the data that I got. This was the training data. That's what I did. I have some algorithms behind. Those I am not gonna share to you. What I can show you is how the output looks like, and output looks like this. So what you will have all the columns in the train data plus the survived column to check who survived and who doesn't. Okay, so that's what is benefit of pandas. It can save the output files in one liner. You can just have a one line. You can select the data into Excel file, in a CSV file. You can also name the sheets, like which sheet you want to save. If you have more than one sheets in the file, then also it will work. You can read that way also, you can write that way also. It has very robust tools for doing that. Okay, very robust functions are there, where all functions are available, so you don't need to worry about it. File handling gets easy with pandas. Next is time series specific functionality, again that I told in the first step only, because this is the base of pandas. So from this requirement, this was derived, so this can always be done, right? So this is again a very good feature. Pandas versus NumPy, what is the difference? So see, NumPy, what it has homogeneous arrays, right? With 1D arrays with only numbers. But pandas, where they are preferable, when you have heterogeneous data. Okay, so let's say you want to accommodate strings also. It might be case that you want to have strings. You don't want to always convert it to numerical thing, but the reality is, for the features of machine learning, you will have it, but sometimes you will need to do a text processing also, right? Text mining also you might need to do before going to it. Let's say you have a very large description field, So you don't want to check all this, right? So you want to check for some specific keywords in that. So that's where this things comes handy. So it might be the case, the data set that you get, you have some comments filled in there and you need to analyze that comment. Let's say for Twitter, for sentiment analysis, you might need it. So that is again not data science, but that is a part of data analytics, but still somewhere you might get that requirement. Okay, so that's where pandas will save you, because in NumPy you won't be able to process the 1D, I mean the string arrays or more than 1D arrays. Okay, you can have multi-dimensional arrays, but again accessing will be difficult because it won't have named columns, named rows like that. So it will be difficult. So that is a real world case when you should use pandas, and when you should and this NumPy thing won't fit your purpose. So next thing is pandas perform better than NumPy for 500k and more. This is just a number. This is just a number. We will show you like why we are telling this. We will show you at the end of the lesson. So you will see an example like how much time and space it takes and all. Next is pandas series object is more flexible, as you can define your own label index. That's what I was telling. So you will have a labeled index for rows and columns that you have. So you're accessing your columns won't be always based on integers, okay? Whereas in NumPy, you always have integer positions, right? But in pandas, you won't have it. You can define. So you will see that how it works. You will see that. Okay, so that is what is about pandas. Now next is how to import pandas in Python. So you can write this function import pandas as pd. So that will import pandas for you, and it will have an alias name of pd, which you can use it in throughout your code. You can give anything as alias, but pd is short and so short and sweet. So you use it. So you need to refer pandas module by using pd dot like that. Next is what kind of data is suitable. So as we already discussed, tabular data, arbitrary matrix, any matrix can suit this, right? And you can change these indexes and columns. And time series data. This was what I was talking about, time series. So see, a series of time will be given, and based on that, the changes of values will be given. So this kind of data suits pandas the most. Next is data structure in pandas. Before going to that, I will show you how you can install it. So in Anaconda, we will by default be having this pandas module. Okay, we will by default be having this pandas module installed. In that case, you won't be need to install pandas separately. But if you are having standalone Python installation, then how you can do it is you can use this command to install pandas. Okay, if you are having any standalone distribution of Python, not the Anaconda one, then you can use it. Okay, so you need to set the path for this pip command, and then you can install pandas. Okay, so that's how you do it. So that's what is about this pandas things. Now let's get started with this data structure in pandas. This I have already told. So in for one-dimensional data, we use series object in pandas. Okay, we use series object. For multi-dimensional data, we use data frames, and for 2D data, actually, we use data frames, and for multi-dimensional data, we use panel data. So this is not in scope. This we don't use it. So it's very rarely used, this panel data. So we will concentrate on first two, series object and data frame. Next is what is series? Series is a dynamically labeled one-dimensional array. You can think it like that. So it can contain similar or mixed type of data. That doesn't hurt. Okay, you can have any kind of data in there. So see here when we have, okay, so how do we create series object? We used to use this notation. Okay, so pd dot series, within brackets we need to pass in the data type that we need to convert to series. Okay, let me show you what happens if we pass 2D arrays. So see here what it will do. This will convert your data, whatever you pass it, to a series object. Okay, what is a series object? That means it will label your rows using integer indexes, and it will give you the data. Okay, so if you see, when I provided only one list, so what it did, it converted this list into a series object, and it had 1 2 3 4 5 written separately. But when we provided two lists, right? So our expectation was to get a two-dimensional matrix kind of thing. Instead, what it did, this series object taken those list as an individual element and columns. It put in the column values, and it provided indexes to the rows, right? So series object is strictly for 1D array. If you, even if you pass 2D arrays, that will also be changed to 1D thing. So series object is always used for 1D kind of an operation. So always keep in mind, don't confuse it with the data frame, because we are going to see data frame next. So they will look the same, but it is not same. Okay, so this thing you need to remember. Okay, now if you see the type of this series, if you see type of this series object, you will see it will be pandas.core.series. So that's where it comes handy. Okay, so you can check it like that. Next is the series object is done, so it will be of type pandas.core.series.series. Okay, so that's how it will work. Next is how to change index names. Okay, this was what I was talking about. So that means, like you saw, we had the 0 1 2 3 index kind of, I mean integer kind of labels attached to each row, but now you can change it to anything. How do we change it? You can, when converting this array to a Python series object, you can change it here. Okay, you can pass in a list of names here. Okay, so we have 5, let's say we are providing 4, and if we run it, see here what is telling, length of pass value is 5, index implies 4. So what it will do, the list of index that you give, it will map it to that, those indexes. Okay, the index that you give, those will be the label for the row, and that sums this up. So this one will be mapped to each of the rows. So a b c d e will now be the row objects. Now if you try accessing this, so this will work. Okay, srs a colon c, now this will work. Okay, this will return you the return you the values that you have. Next thing to remember, when we are using string based indexing here, it won't be excluding the right hand side. Okay, because it can't, right? But if you use string, I mean integer based index, the right hand will be excluded. But for this kind of things, this kind of string based indexing, it won't be excluding that. So that's how it works. Okay, so renaming is done. Let's see how we can convert all these three types of data into scalar. I mean, two series objects. So we can convert this array to a list, dictionary in the similarly you can do scalar data also, you can do it. Okay, similarly this dictionary will also be converted, and scalar means a simple 1D thing that is also been discussed. Okay, so now the series part is done. So what is pandas data frame? That is basically a two-dimensional labeled data structure with columns all of potentially different types. That means any tabular kind of data which will have 2D data, I mean two-dimensional labeled data structure with columns of potentially different types. What that means? That means you will have row labeling and column labeling. Okay, so this column labeling, so you can use it instead of 0 and 1, you can have labels for columns also, and those columns can contain different kind of values. Okay, one can have string, one can have int, one can have float, anything it can have. So that is where data frame comes into picture. Now why data frame? Data frame supports different type of columns that I just told, right? So you no need to have, I mean you no need to have a single, I mean one only homogeneous data when you are using this, when you are using data frame. Okay, so that's where it helps you in getting in getting things done easily, right? Because when you are reading an excel file, you can't expect that everything in there will be of some of the same type. It can have different types of data, right? So that's where this data frame comes handy. Next is mutable size. That means you can change the size. It is not immutable, it is mutable. So you can change the size and shape of the data that you get. So you can drop, you can create extra columns, you can drop columns, you can drop rows, and everything you can do with this data frame. Next is labeled access. This has already been discussed. So arithmetic operation in rows and columns. We will see how you can get meaningful information from the pandas package, pandas data frame. All the stats information that we saw in the last classes, like in the SciPy that we have seen, in the NumPy we have seen, we have same set of information available through this pandas object also, because this is basically built on top of this NumPy arrays only. Okay, so you will see how you can do this. How to create data frame? It is the same way, pd.dataframe.data. So list, series, numpy, nd, array, dictionary, anything and everything can be converted to a data frame. Okay, now let me show you again. See now what is the difference from series and what is difference from the difference in this. You have a indexing column also. Now let's try this. See here what is happening. So as you have provided two columns with different set of values, that's why it has put in none, nan, when it didn't find any values. Okay, so what you had 5 columns in here, right? You have 3 columns in here. Let's say I am changing it. So you provided 3 in the first one, and 5 in the first one, 3 in the second one, right? So when it tried to map the second row of the data to all these 5 columns, like in the first row it had 5 columns, right? Because you have specified 5 values. So in that case it found 5 values, it printed all those out. In the next row, when it had 2 3 4, it tried to map all those to 5 columns, but instead it found 3 values. So what it will do with the rest, it will put an NaN in there. So that's how this pandas data, I mean this 2D arrays has been mapped to a like pandas object. Okay, now let me change this to dictionary right away. So here if you see, I have put in a dictionary, right? A and B. So A, B are converted to columns and others have been changed to row indexes 0 1 2 3 4, and the values are mapped to this columns only. Okay, values are mapped to columns only. So that's how this thing can be that's how this thing can be changed. The dictionary is changed to this kind of a 2D data frame. So that's how dictionaries can be changed. So here what it will do, this there are 3 values, right? So it will convert to 3 columns, and here we have only one value, so the other columns will be converted to NaNs. But here we have 2 columns with 5 rows, so that's why it won't be containing nulls, and you need to provide both this value part to be the same size, otherwise it won't be converted. You will see some kind of value error. So that's why. So this if you have 3 values for the second one, that's what I just explained. So what is happening in this case, it is taking 2 columns, right? And it is filling out rows. So while filling out rows, if it doesn't have the matching number of columns, I mean matching number of values in the columns, it will throw an error, right? So that's what it is doing. So it is not, now it is filling out rows, it is not filling out columns. So you need to have full columns in order to provide the values. Earlier it was taking into account the column values where it put in null, but I mean NaNs, but here it is filling out rows based on these A and B columns. So that's why it should be equal. That's why it should be equal. So that is the concept. So we don't generally have this kind of values. We have, I won't say we don't have, but we don't have generally this kind of values for dictionary. I am just showing it for illustration purpose. So for filling rows, it can't fill in names because we don't know it. So that's how it works. This is a real world thing where we use this dictionaries. Okay. So for fruit we have some values, and for count we have some values. So that means we have 10 apples, 12 mangoes, and 13 bananas. In that case it will show up nicely. Okay, the example that I have taken, it is something else, that's why we use it. So basically this column A is a series, column B is a series, and this entire thing is a pandas data frame. Okay, so individually all the columns are a series object. So when you get into this kind of a zone, you will be using the renaming of index. So here you can change this index name A to a fruit or something like that. So that's where it goes. Okay, we will see some examples on that also. Okay, so this basically sums this up. So this is for converting series objects. See here we are providing names separately. So you can give names like this. So what we are doing, we are creating a series object with A and B name, and then we are passing it to this df, and df is having this AB612 values. Okay, like that. So numpy arrays also you can pass it to there. So 2D arrays I have already shown. It can be of different types in here. So this kind of dictionaries you can put. So that also I have shown. So that's how this works. Okay, that's how this data frames can be created from variety of things. So that's how you can convert different kind of data types. Whatever you see in and around Python and in and around this NumPy and SciPy, you can convert all of this to a all of this to a data frame. Next is this inner merge, inner join, left merge, left join, outer merge, outer join, right merge, right join. So this is basically to concat two different data frames. No need to worry, we will see all these examples in a few minutes. Okay, we have a separate section for this. Starting from this slide, you will see a lot of examples. How do we use it and how do we do that and all. So plan is to have it after the break, or let's see how it goes. Okay, so till this slide, any doubts you guys have, or we can proceed. I think I have answered most of the questions in chat. The chat window is really small, so if I missed something, just let me know. Okay, I can repeat that also.
Abhishek, can we rename the index of rows? That is by default is coming like 0, 1, you know? So can we rename it?
Yes, but that's of no use, right? So you will, when you are accessing the Python object, you will max of the times you will use it based on columns only, right? Rows are not that much used, but you can do that. That's an option. Okay.
Okay. Okay.
But just think of it. Do you really need to rename an index, or 0, 1 is perfect, right? Columns are fine. Columns you will need here and there. So I can show you also. That's not a problem. So you can, okay, let me show you. You can pass in a dictionary actually, and you can do it. I will take a small example. I won't do it big one. So what I am doing in data frame, we have a thing called columns object. Okay. So when you do that, like when you check, I mean, when you after you create a data frame, you can access the columns of the data frame by using this keyword df.columns. This is a cheat code. So that is a list. Okay, and this is mutable. So you can assign the number of that values you want to specify for each columns, and it will be renamed. Okay, so this is a mutable thing. So that's why this way it can be used. Yeah, so that's how you can change the column names. Okay, so this is how the syntax is. So the thing is, if you want to change the indexes of a row, if the row labels you need to change it, then what you need to do, you need to pass in the 0 and 1, that is the row indexes, and create a dictionary. You can pass it in the index parameter of the df.rename thing, and there it will be changing the rows based on the it will be changing the row indexes. Okay, but if you want to change the columns, then you need to pass in index equal to string or int, something like that. So this index will contain this index. Okay, the row indexes, this will contain the row indexes. Okay, then you need to pass in columns list. So this becomes same as this df.columns equals list, or columns equals a dictionary, the older name and new one, and the new name. Okay, and then this in place equals true means it won't be creating a new one, it will replace that existing thing. Okay, so that's why in place equals true, and then if you execute this, so it will rename the columns. But in real world, using this one is really easy and really helpful. So what you can do, if you I am not going into map now. If you use map, it gets easier. So for call in df dot columns, if call equals let's say 0, then you change it to will be a here, right? So if it's a, then have it call equal to b. So if you run it, this will this will change the column value. Now then you can go back and assign this column value to this df dot columns. You can create a list here. You can assign that list to df dot columns, like that you can do. Okay, so that's how you can do it. So you need to take another list. Let's see, call list equals this. So after you come out of the for loop, you change it to, let it be a, let this rename first. See, now a converted to b, right? So this is the best case where you can use. This will get clumsy as the number of columns grow in. You need to remember all, you need to rename all, so this will get clumsy, the syntax will get clumsy. But in real world, how I use this one. Okay, so that's how I use it. So this is the this is how you can do it in real world. This will be easier, right? As you can see. So if you want to change it, this will be much easier for you. So it can be anything. Okay, so 0 1 2, and you just check the conditions, you can change it like that, you can do it. Okay, so this is just to show you how it works. Okay, so that is what is about this row and column accessing. So now next thing is what is inner join. Inner join is joining two tables based on the common column, and the common column will be absent in the resultant value, right? So that is what is inner join. For right join, what happens? The right side table will come in entirely, and the common part of the right side table will have and will be coming entirely in the result, and the non-matching values of the left side table will contain null values. Okay, left join, it will be just the opposite. Left hand side table will be coming entirely, and the non-matching values of the right hand side table will have null values. Outer join, it will have all the data of all the tables, and whatever is not matching, it will put on null, right? So that's what is about this joining. Okay, so now all this can be achieved using pandas. So see, this concat thing that is being shown in here, I will show you with an example. So the concat thing that is being shown here, so that is something like, okay, so that is something like outer join. So that's what concatenation does. Okay, concatenation, what it will do, it will concat all the data frames that is passed as an object to it. It will be taking all those, and it will merge all those three data frames. Okay, so that's how this concat thing works. Now for right join and others, what I showed, so that will work similarly as it works for this one, right? So for that, we need some good kind of data sources. Let's say we are creating, I will keep it short, I will keep 2 columns only. What do we have here? This is my first DF. This is my second DF. Okay, we have a common column of A. We have a common column of A in there, right? So if we do concat, let's see what happens. See here what happened, it just concatenated the values, right? The C column in the first table is NN, so it has put in NN there, but B column in the second list is NN, so when it concatenated the second one, it passed in NN in there, right? But it has kept in the entire syntax perfectly, right? Entire values are kept perfectly. So that is what happens when you use concat. Okay, so concat is kind of a inner join. Okay, concat is a kind of inner join. Concat is kind of a outer join. So inner join, if I now show you what we need to do, it will be done using this concat command only, and we will have something extra. So we will pass in the axis value. Okay, so axis means the column, one means the column, right? So we will pass in and we will type what type. This is now inner join, right? So A, B, A, C is there and all the common values are present only. The values where it was not matching, those are removed, right? So this is what is about, oh sorry, axis one means row, right? So if you use using columns, then only the common column is came out of it. So between A, B and A, C, only A is common, so A column is came out. So we are passing 0, right? 0 means the row wise and 1 means column wise, right? So we have passed in 0 here, so we are getting this kind of a result. So this has joined it row wise. Now if we do it using 1, so it will just concat those rows, right? So that's how it works. Okay, so 1 2 3, the first data frame was 1 2 2 3 3 4, second one was 3 1 4 9 5 10. So here 1 2 3 1 2 3 4 9 3 4 5 10, it has concatenated based on inner join principle, right? So this is I mean this follows the basic rule of inner join, but the difference is, unlike inner join, it won't give you the exact format of output. So for that we have some other things that we really don't use here. Okay, we use it but we really don't need that for now. That is when we do, like when we access the RDBM is kind of data, right? So then we use it, and then this kind of things are there. So you can there is an SQL utility in Pandas, so where you can pass in exact SQL statement that we have, and you can concat, inner join, merge data set based on those principles. Okay, based on those based on the query outputs, you can merge and inner join those. So that's how this kind of thing works on. So there is another thing. So these are not really used. Okay, joining data frames are not used, or you always will be concating only. Concating or merging things, you will do that only. Okay, so that's how it works. So that is what is about this concatenation thing. We have another thing, that is merge. Now see this will work as a exact SQL join. This thing will work as a exact SQL join. Okay, so how it will work? It is not concating, it is merging the data set. See what is the error here? Key error A, right? Why key error A? Because it tried to join this two data set with column name A, but in the second data set we don't have A. So that's why it threw the error. So what I did, I renamed this column to A. Now I'm coming and I am merging it. See, it works, right? Now if you match it, it is the same output as you do in SQL join. If you do create those two tables in DB, if you check the output, now it will match. So concatenation will give you the result that will look the same as SQL1, but it won't be similar as SQL joins. Merge will give you the output that looks like the SQL joins, and it will be the same thing as I mean, it will be working similarly how the SQL joins work. Okay, I will just quickly write these things, all the different kind of joins that we have. Now if you compare all these outputs, right, you will find it that it looks like, see this concat value, how it looks like the first one, right? Like the first output that we saw. So that's how this outer works. So that's what is the difference between merge and concat. So merge will work similarly as SQL joins work, but concat will give you the output that is based on the principle of those, but it won't work like that. So that depends on the scenario. If you are working with this like that database, RDBMS kind of database, then you can go for merge. Otherwise, you can go for concat. So it depends on your need and your scenario, how you are using it. Okay, so that depends, entirely depends on the scenario. So that's how it works. Okay, so see here, this when you are wanting to join two things, where you want the common values only, you don't want the entire thing, then you go for merge. If you want the entire value or not only the common values, go for concat. Okay, so that's how it works. So you need to decide based on the scenario that you have. So that's how the SQL joins work. So if you do a inner join, then wherever it gets a matching value, it will take those into account. So if you see 1 2 2 3 3 4 3 1 4 9 5 10, and then we are joining on column A, right? How we
Yeah.
are joining? We are joining on inner join strategy. So which value of A is matching in both these columns? 3, right? So what will be the output? 3, 4, and 1, right? So if you see the output, what is that? 3, 4, and 1, right? So that's how inner join works. Inner join will compare the values of two columns, and wherever it matches the value, it will take those columns from both the tables, those values from both the tables. So that's how inner join works in SQL, and that's why the output is 3, 4, and 1. Okay, so next part, what we will do, we will see all this thing coming into life. So till now, I was showing you some fake data. I was just taking something out of my mind and I was showing you. So what we will do now, we will see how the real data works. Okay, we will read a CSV file that we have. First, I will show you about the file, how the file looks like and all. Then I will show you what all things we are doing with it. What all things we are doing with it. We will see data cleansing. Then we will see the analyzing the basic stats. How can we take out the basic stats out of a pandas data frame? So this is some kind of a cars data set. You can have it from net also. If you are not getting it, you can have it from net also. So this is a cars data set. Okay, you just type empty cars, you will get the CSV file out of it. Okay, so in this cars dataset, as you see, we have a few columns, right? We have 13, 14 columns, and in that we have serial number. The next one is blank, it is not named, so it doesn't have any name. Then we have MPG, SIL, DESP, HP, DRAT, WT, QSEC, PS, AM, gear, and carb. Let's see what those mean. So MPG means miles per gallon, right? So that is the mileage of your car. Cylinder is number of cylinders that your engine has. Displacement is again the displacement of the car, that is of disp. HP is gross horsepower. Drat is rear axle ratio. Okay, so in the rear tire, the axle ratio. W2 is weight of the car. QSEC is 1/4 mile per time. So that is what is, I mean, for 1 mile, the quarter of a mile, how fast your car travels, that is QSEC. VS is engine, V-shaped or straight. AM is transmission, automatic or manual. So for 0, it's automatic. For 1, it's manual. Gear is number of forward gears. Carburetor is number of carburetors. So that's how this data set looks like, and this is the data dictionary for that. So you can easily get this from net. So that's how it works. So that's how the data set looks like. Okay, now what we will do, we will read this file and we will do some kind of cleansing and all. So before that, let me show you in Excel only what kind of values do we have. We have all proper values in serial number. We have all the names, we don't have any nulls. MPG also the pretty same thing, it's good. MPG also, cylinder also is there. Displacement also is fine. Horsepower cross doesn't have it also. Okay, so it is fine. Okay, for QSEC, see, we have a few blanks. For QSEC, we have some blank values. Others, it will mostly have some values. So 3 rows, we have blank here. Okay, so we will see how we can, what we do with this 3 rows and what all we do with it. Okay, so let's go ahead and let's jump into the code. So closing out this data set and see here what we are doing. We are reading a CSV file. So for reading a CSV, we have this command of read CSV. Okay, for reading a Excel in pandas, we have a command of read Excel. So if you do it like this, then file name, then sheet name, it will be reading that Excel file with the name. So the format will be XLS or XLSX. Okay, so that's how it will work. So you need to pass in a file name and sheet name. If you don't pass the sheet name, the by default the first sheet will be read into account. For document, what is that? The doc file you mean? Doc file, you won't be getting that kind of data, right? So when you are analyzing some kind of data in here, so that will be in tabular format. That's what is the basic requirement of pandas, right? So we covered this in the first part only, and in data that will be text mining. That's the whole separate thing. So for pandas, the only fit in thing will be tabular data. So we covered this earlier only, right? What is the scope of it? Okay. So see now what is the output here? Only the column for which name was not mentioned. Pandas has renamed it by its own, on its own to unnamed :1. Okay. Others are fine. Now if you see this data set, our first task will be to rename this data. Okay. So this is just to show you how you can change the data type. Okay, so you can it's an optional step. You don't need to do this. This is just to show you how to convert a data type. Okay, so for mpg we are converting it to string. So how we are doing, we are writing cards.mpg equals cards.mpg.s type, within bracket we can give anything. So here if you see mpg seems like float values, so we can't convert it to int. If we do it, we will lose the information. So we are converting it to string. So that is not required. This is optional. This is just to show you how it can be done. Now we will see some few analytics functions. So type cards you already know. This is a data frame. Okay. Next is how do we see first 5 rows of a data frame? We use cards.head. So head will by default return first five rows of a data frame. If we want to have first 10 rows, then we need to pass in the number into the head function. So 10, 12, 20, 30, 50, whatever you do, it will return those rows from the top of the data set. If you want those many rows from the bottom, then you need to use tell function. Tell will work as similarly as head. It will just start from beginning or from the bottom. Okay, so that's what the difference is. Others will work as same. So tell will return you by default bottom 5 rows. If you mention a number within the tell function, it will return you those many number of rows from bottom. Okay, so that's how cards.tell works. Now to check the shape, same thing, cards.shape, as we have seen in the list and numpy arrays. So this shape object will give you the number of rows and number of columns. So see here, it's a really small data set with 32 rows and 13 columns. Okay, that is how you can take out a shape. Now how do we print how many objects are there in the columns actually? So here see, we are doing cars.info. That means if you run it now, you will see the only non-null object counts that are there. It will be printed over there. Okay, so those will be printed in there. Okay, so all these columns will be printed like how many non-null values are there. So see, only the qsec column doesn't have 32 non-null values. It has, that means it has 3 blank rows. We already cross-checked this using from the excel only, right? Shape is for returning shape and reshape is for changing the shape, right? So that's what the difference between them. They are whole different functions, shape and reshape. Anyways, no comparison can be done between those actually. So for the info, we will see how many non-null values are there. So this is the first point you need to hit as a data scientist. Okay, others that I have shown, just know that those can be done. Those can be done in that way. Okay, you can see first 5 rows using head, last 5 rows using tail, like that. If you need to see more than 5 rows, then you can mention the number from either from the top, then head. If not from the bottom, then tail. But as a data scientist, your job begins now. So you need to check if any of the columns have any missing values or not. So that's where this cards.info thing will come handy. Okay, so here see in qsec we have 3 null values. So your first thing you need to remember is you will need to replace the 3 null values of qsec. How we do it, we'll show it to you. Next, a few basic functions like to find out mean, median, and other basic stats: standard deviation, cars, minimum value of car, maximum value of car, and the count, how many non-null values are there. Next is count of non-null records. This is also another thing where you can see that. Okay, where you can see that. So that is here, if you see the qsec column value, then it will be 29 only, right? It will be 29 only. So this is another point from where you can understand like how many non-null values are in there. Okay, so that's how you can do it. Next is how to get all this information stacked in together. So this is cars.describe. So that is the data frame name dot describe. What it will do for you is it will sum up all the stats that we have seen till now in a single place. Okay, so for if you check the output carefully, it has count, mean, standard deviation, mean, max, and all those kind of values, right? All those kinds of values it will print you it will be printed over here, so that you can get all this information at a single place. Okay, so the function for that is car.describe. So that's how it works. Okay, that's how this function will work for you. Okay, that's how this function will work. Okay, next is cleaning. Okay, so cleaning, as I told you, like this one column is there in the data set which doesn't have a proper value, right? Which doesn't have a proper column name. So for that, what is happening? For that, we are renaming the column. So see, now we are doing cards.rename, then we are passing in the same way that we did in the earlier example. So we are checking in we are getting the cards.rename function, then we are what we are doing, we are passing the columns dictionary which will contain the old name and the new name of the of the row of the columns that we want to rename, right? So that's how we are renaming the unnamed one column to model, because if you see carefully, that information that is there is model name on, right? So that's why we are renaming the column with the name of model. Okay, so we are changing the level of the unnamed column to model. So that was the name. Okay, next is filling in missile values. So which column had null values? As we know, QSEC column had null values. So we are filling the null values using fill na function, and what we are filling with? We are filling with QSEC.mean, right? We are filling it with QSEC.mean. Okay, so that's how we are filling in null values. Now after filling the null values, if you check the data set, it will be fine. It won't have those extra, it won't have those null values in place. Now next is dropping unnecessary columns. So you can understand the first one that we have, the first column, that is serial number. So what is it? The serial number is nothing but a straightforward EP series actually, right? So it is just having some numbers from 0 to 32. So when you do a data science related thing, this kind of data won't help you, because what you will get from the serial number, it doesn't have any pattern, right? It is just a EP series. So you can safely remove it, because for data science you won't need it, right? So that's why we have removed the column using cards.drop. So in these columns, as you can see, it is a list. You can have more than one column name also. Okay. For here, we are using only one column name to remove, that is S number, the serial number. But you can use more than one column name in the column list also. Okay. In the list, you can pass more than one values to remove those. That's how you drop the column. So now the column, the serial number column is removed, and we are left with 12 other rows. Let's see what we do with this 12 rows. Okay. Now next thing is correlation. Okay. Correlation in statistics means how do we like get, how two columns are mutually related. Okay, how two columns are mutually related with each other. It is the dependency between two columns, that is what is correlation. So how you can do, you can specify the column names among which you need to find the correlation. Okay, so here we want to see correlation of one column to all the other columns that is present in the data set. So that's why we have passed in all the names. Okay, all the names within the second bracket. So that is basically slicing, right? That is slicing. We have passed in a list of columns inside the data frame. So it will provide you all the values of the columns, and it will calculate the correlation using the CORR function. Okay, so we no need to find out, but it will find it on its own with you using with this CORR function. So that is basically correlation function. Okay, now next what it will do, if you see the output carefully, the diagonal elements are all one, right? The diagonal elements are all one because the name of the columns are matching. MPG, MPG, cell, cell, desp, desp, HP, HP, like that. So here the value will be maximum, right? Correlation between the same column. So MPG and MPG will be maximum. That's obvious, right? So where you have the correlation value generally runs from -1 to +1. So that means if the value suggests if the value is negative, then what that means is the columns are inversely related. If it has a plus value, then it can be thought of as the columns are strongly positively related. Okay. So here if you see miles per gallon and number of cylinders is inversely proportional. Okay. So that means to have high miles per gallon, we should have less number of cylinders. So that is also explainable, right? So that's what happens. So if you have more than one cylinder, then the miles per gallon will reduce, because your car will consume more petrol, right, to go the same distance, like that. Okay. So this way you can see all the values are printed. Wherever you see a negative values, that means those are inversely proportional. Wherever you see a positive value, that means they are highly proportional. So for displacement and cylinder, see, there is a high correlation. Okay. For HP and cylinder, there is a high correlation. So positive and high is strong correlation. Okay, that's how you can use this correlation matrix. So what kind of thing it will give you? So if you have any data set and you want to check how many, if there is any relation between two features or not. Let's say let's go to a real world example. Let's say we are going to predict the housing value. Okay, so we have square feet of area, we have garden space. So higher garden space means the price will be higher, right? But if you have some unnecessary column in there, let's say we have a column called this is something which is not necessary to calculate the price. What can be? Let's say main road facing or not will be a factor. This will be a factor. Let's say, okay, any obstacles are there or not outside the house. Yeah, wall paint is there or not? Wall paint is not. So if wall painting is there, that means the price will higher. So let's say if the values, I mean, let's say if there are any obstacles surrounding the place, so this kind of things, those are unnecessary things. Yeah, gate size, right? Gate size is a good one, Anmesh. So let's say if the gate size is bigger, then the price will go high, but that doesn't mean, right, I won't go there. If someone is charging me for their society gate, I won't go there, right? So those kind of things you can remove from there. Okay, if you have zero correlation or very small correlation, then you can remove those. So very small means in the terms of double zeros. Okay, 0.00 then something, you can remove that. So if it's less than 5%, you can remove it. That's safe to estimate, but you can remove it otherwise also. You can remove those from the equation. There are a whole lot of scenarios that we will discuss when we go for machine learning. Okay, so that's where you can use this correlation matrix. Next is we are again here changing the null counts to float. This is just we have converted before to string. That's why. Otherwise it is same. So here also we have changed the QSEC. We have filled in the QSEC, right? So the QSEC column that we have is now having 32 non-null values. That means all the columns that were passed in, I mean all the columns that are there have exactly the same number of values. So that means that part is removed. Okay, that part is by now removed. And QSEC has all the required kind of values. Okay, so that's what is can be seen from there. This is a repetition. Okay, next is manipulation. So in manipulation, what we will do, we will see how to access the data. This is almost the same thing as we do in list and numpy array. So I will just quickly go through it. The only new thing you will see here is iloc. Iloc is nothing but indexed location. Okay, so as you know, we can access the columns of a data frame using names also. So if you use iloc, then the indices that you pass in will need to be only integers, strictly integers. Okay, but this is not really used. What we use is this one. So that's how this iloc is used. Okay, so all these things will be integers. And then if you when I tell integers, it will be applied to all the like those indexing and slicing techniques that we have seen till now. Okay, so that is what ilog. So if you check the outputs here, 6 colon 4 colon, that means from 6th row onwards, and 4 colon means 4th column onwards. So like that it will match. So ilog is the same thing as what we have in indexed arrays. It's the same as indexing and slicing of an array, right? Of a list or an numpy array. So next is slicing by label. So here you see we are passing the labels. So that's how we use it. So we want all the rows for MPG column. Okay, so we want all the rows. We want first six rows for MPG column. Okay, so this is again the same thing, slicing and indexing. So that's very much sums it up. So it is the same thing. You can see. So MPG to QSEC, we want all the columns and the 6th row on, and for the first six rows only. So that's how it works. Now next is how can you change the column values. So you can access the columns using this syntax also. Okay, so you can write the data frame name, then within brackets you can pass the string headers. Okay, so am is am drat wt qsec, you can pass it here and you can access it. So no need to use cards.ilog or log and like that. So here we are using loc, that's why we are passing in mixed of string and integer. One thing need to be remembered, and for ilog we can only pass the integers, either all the two parts of the indexing for row and column both need to be integer. For loc it can be anything. Okay, and to access a column we can use it with a label only. Okay, we can use it with the column label only. Okay, so here what we are doing, we are changing all the am values to 1, just to show you how to do it. Okay, so we are changing all the values to 1 in here. Now next is often you might need to find some derived columns. Okay, next is applying this lambda function. We ran it, that's why we were getting all the values as 2. So this is applying lambda function. So this is just to get some derived columns. Okay, this is okay. VS is a good example. I will show you. So cars for bracket condition I want cards of VS equals 0. Now it will show you all the values where VS equals 0. It will show all the values where VS equals 0. Okay, so that's how you can use filtering. That's how you can use. If I haven't applied lambda function yet, I will do it now. So this is what is about lambda function. So that means what this means is we can find out some derived columns also. Let's say we are not keeping the name as am, we are changing it to 2am. Okay, so that's how we can do it. So we can apply any function on the column also to get a new value. So what we are doing, lambda x equals x star 2. Then what we are doing, cars am dot apply function f. So it will double all the values of the am column, and it will be double to 2. Okay, so that's how you can apply lambda function to a data frame object or any column of a data frame, more than one column, or you can find out some derived column also. So see, now we have applied the lambda function to this am column. Am was 2 from 2 to am value was 2, and 2am now contains 4, right? So that's how you can do it. I created a new column named 2am, so it will, I intended that, that's why it got happened it, right? Next is sort by values. Okay, so this is how easy is to sort a data frame in pandas. You no need to write a sorting algorithm and all. So cars dot sort underscore values, if you provide by equal to any name you provide, it will be sorted based on that column name. Okay, so here we have provided cylinder, so the column will be sorted based on cylinder, and you see 468, that's how it is sorted. So you need to remember this. Okay, sort values, sort underscore values, that's how you sort a data set. And you can pass the option ascending equal to true or false. By default it will be ascending. If you make it false, then it will be in descending order. So that's how you sort a value in pandas data frame. Okay, so that's how it works. Okay, next is filter records with more than 6 cylinders. I already covered this, right? So that's how you can do it. So see here, card cell greater than 6, what that does, that returns a true false array. So this will return a true false array. Now let's say I am storing it in a somewhere, and I want this. Yeah, so see here, Here it is written. So filter, I have created a new function that is called cars of cell greater than 6 that will return this true false array. And when I pass it to cars true and false, so wherever it is true, those rows will be returning. Wherever it is false, it won't be returning. Okay. So that's how this filter thing works. Okay. Now you can have multiple options. You can have more than one condition also. So car cylinder greater than 6 and HP greater than 300, like that. You can provide multiple conditions and you can filter the array. So that's how you filter and data frame in Python. Okay, so let's go to this data visualization part. I will just show you how you can plot a few curves. So for visualization, we have many libraries, but we predominantly use two libraries, that is Seaborn and Matplot. So here we will show you what is matplotlib, okay, and how you can use it. So the name is matplotlib of the package. So we have imported the matplotlib.pyplot as PLT, okay. Then we have done it, we have forced it to render the picture in the Jupyter notebook only with the inline function. Then what we have done, we have we have plotted the HP column of the car. How we did that? For that, what we need to do, we need to pass in two x, and so to plot a curve using matplotlib, we need to use that plot function, that is plt.plot. In the bracket, we need to provide what should be x-axis, what should be y-axis. We have many parameters in there to pass on. We need to pass in x and y values. So here our y value will be the HP column of the car's data frame that we have. Okay, and x value will be 0 to 32, basically the serial number column. So that's why we have taken in range, and x equals range and y1 equals cars HP. Then we have passed in x and y1 to the plt.plot function, and the HP values are printed in a line plot. Okay, so that means for the first row, HP value is somewhere around 120. Okay, for the second row, the HP value is somewhere around 95 or 98, something like that. Okay, like that, this curve can be taken into account. That's how this curve can be thought of. Next one is again another line plot with the displacement. So you can see the displacement values in there, similarly to the line plot. Okay, similarly to the line plot for HP curve. Okay, so next one is to merge two curves in the same plot. So what we have done, we have taken two y variables, HP and displacement. We have placed both in there, and see, this kind of a beautiful curve is being displayed over here, and this legend is also being added with this plt.legend. So see how we can visualize the data, as we are working with the data set, so it won't complete without showing you this. That's why I'm showing you. Okay, so that's how you can visualize this kind of data sets. Okay, yeah, next one is stack plot. Okay, this one is called a stack plot. This is stack plot or area plot, whatever you can consider. Okay, so this is the same thing basically. This is the area chart or stack plot, any way you can mention it. So see here, it will show you the area covered. I am going to the second example. So it just shows you what is the area covered by the curve. Okay, what is the area covered by the curve. We have two plots here for HP and DISP. So we have two areas covered. So this is stack plot and this is area plot. That's how we plot this. This is to show you the area covered by the curves. Okay, so that's how this works. This is bar chart. This is a very popular chart among IT people. Everyone knows this chart. We use it frequently for presenting our estimates and all and all and all. So this is very popular. So this is how it looks, this bar chart, and for that we use plt.bar, okay, to plot this bar chart. So we are plotting the car models and the car's HP in a plot. So that's how it is. So here the plot, the car model names are there. These are the HP values of the car that are plotted using bars. Here it is using horizontal bar. For that we need to use bar h function. Okay, so that's how it works. So here also model name and HP. Model name and HP we are plotting in a horizontal bar. Okay, so that's how you can do it. So that's how basically you can use matplotlib and pandas object hand to hand. Okay, so which of the following will be used to read CSV files? So the which of the following is used to read CSV files? Which one? pd.read underscore CSV, read underscore file, or data frame.read underscore CSV? Which one? So next is what will be the output of the following? So that means that is ARR equals 124578. Small lists are passed. Then DF equal to data frame ARR. Index equals ABC. That means the row names are ABC. Column names are capital A and capital B. So how the array will look like? A, B, C, capital A, capital B, 1, 2, 4, 5, 7, 8, like that. So 3 rows will be there. Okay, 1, 4, 7, 2, 5, 8, and the name of the rows will be A, B, and C. Small ABC. Name of the columns will be capital AB. Now we want to have colon, comma, capital A within quotes, right? So what will be the output? So A is the correct answer because we have passed in the row labels to be ABC, not 0, 1, 2. Okay, what is the output of the following? Okay, see here the march function that we have used. PD.DataFrame 1 colon 1 A comma A, and DF1 is 1 comma A. Okay, DF1 is 1 comma A. Now small a is capital A, small a, capital A, small a. This will I need to type. So basically the output, which one it will be? AA will be joined 1A. So here if you see 1 colon 1 and A colon A, 1 means this array 1 1 1, and A means this array A. So the arrays will, the first array will look like 1 will be the column header, A will be the column header, 1 1 1 is the value. So this is the first column of the first array. This is the second column of the first array. This will be the second column of the second array, and this is the second column of the second array. Now if you inner join, the middle one will be common and others will be merged. So that is the output. So A is the correct output. Okay, next is import pandas as PD. Data frame 1 equals pd.read underscore csv some dataset dot csv. Now to view first 15 rows, what will be the command? Should be D. Next is to rename a column in given CSV dataset. Which command is used? We need to mention the like argument if it's a column or index, so row or column. So columns we need to specify. So A is the correct answer. Okay, that's what is about pandas. Data visualization, why it is needed, what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture what is data visualization. So data visualization is basically presenting a data, presenting numeric or any kind of data with using using charts and graphs and or any other pictorial formats, right? So by that what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay, also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like see, this is the data that we drill down and this is what we have found out. So this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field, this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time what you will do is, you will grab a already defined and already optimized library that is available in net. Those are all the time will be open sourced. So those open source libraries you can grab and you can use those to use those as it fits your purpose. Okay, so that's what is what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are trying are going to give a summation like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them like, okay, this is what is the thing. Okay, and we can ask data from clients also. So that's how we can do. Okay, so in those cases, data visualization comes really handy. Okay, and data visualization is presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have, 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some, till 18 you will have some XYZ kind of data. But that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, like girls are more initiative in this. Or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this. And next is I mean, data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just I mean, just plot these data, if you just show them with the picture, like compare the upper table and the below pictures, then later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always always be using this technique to get some insight from the data, like that. Okay. Okay, so now the things that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right? Like some average, standard deviation and all this kind of average basic stats, then you will see that those have almost the similar kind of values, right? Some is always like 99, some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye, like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you where you will see how different the data sets are, how different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right? This will look something like this, that is in my screen. So let me just grab my piece of code for this NSCOM portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ from differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried, that that is I mean already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation. It's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only 1 or 2 points are here and there. Those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data, it is stacked. All the points are stacked in here, because if you check this, all the x values for the last one is set as 8 except one. For one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one, for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see, their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this ANASCOM cohort rate is a unique data set. Okay, this ANASCOM just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this ANASCOM quadrant was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with 4 data set, obviously with 4 x and y data sets. So for 4 of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay. So for in here, those 4 of them are, all the 4 of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay, so that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values, with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import matplotlib into our Python code. So matplotlib, why matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this matplotlib code, right? So that's where what we are doing is, in this matplotlib code, what we are doing, we are just I mean, in this is a matplotlib library, and this is a object oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this xy points and you can try plotting these points in the plot, like we showed in the last class, right? How to plot a line chart. So you can try it that way also. If you are not having the data set also, so then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this ANASCOM quadrate picture won't be given. I think so, because I don't have it. If they have updated, then fine, you can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take two arrays x, y, x1, y1, x2, y2, x3, y3, four arrays you can take of x and y, then merge those. Like for x, y, plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see, the equation will fit this one to some extent. So yeah, that will be better. So if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here, we have used plt.plot x and y1. If you even if you for now, if you don't even I mean, if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now, keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things. No need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done x y1, x y2, x y3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why is that? Because if you see, the x part for all these three data sets are same, right? So only one array would do, and for y we have four different arrays, and we have plotted those. Okay, we have plotted those using this plt.plot line. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, I mean, if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one, it will take the horizontal axis, second one, it will take the vertical axis, so it will have x and y too. Okay, other things we are we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have matplotlib, ggplot, seaborn, plotly, and geoplotlib. So all these plots comes handy in data visualization, but the matplotlib, it has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like, as you saw, right, we have a setup function, we have a access function, text function. Those, all those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is matplotlib is there. Next is seaborn. Seaborn is again built on top of matplotlib, and that's also a very good plotting library. So, but and generally we use matplotlib the most. Then comes the seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay, so let's go ahead and see why matplotlib. I have told you something, but there are some other points also. So this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multidimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that, like the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multidimensional graphs. So 2D graphs and plots can be created easily using Python script. it can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is this is a next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, I mean sorry, object name dot function name, that's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on numpy, so numpy is also possible. I have shown you examples, but this matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like how what all types of graphs we have in Matplotlib, and how that can be used, and what are the usage of those graphs, and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is. Next, what we are gonna see is what are the different types of plot that we have. Before that, let me come to this inline thing. So this inline function, if you don't have it, it will still work. Okay, this percentage matplotlib inline, you won't see a difference in Jupyter Notebook. Okay, because this Jupyter Notebook is anyways browser based, right? So this won't give you any difference when you use Matplotlib from any web based or any kind of notebook kind of scenario. Okay, but if we have a different set of, I mean if you are running Python separately, right? If you are running Python separately, correct, using spider, it can be spider, it can be a simple command prompt of Python, anything can be there. So if you are running it from those, IntelliJ idea means PyCharm. Okay, for Python the ID name is PyCharm. So if you are running using those IDs, or if you are running using like what, let's say if you are running it from the command prompt, then this will create a separate window. So that's where it gets difficult. Okay, so that's where it is, I mean it is advisable to use this like numpy, I mean sorry, this matplotlib inline command for having the graphs in inlined to the screen that you are currently using. Okay, otherwise what it will do, it will create you a whole separate thing. Okay, so it will give you a different set of, I mean, a different window where you will see the plot. So that's why we use this matplotlib inline. So that's the basic standard, to have it displayed in the same window. Okay, so that is why we use matplotlib inline. But if you don't want it, if you want the separate window to pop up, it will also work. Okay, that will also work. So that's no need to be worried. Okay, before that, let me show you what are the different types of plot that we are having in matplotlib and what are their uses. Okay, then we will go to each of the examples one by one. So if the what you need to remember from this whole lecture will be three things. Okay, first of all, why and what plot need to be used, where it need to be used, and how you can write those. Okay, customization, even if you learn it slowly by playing with it, it's perfectly fine. I don't That's not a matter. Okay, the customization thing, coloring thing, changing the axis labels, adding legends, changing the colors, there can be thousands kind of customization in matplotlib. Okay, so do I have that mail with me? No, I will have it my official email ID. Okay, so what I did, for some requirement I created, there is some kind of graphs and charts that goes to higher management. Okay, for reporting purpose, that goes every day. Okay, so I created something using Python, no data science is involved. That's a straightforward thing, much easier. So I created a simple script or simple job using Python. What it does, it takes in data from a rdbms, it plots the data nicely in a matplotlib plot, and it sends it to you, sends it to the upper management. So when I am telling upper management, that is D plus. Okay, so that's where this comes handy. So in there, you understand, right? When we are going to show this to upper managements, we need to have the graphs beautiful, we need to have all the specifications, we need to have pointers, we need to place them in the right position so that they don't find any errors and they won't accept anything so easily, right? So that's how powerful matplotlib library is. I don't have the I can't show you that because that's not allowable. So otherwise I would have shown you. So that's how you can do it. So the graph, what I can do, like the simple graphs that you are seeing in here, you can change the background color of the graph. Okay, so the background will be of some different color and the foreground will be of some different color. As you are seeing there in the right hand side, we have a bar plot, right? In the bar, you can choose each and every bar color one by one. Okay, that can also be done. All these bar objects can be accessed individually. Okay, once you plot these bars in matplotlib, right, all these individual bars can be accessed one by one. You can change their width, you can change their height, you can change their color, you can set text to them, you can write text in between them. So whatever you can do in Excel with all these graphs, the same things can be done in matplotlib. But again, those things are not required for your day-to-day work. It will require very rarely. So if even if you don't understand those, if you even if you like the NSCOM quartet I have shown you, if I start explaining the whole graph, it will take the entire class because it has too much customization in it. Okay, so just to keep it short and just to give you the proper idea so that you can start experimenting or playing with it, the basics I will tell you. Okay, and on the basic you can build up. Okay, you can build up on the basic. If you do understand the core concept, you can easily build up. So, and also if you are facing any problem, you can tell me in the next class also, I can help you. Okay, so that's how powerful matplotlib is. And let's see what kind of graphs we use. We have line plots. So line plots, what we use just to plot 2D equations, right, with x and y. There we will use line plots. Okay, so line plot will give you a trend line in an equation. Okay, so when we see linear regression, we will see its use pretty heavily. Okay, for machine learning, and also for observing a data set how it is distributed, this is really needed. Okay, next is bar plot. This is the same as line plot. The difference between these two is you can add a trend line in bar plot also, so that way it will become this, but this denotes the area covered by the point. Okay, So the bar will start from x-axis and it will go, the height of the bar will equal to its y value, and the shaded area will be showing the area covered by that point. Okay, so that's where bar plot is needed. Bar plot is basically this, it is required in the same way we have line plots. So what is different in here, in line plots you might not be able to tell what is the value of x for the value of y at x equals 17.5. You need to go there, you need to see, it will be difficult for you. But in bar plot you can see it there directly, right? Because the bar will do that. Significance of width, there is not much, it is just to illustrate, okay, illustrate this bar one. Okay, this is that is how this bar is designed. So bar means it will show you some area covered by the curve. So if you calculate this rectangle, so what it has, this rectangle is same, this rectangle has this width of some x value, height of this y value, right? So if you calculate a rectangle covering that area, so this will denote the area covered by that point, okay, by that x and y point. From the ending to beginning, this area will be covered, so area is shown here. Next is scatter plot. So scatter plot and line plot again are same, but only difference, the points are not joined. So you need to understand when we use these two. When we have a continuous set of data, we know that it might fit a linear equation, right? It Yes, Azam, I just explained it. What is the significance of the area, right? So in the line plot, if you have like if you have a what like continuous set of data, then in that case this line plot will be visible. But if you don't have a continuous set, if you have some chunk of data, clusters of data, then you will use scatter plot. This is to see the data distribution, how they are distributed, and this is the trend line of the data. This example of scatter plot you will see when we are covering clustering. You can understand, right? We have seen some clustering algorithms. So if you plot the data in this plane, then from that you can easily understand how many clusters will be formed from that k-means, right? The k value you can find it from your you can find it by checking that manually only, right? If you plot the data, it will be clear to you. After clearing the data, if you are able to plot that data in this plot, you can find the value of k without any hack, right? And you can pass it to the algorithm to give you those many clusters and their centroids and all. But what you not need to do is you no need to check the data points and decide which point will be belonging to which cluster. Those things you no need to calculate. Okay, next is this histogram. Histogram is basically used for image processing purpose. This histogram shows you basically, okay, so this histogram is basically used for like image processing purposes. And what this bins are denoting, this bins denotes the number of times the values, the frequency of the values, the frequency of each point occurring in the data set. Okay, so that's what this bins are denoting. So this is not really used in data science, somewhat used, but it won't fit our purpose always. So maximum for image processing this is used to see how the data is spread and what are the frequency of the data point that we have, what are the frequency of pixels that we have, those kind of cases, and histograms comes handy. I will show you all these examples, but again this is not really required. Image plot, again this can yeah, CPU processing is also histogram, right? So that's what. So wherever the scenario fits in, to show you some frequency kind of thing, wherever it fits in, then you can use histogram. Okay, wherever you need to find out some frequency of some point in dataset. Let's say for CPU processing, if you see the graph how it will look, it will give you how much CPU is used in what point of time and what is the frequency of high CPU uses. In that case they will use histogram because it will give you the frequency related data. Okay, difference between bar and histogram is bar plot won't give you this frequency, it will just plot the x and y points. It is almost similar to the trend line, except it will show you the area, it won't show you the frequency. But from histogram you can find out the frequency. When we go to example, let's see how we can do that. Okay, Okay, next is image plot, right? Image plot is to plot some image. Okay, again you won't need that. So image plot will fit in a existing image to this to the 2D plot, and it will show you the height and width and all those things you can see visually. Okay, next two plots are really important for us. Those are box plots and violin plots. Okay, so let's do one thing. Let's see the examples of all the 5 plots that we discussed, then we will discuss the rest 5. Okay, rest 5 or 6 whatever we have, we will discuss those after that. Okay, let's see these examples first. So this line example I have already shown you. Now the next one is how to customize these lines. So basically these are the basic customization technique I will show you. So see here what we have done. We have taken the same example as the earlier one, just we have reduced the number of points. We have used this fig equals plt dot figure, fig size equals 10,5. So this one, this plt dot figure object, what it does, so if you don't use it, that also work, but how it works is this plane is a single plot. Within the plot you can create multiple figures. So let's say you want to create two charts side by side. In that case you will use this figure. Okay, you will create a figure size, I mean you will create this 2D plane first. Okay, then you will plot this line. That is the best standard practice, so you should follow that. Okay, you will create a figure object, then you will plot the data points. Okay, that is the standard that we do. So how do we do that? What we do, we use plt.plot function as shown before. We are having x and y, two values for x and y data points. Next we are passing is this line width parameter, right? So this is to provide that line width, what it will be. Next is line style. It has many different line styles also. It has dash, you can give 0, you can give o, any character you can give. Let's say I am giving I, and if I run it, it won't run because I is not a supported character. What was that supported one? I don't remember. I think dash was supported. Yeah, so this line style you can provide anything. Okay, sorry, not line style. Line style will be dot dash, these two things only, or a continuous line. I was talking about this marker. Marker you can put anything. Okay, so marker you can put something like this also. Unrecognized marker. Marker, except to what we had cross, I believe. We had cross, yeah, we have plus, those kind of markers are there. So this marker object is to show you this points. Okay, show you this data points, how you want to see those, but o gives you the best visualization among all. Okay, so that's how you can use it. Okay, next is this line style is for styling this lines, this intermediate lines. If you provide colon, then it will be like this dashed line. If you provide a dash, it dashes will join, right? So dashes will join, and it will, you will see a straight line. So that's how this works. Next is color. You can provide any color. You can write the full name also. You can use the short name also. You can provide here the RGB values. You can provide. Let me show you. You can provide this hex values also. You can do anything. Okay, let me take the default color that is coming. So I will show you this to example. Come on. Okay, if I tell it take it this, and if I put it here, this will also work. Okay, see that lines have changed to blue, right? If I provide this, that will also work. I don't remember the syntax for RGB. RGB is not much used, but still, okay, sorry. But still you can provide like this, I believe, and RGB like this. No, RGB is not the thing. RGBA, how was it? How was it? I don't remember. Okay, RGB styling in Matplotlib. Just let me check it. Check in Google. I will show you. Just a second. RGB, anyways, we don't use it much. We use the simple names or hex codes, because hex codes you can find in many places. Like like in net, you can have it easily available. You can create your own colors, but RGB we really don't use in plot. Yeah, so that's how. So I will still show you because it can be done. So I believe we can only mention the tuple. We no need to write anything in behind. Let's see. Still it doesn't work. Why? How to give it? Just the tuple without this single quotes? I believe yes. Let's see how it works. Still not working. Okay, how do I give it? How do I give it? Why it is not working? Not sure. It should work like this. Somewhere it is not working somehow. Not sure. I will check in the break and I will tell you. Okay. This one I will tell you. So you can provide the hex value or you can provide the mnemonics also. You can type in any color in full also. If I type it yellow, it will also work. Okay. So that's how you can use this color attribute for all the graphs. For all the graphs you can use it. Okay. So you can type in any color or you can provide the hex codes also. Okay. So let me give some good color here. So that's how it works. Okay, that's how this color attribute works. Next is for alpha. Okay, alpha is for reducing the brightness. Okay, reducing the I mean the transparency of it. Let me give it blue. That would look the best. So that's how. So alpha is the transparency. Okay, alpha is the transparency of it. Yeah, that is not working, Nancy. I also remembered the same thing. RGBA is not working. RGBA, nothing is working. So I will check and tell you, no issues. Okay, next is alpha is for reducing the brightness. So let's say you will understand on your own only. I no need to explain. If I run it to 1, see this is much vivid. But if I do it 0.1, you will see this is way too dim. It will be way too dim, right? So that is what is alpha. Alpha is for reducing the brightness. So alpha is the transparency factor. So if you reduce the alpha, then what it will do, it will make the line or plot whatever you are doing transparent to the plane. So it will match the background color of it. Almost it will match the background color of it. It will be a very fade color. But if you pick a high alpha value, it will give you somewhat deep lines. Okay, you will see the dark lines, dark colors over there. Okay, so that's what is alpha used. Marker, as I have shown, these points are called markers. So that's how we plot a line. Next is this title object, right? This title function. So what we do with this title, we plot this title like line plot demo. This we put it using this plt.title and it will automatically be placed here. Okay, it will automatically be placed at the top. You can change it to bottom also. You have options for that, but the basic that we follow, the standard, that is to put it in top always. And x level, y level, x axis, y axis, you can type it. So the labels, axis will be labels. Okay, axis will are labels. It is not for the value, it is for the labels only. Okay, that's how it is. And for the limit of it, the graph will take on its own. It is best to leave it on its own because it will be helpful. Because if you are trying to manipulate the graph, because see, you will always not know this, right, that how much data you are covering, how much data you are taking, like that. So that's why this is best to leave it on the graph itself. So it will decide the best min x min y, min x min y, and max x max y, and it will plot it. Okay, so that's how it works. Okay, next is for plotting legends. Legends means this small markers. So to show you, to show someone which one line denotes what, right? That is what is legend. So for plotting legend, what we do, we use this legend function. Okay, we use this legend function, then within bracket we line the marker name. It can be a list also. Okay, it can be a list. If we had two lines here, let me show you. That will also work. Let's say I have an orange object now. marker as cross. Okay, and it is darker. Let's make it darker. And if I run now, you see we have two lines now in the same plot, right? So how you can have here, you can write like this, and see everything will be taken care automatically. Okay, see here in legend it's already added, the my line thing is already added, and LOC equals base means the graph will on its own calculate the best position for the legend and it will put it, so it will always put in the best position. It can be down, it can be up, it can be anywhere. Okay, plt.grid true, that is to show these grid lines. If you don't want it, just don't mention this function, it won't show you these grids. Okay, so that's up to you. If you like the grids, you can keep it. If you don't, you cannot. So there is no really no real thing in that in showing or not showing the grids. Okay, somewhere if you fill it, you can provide you can have those displayed. Okay, so that's how this grid works. And plt.show, as you know, to show the plot, to show the to, I mean to display the plot in front. So that's how this thing works, this line plot works. Okay, okay, so that is what is about line plot. And you have seen only single line plot in a picture, right? So I have shown you two line plots in the same graph, right? Let's say we have two different plots in the same we have two different subplots in the same plot object. How do we do it? Okay, so that is where this subplot function comes into picture. That is where this subplot function comes into picture. So if you see carefully what we have done here, we have taken the same thing, the same functions that we used in the earlier example, and we have shown you this. We have shown here the two different plots in the same thing. Okay, we have shown two different plots in the same figure. So that's how. Okay, so the next thing is the parameters that we have passed and how do we create this subplot. Okay, so how do we do is, firstly what we did, we used plt dot subplot function. Okay, so subplot function, we have, there are many parameters that can be passed on to it. Okay, there can be many parameter. So we have provided only three parameters here. This is just to have it in a standard one. Okay, so how does it work? Okay, that means the first one, 2, right? These are for number of rows and number of columns. Okay, so we have created one number of row and two number of columns. Why one number of row? Because we want this to have in a single subplot, right? We want this to have in a single plot. So see, when I change it in two rows, so this first one gets smaller, right? Because it has created two rows. First one contains the first graph, second one contains the extra portion of the second graph. So always try to have n rows as one if you don't want to create more rows. Okay, so sorry, for the first subplot, for this first subplot, if you create two rows, then the same area will be divided into two parts. So the graph became smaller in and got fit into one row, and the next row is left around. Okay, so that's how it is created two rows here. So here, so the idea is, if you want to fit two graphs in the same subplot, then only go for this 2 1. Okay, but standard is to use one, because we generally, when we subplot it, we want the subplots to contain one graph. If you want to fit in two graphs like this, you can create a separate subplot here and you can plot the graphs. Okay, so that's how this plt dot subplot is used. See here we have passed in number of rows and number of where we have passed in only plt dot subplot, we have passed in some integer numbers. Plt dot subplot 221 222, so these are just integer numbers, right? So this is 221, this is 222, the starting point of the subplot, and the plot will adjust on its own. This is also an expression that we use, but this is not standard. Okay, this is not standard. This is just to have four plots, four plots arranged in a rectangular way. The standard is always this one. So we pass the number of rows, number of columns that we want, and this one is for number. So that means how many figures are there. Okay, how many figures are there. So this thing, the pyplot.figure function that I have shown you in the in the earlier part, that will be called, and the figure number will be attached to it. That means this is figure number 1 and this is figure number 2. Okay, so if you want to customize it using this figure object, then you will see how you can use it, but that is not really required. Okay, for now just know that this is a number parameter that is being passed into this function, and that denotes how many number of what is the figure number that is there in the graph. Okay, so for the next one, if you see, we have created the same subplot size 1 2, and we have provided number equals 2. So that means this is a figure 2. So this is figure 1, this is figure 2. Okay, the rest function the same as what we had in this. So plt dot title, it has plotted these titles of graph 1 and graph 2. Plt dot show showed you the graph, and plt dot plot show plotted this x and y1 and x and y2, these two things. Okay, so that's how now line plots can be created and customized, and also multiple line plots can be created in the same subplot. So this applies to all the other graphs that we are going to see. So we won't show you those in that much detail, but you can always create a subplot. You can fit in 2 bar plots, 2 line plots, 2 scatter plots, anything you want in there. Okay, so
Number of columns means like one on x-axis and one on y-axis, or what? How?
no, number of columns will denote the width of it. Okay, the height and width, these two things. So if I give it 1, it is so small that it just went out. So that means if you want to divide this, right, how many columns you want in the figure. Okay, so so we want 2 graphs to be displayed, so that's why we set it 2. If we do it 3, that means we have a provision for the third graph to be displayed, and see, this graph is smaller, right? So if you change it to 3, it will be smaller, because it is providing you option for creating a third graph here. So the entire figure, how many columns are there, so that's how it denotes. Okay, so that's how it denotes. So if you do it 1, only one graph will be displayed. Okay, so that's how it works. Okay, so that's how you can create this subplots. So is this clear? Then we can move on to this bar plot. Okay, so bar plot is basically to show you some counts, to show you some this is basically used to show you counts. Okay, so see here what we have done. We have created a data set with 3 this is a dictionary, right? So we have count for apple, mangoes, lemons and oranges. Okay, for x-axis we have taken the dictionary, the list of keys from the dictionary, and for the y-axis we have taken the list of values, that is the count for those. Again, we have created a figure size. How do we plot a bar chart? We plot a bar chart using plt.bar. We passed in x and y. This kind of nice little rectangles are shown over here. So this is 15 and this is the area behind this curve. So next we will see how can we change the width and all of this curve. Okay, so let's go to this one. See here, this is actually this like horizontal bar graph. Okay, so here for horizontal bar graph, we have taken the same data set, we have used bar each function, right? So bar each and bar both will have the same kind of customization. This width will be decided on its own, you no need to specify that. Again, as I told, you can change it, height and width you can change, but that is way too advanced. Take your time, you can work on those things later only. Okay, so this can be done. Just you, if someone asks in the interview, just tell them yes, we can customize those, it is not by default. But how this is, that is a really advanced topic, I don't think interviewers will know also. Okay, next is data. How do we create horizontal bar chart? This is a reverse bar chart. So here we can have bar each function to be called for the plot, and similarly we pass in the arguments. Now the next thing to be covered is like bar and bar chart customization will be same as both will be same. So here beside this I can provide the colors also. Okay, so colors, let me put, say what should I put, let's say I put maroon. So next one I will make it green. So that's how it looks. Okay, so you can pass in the color object, color parameter to it, and these bars will be colored according to that. Okay, so similarly for bar and bar each, same things will be applied. And this plt dot title, x level, y level, we have already seen, right, when we covered this line plot. So similarly those can be plotted. So see here, bar graph demo, quantity, fruits. Here also you can put it in the similar way. You can put it in this way. Let me show you. Copy is not enabled file. So the similarly you can do for bar and bar each. So remember, bar is for plotting bar, bar each for plotting horizontal bars. Okay, so that's how bar plot looks like. Okay, so that's how bar plot looks like. Now next, any doubts in this, or scatter plot is fine now? So now we will go to the scatter plot. Okay, so scatter plot, see, scatter plot is a bit different. It is not like x and y equation. So we have three data sets, a, b and x. So this is x and y equation actually. So for this x value, this is y value for one. So let's consider this as x and y, and consider this as x and y1. Okay, so no equation we need to do. What we can do, we can just generally point these things. Okay, we can just distribute the points over the plot. Okay, so that's how we did. Okay, and this points will be taken automatically. Okay, the colors will be taken automatically. So next we will see how can we customize it. Okay, these are the basic customization techniques, not advanced. Many things can be done with it, just remember that. Okay, so again I will change it tomorrow. Okay, so here, okay, next thing to be show you is, for line plot we use plt dot plot, right? For scatter plot we use plt dot scatter. We pass the x and y arguments inside this scatter, and then we get this nice looking output. Okay, next is customizing scatter plot. Same equations we have taken. So this c, either you can write c or you can write color, anyway it fits you. Okay, s is for size. That means size of these things. If you make it, let me add another 0 and run it. So it will bigger the size of the data points that you have. So size, that is really size, you can write a whole, or you can mention the short name, anyways it will work. Okay, age colors means, if you see these lines carefully, the age is colored as yellow. Okay, because so age is colored as yellow. So for, if I do it black, you will see that, I believe it is really hard to see here. If I make it one, I think you can see. Yeah, now see, the green round objects are covered by a black border, right? So that is the H colors, to differentiate between 1 and 2. Marker, it can be different kind of things. So marker have 0, o 1, if we give, it will give you some this kind of downwards value. 2, if you give, it will give you some upper kind of values. For 3, you will have the in the reverse side. Okay, in the reverse arrow. And 4, you already have it, right? Or if you put o, it will be the round objects that is going to be put. Marker, can we customize? No, we cannot. Okay, so these are the choices for the marker object. Alpha, as we discussed earlier, alpha is for the same thing. Okay, alpha is for the same thing, to reduce the brightness of it. Okay, next is plt.legend, title, x level, y level, same as others. plt.grid, same as others. So now if you see, we have a plt.savefig, scatterplot.png. So this is to save the output of the curve. That we discussed earlier, right? This is to save the output of it. So if I go back to my Jupyter notebook, see here, scatterplot.png is saved. And if you open this graph picture, you can see, and then you can use it for your own purpose. You can attach it in mail, you can send it, or you can do whatever with this. Okay, so that's how you can save the figure to a nice looking image. So that the command for this is savefig, plt.savefig. Okay, so plt.savefig, that's how it works. So that's what is with scatter plot. And now next is this histogram. Okay, so is that clear? Next is histogram. So histogram is to show you counts for some numbers. So we have taken a huge data set to show you this counts. Okay, and we have created the histogram using plt.hist function. Okay, next we have passed in the array that we need to plot in histogram, and we have passed in this bins, right? So bins means where these markers will be put in. This is again intuitional, you can put it anywhere you like. So these are the markers, the marker points. So 0, 20, 40, 60, 80, 100, like that we have given. So how to, yeah, bins are intervals only, correct. So how to understand this histogram? So can you check the data? If you check the data set and if you see how many points are there between 0 and 20, 1, 2, 3, 4, 5, 6, 6, right? So if you check this, so 20 we have 1, leave it. So till I mean until 20 we have 5 points, right? If you check from 0 to 20, what is the value? What is the y value? 5, right? For 20, so from 20 to 40, if you count, we will have 7 values, so it will be going up to 7. Okay, 40 to 60, it is really small, right? Only 1. So see here, the height of histogram shows you 1, right? 60 to 80, if you count most of the numbers, so 68, 64, 62, 60, 70, 78, 75, 79, and all those numbers. So almost 6 7 numbers, 7 numbers almost. So if you check our 8 numbers, whatever, so you will see 8. Okay, 80 to 100, 3. So 3. That's how to understand histograms. Okay, that's how you need to understand histograms. So that's what histogram denotes. Histogram denotes the frequency of data points between a range. So from 0 to 20, how many? 22. So what happens if we add another bin, right? The graph shape will change radically. Why that will change? Because within 0 and 10 we don't have any point, so it has kept it blank, so we haven't put the marker over there. Now let's say we are plotting a marker in 30. Okay, we are changing this to 30. So see it, from 20 to 30 the bin has changed, right? Because we have created two different markers. So 20 to 30 we have a dip, right? We have a dip. So within 20 and 30 we have 3 points, and 30 and 40 we have 4 points, like that. So that's why between 20 and 40 we have total number of 7 points. Okay, that's how to understand this bins attribute, and that's how to explain a histogram to someone. Yes, right, it will be changing with data, correct. Okay, so this is to color the histogram. We, yeah, so that's what I'm telling, right? So that's what I told earlier only, right? Before starting with the examples, bar you will see when you just need to, when you have the counts of some data points, you need to display those in a graph. So that's why you, when you use bar, linear equations, when fits into scenario, you use line. When you want to see the distribution of data over a plane, you use scatter. And when for image processing kind of thing, and when you need to find out counts of data points, you use histogram, right? You don't know the counts, you want to find out without writing a code, you can, if you plot a histogram, you will have the count. So that I told when I covered the theory part of it, right? Okay, next is customizing histograms. Again, we have provided this bin numbers. Age color we have provided as black, and color we have provided this funky red color. Okay, title, X level, Y level, grid, sefig, already you know this, right? So same thing, not wasting much of a time. So edge color and color, we can do it in all the graphs, and we can customize the graphs. Okay, so that's how this works. That's how this histogram works. Okay, okay, so that's what we discussed till now. Image plot is not really required, we are not so for now I am skipping it. It's not really required. Do I have it? No, I don't have it. So any images can be plotted into it. Okay, so that much you can remember. So that will be enough for you. Okay, so that's how it is. Okay, so that's what we have till now. So next we will discover box plots and violin plots. So let's have a 20 minutes break and come back. We have a lot of theories in mind, so then we will discuss this. Okay, so box plots and violin plots are hugely used. I will tell you when and what, where to use it. So any doubts till this bar plot, or is it okay? We can go for a break and then come back and go for this box plot. Is this fine till now? No questions? Then we can break here.
So one question, like each plot has its own significance, right? Exactly, we have to, for a linear we have to use a line plot kind of things, right?
Correct. Right.
Histogram we have to use in one place, and bar, where exactly we are going to use bar and all?
When you have the counts defined, you use bar. When you don't have the count, you use histogram. Okay. See, this
And
is just to this is why we are using data visualization. Again, have the concept clear. This is nothing but showing a I mean showing the data in a graphical way, right? So if you tell this data to the clients, it will be hard for them to understand, and for you also, you would need to read this carefully and all, because in real world data set only five, you have already seen 300 rows, right? But in real world data set you will have 1 lakh of 1 lakh or 2 lakh rows of data. That will be pretty much on the cards. Okay. And me and you don't have the infrastructure to run that, so we are limiting to small examples. So in that case, when you are going to find out all these insights by manually checking, it will be impossible. So that's why this plots. So you need to understand the scenario and you need to apply it. Okay, so that's how. So let's get started. So if you see this box plot, right, box plot contains the quartile information of a data set. Okay, this is the statistical plot that we use heavily. So this below line will be your Q0 and the top line will be Q4. In between, this will be your mean, that is Q2. This will be Q1. This will be Q3. Okay, 4 lines will be there. Now this is how this data will look like. Now how do we calculate those Q1 Q2s? Okay, I have considered this data set and I have calculated all those calculations. I have done all those calculations in my Word doc. Okay, in Word doc we have all these calculations. So what we are doing, we are just having the equation. We are just sorting the array. So if you sort the array that is given, you will get this kind of an array. Okay, this array you will get this one. Okay. So next, what we are doing, what we are doing is we are finding out the second quarter. We are finding out the mean of this. So how do we find out mean? What are the number of points? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we have even number of points. What is the definition of mean? Mean is the middle point of the data set to which all the left values will be less than to that mean, and in the right side we will have greater than or equal to the mean, right? So we have taken, and for odd even number of values we take the middle two values. So we have taken these two values, we found out their average and we found 20, and 20 is our mean. Okay, 20 is our mean, and this 20 is referred to as second quartile also. Okay, now so this is the mean. Okay, so here we split the data set. Okay, here in this 20 point we split the data set. Now as we have two middle points of the data, so 2 point we can consider in the for two parts. First let us take this part. Okay, let us take part from this to this 20 and part from this to this 20. Let us take this two part. Now this is already sorted, so we will again calculate their mean. So here if you see 5 number of data points are there, so that means odd number of data. So we will have the midpoint, that is 10 as our quartile, so 10 as our mean. So this mean is called as Q1. Okay, this is the first quartile. Okay, from 20 to 70 we have 30. This is called Q3, third quartile. So what this does, this gives you this three Q1, Q2, Q3 informations. And if you see Q0, Q0 is the minimum number and Q4 is the maximum number. Okay, Q4 is the maximum number. These two are first and fourth quartiles. Okay, so zeroth can we say 0? So that is our first quartile, second, third, fourth, and fifth quartile. So we have 5 quartiles. So we generally consider this for Q0 to Q3. Q4 is the last one, so we don't really consider this as a quartile, but you can tell it like that. So this information will be pasted in the box plot. Okay, this information will be provided in the box plot that we have in here. Okay, that we have in here. So if you see carefully, for the first, this total, this is the box plot for that. What was the minimum value? 1, correct? So here is it is 1. What was the first quartile? 10. What was the mean? 20. What was the third quartile? 30. And this sums it up. Okay, this 30 sums it up. So this is the box plot. This much you focus on, and the max point, that is what I was referring to as Q4, that is not there. That doesn't present. That is not present anyways. So here it is. Okay, how this height is defined? From 10 to 30, how many points are there? 6 points. So that's why this box is a bit bigger. Okay, that box is a bit bigger. So this, the height of is it's almost 6. So that is what this height denotes. Okay, from 10 to 30, how many values, like that. Okay, so that's what is this height about. Okay, that's what is this height about, or you can say it like Q1 and Q3. In between, this height is given. Okay, so this box means here the maximum number of data point are concentrated in here. So between 10 and 20, how many points are there? If you check, so we have 2 10s and 3 20s. So in a data set of 10, we have 5 values within 10 to 20, right? Within 10 to 20. So that kind of information you can get from there. Okay, that you can get from this box plot. So it basically shows you again the distribution of the data and the basic statistics of the data, the quartile range, and how and where and which part of the data is concentrated. Where the data is more concentrated. Okay, the height of the box is how many points are there, like that. So 10 to 20 or 10 to 30, we have 7 8 data points, so the box is a bit bigger, like that. And from 0 to 10, we have 3 data, so that is the height. Okay, it won't match with the graph. It is just for visualization purpose. It won't match with the graph height. I am just telling you for ease of your understanding. Correct, that is IQR actually. So IQR is, this is between Q0 Q1, this is between Q1 Q2, this is between Q2 Q3. Okay, so that is what is the frequency of the data, right? So that's why we calculate IQR. IQR is to give you a rough idea about how the data is, what is the frequency of the data, how it is spread in a in a range, right? So that's how this works. This won't match with the box line. So this big lines are IQR, interquartile range, and how many data sets are there, like that. So that's what is about this box plot. So here we haven't done many things. We have taken 3 distinct lists. We have taken all those into a single list, and we have plotted the data sets, and we have plotted that using box plot. Okay, that is the command for that. We have we have told it to show the means. We have passed in that show means to be true, so that's why that orange dots are shown. Okay, those are the means actually. So that's how this box plot works, and that's what kind of information you get from this box plot. Okay, that's what kind of information you get from the box plot. So this is what is about this box plot. Others I have already explained, so not repeating those things. And if you go on this code perspective, we have taken 3 different lists of total, order, and discount, and we have combined all those 3 lists into one using this list command, and we have passed 3 separate lists to plot it. This is just to have the information handy, because this is just to follow the syntax of the box plot, because it takes in the entire data set and it will create 3 boxes for 3 different data sets that it has. Okay, so that's how this box plot works, and that's what kind of information we do have from this box plot. And generally speaking, when you start analyzing data, you will use this box plot to quite some time. Okay, to check the data distribution and to check the quartile range, to check how it is distributed among the quartiles, and like that. Okay, okay, so that's what it is. Okay, see, don't think about the height much. So that height is basically the IQR, that is the distance between Q0 Q1, and that shows how many data points can be there. Okay, so that's what is this height reflects. Okay, height doesn't have much of an scenario here. So this is just to connect the plot and show it like a box. That's why the heights are there, and the distance between 2 quartiles are called IQR, that is interquartile ranges. Okay, so the the value of the height is interquartile range. So that is the frequency of the data set. Okay, what does that mean? So say 0 is the minimum value and 10 is the first quartile. So if you check the quartile range for the first quartile, that is 10, right? So the height equals 10. Okay, the mean is 20 and the Q3 is 30. So what is that quartile? That is like 10, right? So that's how this height is there. That is the interquartile range actually. Okay, so that's how it works.
And 70 is outliner. It will exclude that while calculating.
No, it has calculated that, but that is the max value, so that's why it has kept it that far. Okay, that is the max value. But for quartile calculation, we don't take into account the max value. Okay, so that's why it is left out. That is a max value, right? We don't take it into account like that.
So why we don't take into the account? Because it's far away or something like that.
No, because that is what the value of because that is that is how we calculate the quartiles, and that is what is the IQs are all about. Okay, we don't take the last one. We have only 4 quartiles, Q0 to Q3. Q4 is not taken into account, so that is the max value basically. So that is not taken into account. That is not outlier. That is how stats work.
Okay, okay.
Okay, so any questions? Okay, so next one is violin plot. It is the same as the same as this box plot, but it is different. It has the same values. Okay, Q0, Q1, Q2, mean, and all those kind of things. It has, but what you see here is a violin kind of a shape for all this distribution, right? So that shape that you see, the shaded area that you see outside the middle line, that is the probability density function of the data set. Okay, that is the probability density function of the data set. What does that mean? Okay, what does that mean? So okay, what does that mean? This shaded area. Okay, this shaded area. So this is the probability density function. That means probability of having a number between. So what is probability density function? Probability density function means the probability of a point being in a range or a probability of an event being occurring, right? So let's say we have a range of 0 to 10. What is the probability that in for a particular data set, what is the probability that number 4 will occur? What is the probability of number 4 will be there in the data set? That is what probability density function calculates. Okay, so that means this is the probability of an event being happening in a sample space. You can if I go by the by default stats terms, that is how it looks like, probability of some event happening in a sample space. So that is what it defines in probability density function, and the same thing reflects in violin plot. So how can you use it? Similarly, as I show you the calculation for q1, q2, q0 to q3, same lines are there. See, only 4 lines will be in here, right? If you see, there are 4 lines, so those lines are for q0 to q4, like that. And then the outside shade is the probability density function. So how can you see, what can you configure from those? Between 1 and 20, how many values are there? If you check the data set carefully, there are 5 to 6 values between 1 and 20. So that's why the curve is thickest at that point, right? So there is a high chance that if any future data comes in, so it will be in that range. So basically you need to think it in a bit other ways. So this static data set won't explain you. So let's say you have built a model. Okay, you have built a model based on some features. Okay, what is model and all, don't go too deep. Model is an algorithm. Okay, that we will discuss in the next class. So how I mean, I am trying to explain when you use it and how you use it. So let's say you have built a model without seeing anything. You have put in some features, you have taken into you have assigned the features into the weight to the features. So now how do you validate that? So if some feature values are in between, lying heavily between 0 and 20 or 30, then that means when you get a test data set from that of the same pattern, it will always follow that probability density function. So that way you can understand which feature to have what kind of a weight. Okay, and which feature is having what kind of a distribution. So these things you can check. So that won't be only a single feature, that will apply for all the features. That is a machine learning data set that you will have. So this applies to all those. For ease of understanding, I explained with one, because there is only single arrays are taken into account. So this we will plot for all the features, and we will see how the data is being differing. Okay, what is the probability that in future we can have different set of data. So if we have some true false kind of skewed data set, we will have it often. So 0 and 1 kind of data set if we have, then probability density function will have two peaks, one near 0, one near 1. Okay, so that's how it will look like. So let me try and show you. 10 points we have, right? 4, 5, 6, 7, 8, 9, 10. See here, because this is not visible because this is having this large values. So this value, if you enlarge it, you will see that this is stacked between 0 and 1 only, right? So you will see two peaks in here between 0 and 1. So that's how this thing works. So let me try this. See, you have two peaks, right, between 0 and 1. So as we have more ones, so the peak is flattened near 1. As we have less number of 0, so it is flattened near 0. But see, between 0 and 1, the curve is getting shortened, and when it goes so 0.6 will be their mean. Okay, because that is what we have taken as 0 and 1. Okay, so 0.6 will be their mean, and if you see from 0 to 0.6, that the curve is a, so let's say 0 to 0.4, the curve is wide enough, right? Because till 0.5 we can consider it to be 0. So from zero point 0.4 onwards it started to increase, because if it is greater than 0.5 we can estimate it as 1, right? So and at the 1 it has a maximum width, and at 0 it has a maximum width. Others are just shortened, right? So that's how probability distribution function you can use. So here what you can see, this is a skewed data set, right? This is a skewed data set, so this cannot fit a straight line equation or something like that. So you need to change it, you need to change the thinking, and you need to choose, explore other options. So that's how you can check that. Yes, this is a binomial function. So this is a skewed function. It will be of form e to the power x, right? E to the power x by 1 plus e to the power x. That is sigmoid function. Like that we will have this. Okay, this function will output two values only, 0 and 1. So that's how it works. Okay, so that's how violin plot works. So if this is clear, we will just I don't have examples for this because we won't need that. I will just explain these two plots, these three plots actually. We won't need that much, so I will explain what are those and how they are used, like that. Okay, next is this quiver and stream plot and area plot. These three we are not gonna use much. I will start with area plot. What is area plot? Area plot will show you the area covered in a line. So how you can see that? You can check like this. So let's say we have a line plot. Okay, we have a line plot. I am drawing some line over here. So let's say we have a line plot like this. So let's say this is the line plot. So area plot, what it will show? It will show this area. So it will show this area that we have inside this. Okay, that is the area plot. So that is to show you the area covered by a curve. Okay, area covered by some curve that we have. So that is what is called area plot. Okay, that is what is called area plot. Now if I show you here, like this is the quiver plot, right? So if you see all these individual data points, right, these individual data points are looking like vectors. It has some directions, right? So that is for basically magnetic field analytics and high-end physics needs. These are basically vectors. These are basically directed vectors. This is basically needed by physicians. Okay, this is basically needed by physicians, these two plots, this stream plot, this one up here, and this one down here. These two things are basically required by physicists to analyze the vector and to do vector analysis. Here if you see, this has pointed ends, right? So that is the direction of the vectors that goes in or out. So electrical engineers or physicists can use this plot. So if any electrical engineer is there in class, you will understand this, right? Current inflow, outflow, and all those kind of stuff. So if you have a large circuit, it will something look like this, right? So if you have a midpoint in here, what is the current input, what is the current output, and all those blah blah stuffs of electrical things will be there. So that's how this quiver plots are used. That's how the stream plots are used also. In stream plots, what is the stream plot? What is the difference? The difference is in the stream plot, we won't have that vector direction. We will just have positive or negative value for a vector, and that will be just a representation of the vectors in a 2D plane. Okay, so that's how this quiver and stream plot works. An area plot shows you the area covered under a curve. So these three plots, data scientists are rarely uses. Even if you use area plot somewhere, some down the line, but quiver and stream, let me assure you, you won't use it ever. Okay, because we are not gonna deal with vectors, right? That's how. Okay, so any questions on these three plots? So before that, I will just quickly go through these points. I have told you, but still, see here, where is bar plot used? So bar chart or graph chart is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values they represent, right? That's what. So the bars can be plotted vertically or horizontally. So what is categorical data? When you have count kind of thing, when you have some categorical data, means where we have categories defined, right? So here apple, oranges and all those kind of stuff and related to their counts or their price or their anything. So these type of data are called categorical data. So then we do use bar plot. Okay, for scatter plot, where is it? Yeah, scatter plots are used to plot data points on a horizontal and vertical axis in attempt to show how much one variable is affected by another. That is, what is the distribution of the data set, right? What is the distribution of the data points in a 2D plane, right? How the data are distributed. So if the data are very closely stacked, that means x and y values are very closely related. So we will have a high correlation. If they are widespread, then we will have a low correlation, right? Because they will be independent. If you see very high what sorry, so if you have a very the high difference between two data points, so that means if the difference is more, that means the correlation is low and they are independent kind of thing, right? Because in those two, if x and y has a pattern, then they will be following a pattern, right? Either they will be clustered, either they will be having a linear equation like that. Okay, so that's what it helps you to understand. And in a cluster, all the values will be tightly correlated. So if you try and find out a cluster here, you will see one, then two, then three, then four clusters, right? Like that. So you will see four clusters are there. So they are not tightly coupled. But if you see in a cluster, this three or four data set, they are almost following a line, right? These two are following a line. So that kind of values you can get from scatter plot. I have told this, but it is written beautifully here. So that's why just covering it. The sentencing are good here. That's why. Okay, histogram I explained. So plot used to display frequency across a continuous or discrete variable that I already discussed, right? Box and violin also viewing summary statistics, and is an efficient way. Also box plot helps you in doing outlier analysis. So these are outliers, right? This is the outlier because you see the quartile range finishes here and some value is up way there. So these are outliers, right? These are the max values. These are way far high than outlier than the Q3. So that means almost all the data sets lies between this, but this data lies far above that. So this is an outlier, right? That's why it is left out. That's why it is left out. And if it is not an outlier, it will be close to the line, right? If the value is not an outlier, it will be close to the line. So that way we will see. But again, that won't be plotted using dot, because the max will be plotted using dot here. Let's say we have a value of 35, so it will be somewhere around here. So that we can't consider as outlier, right? Because it is pretty close to the Q3 range, right? So that is there. That value is there. So that's how we can use box plot. Violin also same thing, except that we will have a probability distribution function attached to it. Okay. Okay, so that's how we have image plot. Let's leave it. Let's not let's not go into a bit detail. So just know how to do that. If you open a image, okay. So how you can do it? You have image processing library called pillow inside Python. Okay, you have pillow library in Python. You can install it, no need to do it. Okay, no need to do it or remember it. This won't be used. So using pillow library, you can use this image function, and you can open an image. All images are what? Arrays, right? They are arrays of pixels. So you can convert it to a numpy array. You can pass that numpy, you can plot that numpy array itself, and that would serve your purpose, right? That will serve your purpose. So this is what ax1.imshow. Imshow is for showing the image. That is again a pyplotlib matplotlib function. And if you pass in the array, the corresponding values will be shown as a image here. Okay, the corresponding values of the pixels will be shown as an image in the output plot. Okay, so that's what is image plot. And the image plot to histogram also you can do, so that way you will see the distribution of the like that distribution of the colors in that, right? Colors or pixels in that. So see here, this is at 250, this is a very high value, so it might be some pixel having high value, because see, blue is having a pretty dominant color here. Blue is pretty dominant, right? So that's why it might be causing this high value kind of thing, right? So that's how is for image plot. That is not at all used. Quiver scheme, as I already told, the example is not much required. See here, this is a plotting a vector. How can you do? You can do it using quiver, this quiver option. Okay, this quiver option, we have created a subplot, then we have created this quiver option. Okay, using this quiver, if you pass x position, y position, and the directions, so you know, right, the vectors will have two directions, 1 0 1 minus 1. This is the direction of the vector, so it will go from 0 to 1 upwards, and this will go from 1 to minus 1, that is in a downward way. So that's how the vector directions work, and that's how the vector calculations work. That's how you can plot a vector. Okay, you're using quiver plot. So this is a 2D plot. This is a stream plot actually. So stream plot is used for vector calculation, vector algebra, vector physics. I mean, wherever you have a vector involved in physics, electromagnetics, electrical engineering, stream analysis like cyclone analysis, wind trend prediction, like those kind of scenarios, you will have the stream plots into account. Okay, so this is just a bit different from the vector plot. And here also you have the same thing, the stream plot function. Okay, but you won't be, you will use it pretty less. Okay, see here, this is a trend analysis, a wind trend analysis kind of thing. Okay, so that's how this stream plot works. So see, the pie chart is to show you percentage or proportional data. Okay, so this can be this can come handy when you have more than 4 or 5 categories. Then box plot will take up a lot of space, and from the box plots also you will only see the values, right? The counts and the categorical values like that, but you won't see the percentage of the data that is being placed in those each of the categories. So those kind of scenarios, pie plot comes into picture. Okay, I will show you the coding example for this pie chart. Okay, but it's not much left for pie chart to be customized. So let's see. So if you see, so now it will be easier for you to understand all these functions. So first, what we have done, we have taken a label array of 4 and size array of 4. So that denotes in a data set what are the number of dog, cats, wolves, and lions that we have. Okay, so if I show you a quick math, that then it will be easier. So let's say what are the values that we have. We have 50, 45, 60, and 80, right? We have 50, 45, 60, 80. So how it calculates? So 50, 45, 60, and 80. So it comes to 140, it comes to 95, this two comes to 275, right? So we have total of 275. Now if you calculate 50 by 275, how much it comes? It comes to 10 by 52. So that is somewhere around 20%, right? If you calculate this, it is somewhere around 20 or 19%, right? 50 is the count of dog. What is the percentage of dog? Percentage of dog is 21.3%, right? So this kind of percentages are calculated and shown over here. Okay, for cat it is 45, so it will be around 90% like that. Okay, so that's what kind of information you can get from this pie chart. Okay, now how do you plot that pie chart? you need to use plt.py function. Within py, if you provide some, and the options I will explain now. So sizes is one variable, labels is another variable. So labels we need to pass it, because otherwise this labels of lion, dog, cat, wolf won't be shown. So and it will be equally, it need to be in the same order as the size array. Okay, otherwise the this labels will be misplaced. Okay, next is auto pct percentage 1.1 f percentage. That means what is the display percentage, what will be the format of it. So we want only one decimal after the, we want only 1 point after the decimal, right? So that's why we have given 1.1. So that is the number will be whole intact, then after the decimal we want only 1 point, so that's why 1.1. Shadow true means you see there is a shadow effect inside. If you give it as false, I will show you, then you will understand the difference between these two, shadow true and false. So if it's a, if it's a 3D I mean, if so here the shadow is not really visible, but it should be if you use lighter colors. Okay, lighter colors will have you the shadow visible, so it will have a bulging effect actually. So that's how it will look. So that is not much used, you can leave it. Okay, start angle is 90, means then the angle will be 90-degree angled. Okay, so it will have a equal kind of a shape, so it will have a equal kind of a array actually, I mean sorry, equal kind of a shape of the circle. So that's why start angle equals 90. Explode, as you can see, if you mention 0.1 as an explode, then it will be those slices will be cut out from the array and it will be outside the array. So that's how explode function works. And explode you need to give 1 for each. So where I have mentioned 0.1, those slices, see, they're cut out from the pie chart, right? That's how this pie chart works. Okay, so pie and donut, I will finish it, then I will open for question here. So donut chart is the same thing, just the difference is it shows the area. Instead of showing the percentage, it shows the area. Okay, for that what we do, we create two pie charts and we combine those. Okay, so see here, we create one pie chart here. This pie chart, if I show you one by one, so this is a pie chart, right? We don't have the numbers mentioned, so we haven't mentioned auto PCT, so it haven't shown. We haven't mentioned shadow, so this kind of effect is not there. If you see these two, a difference between these two, you will understand what is the difference of the shadow function, right? So this is a pie chart. Okay, we have created a pie chart using this variable that we have. And okay, this is color white, let me make it black. Black is coming as blue. Why? Okay, black, only one body takes, that's why it's taken blue. Okay, got it. So that's how it will take only one word in the color, so that's why it is taken as black. If I put O is not supported. Y is supported. Okay, so Y for yellow. So you see here we have a yellow kind of a circle. So this circle is to give the blank inner filling. Now if I run this first pie and second pie together, see this effect we want to give, right? So this is a pie chart that is there. So if you remove this second pie chart, what happens? This is the entire chart, correct? This is the entire chart, correct? What is the radius of this? 1.5, right? Now we want to show it as a donut. So what we can do, we can cut out some area, right? So that without saying, if I draw it, it will be easier. So being said that, so let's say this is a bigger circle. Okay, let me change the color. So let's say we have blue here. So this is a bigger circle and we have these three parts. Okay, we have these three parts. Okay, let me change the color again. Let's say I'm taking green. So this part is green. So next I'm changing it. This part is pink. Let's say like that. Okay, and this part is orange. This is filled up. Okay, this is entirely filled up. I am not going to fill it up. So what you can do, you want to show only this much. Let's say only this much you want to show. Oops, sorry. Let me change the pen color. It will be easier for you to understand. I have exhausted all the colors. No. Let me just think. We want to show to the viewer this much of value, this much of portion. So what can we do? We can fill it up with some value. We can fill it up with some color. Let's say we are filling this up with orange. Okay, what will happen? This shade will left upon, right? This outer side circle will be left upon. So that's how you can create a donut chart. It is not an option in it. So let's say if I increase this, you will see the donut chart gets shrinked. Okay, the donut chart will get shrink. That's why we have used white here, and that's how it works. Okay, if you use 1.5, the donut chart will vanish and it will have a slight effect over there, right? If you use 1.3, it will be pretty thin, right? So that's how you can create a donut chart in Matplotlib. Okay, that's how you can create a donut chart in Matplotlib. The pie chart you will create and you will empty its center. That's how you can create it. Okay, so two pie charts combined together will give you a donut chart. Okay, so that's how this works. Okay, so for your ease of understanding, I will leave it as yellow only, so that it's better for you to understand how you create donut chart. There is no donut chart. You are fooling the audience. Okay, so next is area chart. So area area chart I have already shown in the last class, right? So what you can do, you can use stack plot function, and if you pass two variables, then it will show you the variable the plot covered. So let me show you using a line equation. Okay, oops, sorry. Let me copy the line equation that we had earlier. Which one? L. Yeah. So that's how this will work. Okay, that's how this will work. So for this color, if you write black, it won't work, but if you do color, it will work. Yeah, so that's how it works. Okay, so see, now we have, let's not give it green, let's give it maroon, let's give it green. So if you increase the transparency, it will be easier for you to show. Yeah, looks nice. So that's how this stack plot works. So see, this is basically denotes the area covered between a curve. Okay, a curve or a straight line or whatever is it. Okay, so that's how this stack plot works. So stack plot is basically for showing you the area. Okay, the area of the plot covered. Okay, so that is how we have this area plot. So this area plot you might use somewhere, but not much used at all. But this quiver and stream you won't use. Pie donut you will use often. If you have some presentations, you will use this. And without from now on, what I can suggest you, if you are working on some data on Excel and generating some graph on Excel, try to switch to this one, right? Try to switch to this editor like this, like Python. Okay, so just try to switch to Python, and then you will have nice looking charts, nice looking things, and you will learn this Matplotlib library in a vast details. So that will help you. I believe whoever is there, everyone is working on this Excel heavily, so you can try it. Okay, you can try Python for generating those charts also. So that way you will learn it. Okay, you will learn it quite well. So that's how we have. So that is what we have theory portion for this charts and all.
So our today's session is on Introduction to Machine Learning. In today's session, you will learn about how you are surrounded with machine learning, what exactly is machine learning, and what are the various myths related to machine learning. So without delaying any further, let's move ahead and see how you are exactly surrounded by machine learning. The first one we have is product recommendation. So have you ever shopped online on Amazon? So while browsing through the product, did you notice that it recommends you a certain list of products which are quite similar to your interest? So how do you think Amazon is doing this? Well, it is one of the application of machine learning used in Amazon. Amazon is using the technique of machine learning to build a recommendation engine which recommends product to you. Okay, let's move on ahead. Next is Amazon Alexa.
So how do you think whenever you command Alexa, it performs a particular function? Like, hey Alexa, play a music. So it plays your favorite music for you. Or hey Alexa, turn the light on. So it turns the light on. So how do you think these actions are performed? Well, this is again one of the application of machine learning. Or movie recommendation by Netflix. Again, one of the application of machine learning. Or Google traffic prediction. So how do you think when you're using Google Map to navigate from a place X to Y, then it suggests you route and it predicts the traffic on that particular route. Like from point A to point B, it will be huge traffic and that is mentioned in red, and after that there would be no traffic. So the pathway is shown in blue. So how do you think this traffic prediction is done? Well, it's also an application of machine learning. And these are the use cases which you are using in your daily life. Right, so these are the use cases of machine learning which you are using in your daily life. So now let's just move ahead and start with introduction to machine learning. So what exactly is machine learning? Well, machine learning is not just about the robots, right? Machine learning is a sub-branch of artificial intelligence which focuses mainly on machine learning from their experience. It is a subset of artificial intelligence which gives the machine the ability to learn without being explicitly programmed. Here, the data is the key and the learning algorithm. The data is the most important part of the machine learning algorithms. The machine trains itself according to the data provided to it. Let me explain you this with an analogy. Consider a newly born human child who starts learning in his primary and kindergarten. The child initially knows nothing, so the teacher starts with the alphabet. The teacher shows the picture of A to the child and tells him it's A. The teacher repeats the process again and again till the student learns all the alphabet. So this was teacher teaching the student. Now once the training is complete, teacher conducts a test to verify how accurately his student has learned. If the test score was not good, means that student has not learned. So more training is required in that case. Now compare this human child with a newly born machine. The machine doesn't know anything, right? So you start training them in a similar way the teacher taught to the child. Initially, the machine has no idea about what is A or what is B. So you start by showing your machine various pictures of A and telling that it's A. Now once the training is complete, you can test your machine by showing it different images of A of different fonts and style. If the machine is able to predict the image A with higher accuracy, then in that case you can say that your machine or the model is trained. Alright? So this is what exactly is machine learning. So now the question arises, how does the machine learn? So when you have the data set, you start by dividing your data set into two parts, the train and the test part. First 80% of the data is the training data, and rest 20% we use it as a test data to test our model. So you train the machine with 80% of your data and create a machine learning model. Now once the model is created, we bring in our test data and test our machine with it. If the accuracy is not good enough, then we repeat the process again and again till we get a final trained and tested model. Okay, this is how a machine learns. Fine. So this slide says that machine works with more data. So it's like more data you provide to the machine, more accurate it will get. For example, here on the screen you have some images of Chihuahua and Muffin. Okay, so you can see that they are quite very similar in their appearance, right? A human can easily tell that yeah, it's a dog or it's a muffin. But when it comes to the case of machine, it is really very difficult to tell which one of them is dog and which one of them is a muffin. So the more data you provide, the more accurate your machine get, and more easily it will be able to identify between dog and the muffin. Okay. Next. So I'm assuming that almost all of you must have come across this verification step from Google, right? Where it asks you to select all the images, for example here of a fire hydrant. So what you do, you just click on the picture of fire hydrant to verify that it's not a machine, it's you. But who knows, we are actually training a machine and telling the machine that these are the images of a fire hydrant, right? It might be possible that we are training a machine for something very big. Okay, let's move ahead. The machine learning popular myth. So let's bust out some of the popular machine learning myth. So the first myth that we have is most of the people consider that all the AI, machine learning, deep learning, all these are same. But just to tell you, there's a significant difference between them. So just to tell you, AI is a broader umbrella under which machine learning and deep learning comes. And deep learning is a subset of machine learning. Okay, so let's see them one by one. Starting with artificial intelligence. Well, artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that works and react like human. Well, it's a broader field, or you can say that the theoretical concept of machine learning and deep learning comes under AI. So the presentation part is AI and the actual implementation part is either machine learning or deep learning. Okay, next comes machine learning. Well, machine learning is a subset of AI which gives the machine the ability to learn without being explicitly programmed. Okay. Next is deep learning. Well, it's a subfield or subset of machine learning which is concerned with algorithm inspired by the structure and function of the brain called artificial neural networks. Fine. So get this thing clear that AI, machine learning and deep learning are not at all the same. Okay. So I hope now you know what exactly is AI, machine learning and deep learning. Okay. Let's bust out another myth. So next myth that we have is robots will take up our job. So most of us think that robots is gonna take up our job. Let me give you a scenario. Every one of you know about Uber, right? Uber is using machine learning algorithm to simplify your life. So what do you think? Uber has taken up the job? No, right? So instead it has generated so many n number of jobs for the people out there. So many needy people are hired every day as Uber driver. So here my point is machine learning or the robots might take up your current tedious job, but instead it will open up with thousands of opportunity for you and will definitely make your life more easier. Okay, so robots are not going to take up our job, but instead they are going to generate more jobs for us. Okay. So in today's session, we'll learn what exactly is supervised learning, one of the type of machine learning, what are the real life use cases of supervised learning, what is unsupervised learning, what are the various real life use cases of unsupervised learning, what is reinforcement learning, and finally, what are some of the real life use cases of reinforcement learning. So without delaying any further, let's start with types of machine learning. So in general, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's see them one by one. So starting with supervised learning. So supervised learning is the one in which we have a training data set, or you can say in which we have a labeled training data set and the machine is trained on that particular label. For example, so there's a teacher or there's a supervisor who supervises the entire process and trains the machine according to the label. For example, you can see up here, here's a teacher on the screen who is teaching the machine by showing different images of the apple. So once the machine is trained, so in future, when we show a different image of an apple, the machine can easily identify that it's an apple with some accuracy. Okay, for example, the image shown up here is an apple with 97% accuracy. So this is supervised learning. So let's see some of the use cases of supervised learning. So first we have a spam classifier. So how do you think your mail is getting classified as whether it's a spam mail or not a spam mail? Well, the spam detection basically works on the basis of filter. These are settings that are constantly updated based on new technologies, new spam identification, and the feedback given by Gmail user about potential spammers. Spam filter uses either text filter or it eliminates the threat based on sender and their history, whether the sender was previously reported or not. Okay. So there are mainly two types of filters: text filters and client filter. Text filter work by using algorithm to detect which word and phrases are most often used in the spam email. Phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. Spammers have gotten wise to this and often use blunt misspellings or even substitute of characters like free dollar character in order to make it pass the filter. Fortunately, the modern spam filter can also make allowances for these type of misspellings, and if a word comes up, even with character substitution, the message will still be blocked. Next is the client filter. In addition to the simple text filter algorithm, the top spam filter uses client identity and history to block malicious or annoying spam email. Now, how does a spam filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. If they send out huge amounts of email constantly, or if several of their messages have already been marked as spam through the text filter, in that case their email will be blocked entirely. So this brings us to the use of blacklist. Spam filters also include a blacklist. Blacklisting is simply the process of adding the known email addresses of a spammer to a list. This list prevents any inbound messages from the email address going forward. If you have marked something as spam, it will directly go in this blacklist. And it also helped Google to make a note of certain keywords found from that particular spam mail. So that's the outline of spam detection. The real-time process are a lot more complex and consume a lot of data. Okay. Next is fingerprint analysis. So for fingerprint analysis, what you do, you save your fingerprint in the machine as a record. So the machine checks the data and verifies whether this particular data belongs to you or not. Okay. So once the data is saved into the machine, so from next time, whenever you put your fingerprint on the machine, what the machine does is scan through all of its data. And if the data is matched, then in that case, your fingerprint is verified. There is another application of supervised learning. Next we have is unsupervised learning. Well, in case of unsupervised learning, there is no teacher and there is no label. What the machine does, the machine identifies clusters in it. It finds similar images and group them into a cluster. For example, over here, seeing some pattern in different images, the machine divides the entire image into 3 different clusters. Okay? Cluster 1, cluster 2, cluster 3. But the machine doesn't know that cluster 1 is an apple, or cluster 2 is an orange, or cluster 3 is a banana. All it knows that cluster 1 consists of similar item, cluster 2 consists of other similar item which are not at all related to cluster 1. And similarly, cluster 3 consists of different item which are completely different from cluster 1 and cluster 2. And cluster 3 consists of other similar item which are completely different from the item of cluster 1 and cluster 2. Okay, so this is what unsupervised machine learning is. So one of the use case of unsupervised learning is voice-based personal assistant. So the device which you are seeing on your screen is Amazon Echo, and the brain or the voice of Echo is known as Amazon Alexa. The device has many smart built-in to do a number of tasks like playback music, make the light blink. It also recognizes the name Alexa. It's like when you say the word, it recognizes the word and start recording your voice. Amazon calls this word as a wake word. So it's like when you have finished speaking, it sends the recording over to the internet to Amazon. The service that processes this recording is called Alexa Voice Services, or AVS. It's run by Amazon, thus converts the recording into command that it interprets. It's more than a simple voice-to-text service. It is a fully programmable service that can work with other online services to do a large range of things for you. Once authorized by Amazon, anyone can use this service for free to build a homemade Echo. Amazon has also offered sample code for building an Echo using a Raspberry Pi, which is a simple $30 computer. It might sound extremely selfless of Amazon to provide the service for free, but as always, they have their reasons. Amazon want others to build their service into their product so that they can sell you this stuff. So every product that has Alexa built in is a device that can be used to buy stuff from Amazon. These commands that Alexa interprets can be very simple. It's like if you ask for a time, the AVS sends back an audio file to Alexa telling you the time, which the Echo plays back. They can also be more complex. If you ask Alexa to play a Pink Floyd, AVS will search the music service to have you set up for Pink Floyd, and then send a command back to the Echo that sets it playing the requested music. Alexa can also work with other technologies in your home. It's like you can even set up your Philips Hue smart lights to be controlled with Alexa. You can ask Alexa to turn on the living room lights, and the Alexa will send a command to the Echo that sends a command to these light bulbs to turn on. It can also work with various online services. You can link Alexa to Uber, and you can request Uber by simply asking Alexa. You can link it to Domino's, and you can just order a pizza with your voice. So this approach means that Alexa can do a lot of things for you. And the list is just getting longer. Amazon is adding more features and skills to Alexa. And if you are smart enough, you can build up on their own. So it means that you can use Alexa to control things that are not even on the list. Okay, well, however, Alexa needs internet connectivity and AVS to work. If your internet connection is slow or it's not working, then Alexa won't be available and your Echo will be useless. So if Amazon decides to charge for a service or just close it down, then in that case, you'll be just left with a useless device. Well, Amazon is not the only one in town. We have Google, Apple, and Microsoft, which offers similar services that can perform tasks by voice command in the form of OK Google, Siri, and Cortana. They use similar approach, voice commands that are processed in a cloud service. But most of them are not as flexible or as integrated with other services as Alexa is. So whichever of these services end up being the one we all use, hopefully they will be as polite as Alexa. I'll just give you an example. When I asked her how she works, She replied, "Lots of people had worked hard to teach me, and I'm still learning more. Wouldn't it be nice if all of our appliances were that modest and polite?" Right? So let's move ahead. So another use case of unsupervised learning is Netflix recommendation. So more than 80% of the TV shows that you guys watch on Netflix are discovered through the platform's recommendation system. That means the majority of what you decide to watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. Let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you the list of movies and find shows that you might not have initially chosen. To do this, what it does, it looks through a thread within the content rather than relying on board genres to make a prediction. So this explains how 1 in 8 people who watch Netflix Marvel shows are completely new to comic book based stuff on Netflix. Let me tell you about a guy named Todd Yellen. He's the Netflix Vice President of Product Innovation. He has explained the working of Netflix as a three-legged stool. The three legs of this stool are Netflix members, the tagger who understands everything about the content, and our machine learning algorithm that takes all of the data and puts them together. So Netflix has more than 100 million worldwide users. If we count the multiple user profile for each subscriber, it comes to around 250 million active profiles. Now Netflix uses different kind of data from these profiles, like it keeps a track of what you guys are watching from your profile, what do you watch after completing your current video, and even what you have watched earlier. It also keeps a track of what you have watched a year ago or what you're currently watching and at what time of the day. Well, this data is the first leg of the metamorphical stool. Now what they do, they combine this information with more data to understand the content of the show that you are watching. The data is generated from dozens of in-house and freelance staff who watch every minute or every show on Netflix and tag it. Now all these tags and the user behavior data are taken and is fed to a very sophisticated machine learning algorithm that figures out what's most important and what should it weigh like. Or how much should it matter if a consumer has watched something yesterday? Should that count twice as much or 10 times as much compared to what they have watched a whole year ago? How about a month ago? Or how about if they watched 10 minutes of the content and abandoned it, or they binged through it in 2 nights? So how do we weigh all that? Well, that's where machine learning comes in. What those three things create for us is taste communities around the world. It's about people who watch same kinds of thing that you watch. Viewers are fit into thousands of multiple taste groups, and it's these that affect what recommendation pop up on the top of your screen. The tags that are used for machine learning algorithm are the same across the globe. However, a small subset of tags are used in more outward facing way, feeding directly into the user interface and differing depending on a country language and cultural context, as the tags have to be localized in a way that make more sense. For example, if you know English and you're watching Hollywood movies or movies in English, then in that case, Netflix won't recommend you German movies or Chinese movies or Japanese movie. Alright, the data that Netflix feed into its algorithm can be broken down into two types, implicit and explicit. Explicit is, for example, you gives a thumbs up to the series The Friends, so the Netflix get it. Okay, and implicit data is mostly the behavioral data. It's like you didn't explicitly tell Netflix that you like Black Mirror, but you just binged on it and watched it in 2 nights. So the Netflix understands that behaviorally. So the majority of the data is implicit. So this was about how Netflix is using machine learning to recommend you the movies. Fine. So next we have is the reinforcement learning. Well, in reinforcement learning, what we have is the agent and the environment. The agent selects some action using some policies. So there is no teacher in this case for training the machine. If the machine makes a right decision, the machine gets a positive point. If it makes a wrong decision, it gets a negative point for it. So repeating the process again and again and again, the machine learns it. So this process is of reinforcement learning. So let's take the example of a self-driving car over here. So initially, when the car was trained, so the car didn't know what way to choose. Okay. So what it did, it make an action, but the action it performed was wrong. So it got a penalty of minus 50 points for that. So from the next time, car realized that what it did earlier was wrong, and it updates its policy and then iterates the process. Okay. So this is reinforcement learning. So let me just explain you reinforcement learning with the concept of how Pavlov trained his dog using reinforcement learning. So this is a famous example of how Pavlov trained his dog using reinforcement learning. So it's like initially Pavlov gave food to the dog. So, in response to the food, the dog started salivating. Okay, this was before conditioning. Then, in the next phase, what he did, he just rang a bell, for which the dog did not respond anything. Okay, then the third phase, what he did, he rang the bell and then gave him the food. So, seeing the food, the dog started salivating again. Then, after that, he repeated this third step again and again and again until the dog learned it. Then, after conditioning, whenever Pavlo used to ring the bell, the dog started salivating. He understood that whenever the bell is going to ring, his master is going to give him the food. So, this is how Pavlo trained his dog using reinforcement learning. Okay. One of the application or the use case of reinforcement learning is self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. To err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive number of unnecessary deaths, lives that could have been saved otherwise through self-driving. So this is where self-driving cars comes into picture. The autonomous car or the self-driving cars are much safer than human-driven car. They are unaffected by factors like driver fatigue, emotions or illness. This makes them very safe. Self-driving cars are always active and attentive, observing the environments and scanning multiple directions. It would be difficult to make a move that car has not anticipated. So, how does a self-driving car work? Well, self-driving cars mainly rely on three technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensor available for a self-driving car. For example, sensor for blind spot monitoring, forward collision warning, radar, camera, lidar, and ultrasonic. So all of these IoT sensors work together to make navigation of a self-driving car. Next is the IoT connectivity. Self-driving cars uses cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditioning among others. This helps them to monitor their surroundings better and make informed decisions. And next is the software algorithm. All the data the car collects need to be analyzed to determine the best course of action. This is the main function of the control algorithm and software, and this is where reinforcement learning comes into picture. This is the most complex part of the self-driving car since it has to make decision flawless. A flaw like in case of Uber's self-driving car can be fatal. Okay? In today's world, the most famous self-driving car are those from Tesla and Google. Tesla cars work by analyzing the environment using a software system known as Autopilot. Autopilot uses high-tech cameras to view and collect data from the world, same as what we do with our eyes. It's called as computer vision or sophisticated image recognition. It then interprets this information and makes the best decisions based on it. So this was one of the use case of reinforcement learning. Okay.
To start with this linear regression, right? You all must be remembering the linear equation that we have, right? So what was that linear equation that we used to have in our school days? It was something like this, right? Y equals mx, sorry. So the form was y equals mx plus c, right? So the form was y equals mx plus c, right? This was the form of the equation that we used to be getting in our getting for a linear line, right? So we had this kind of line from that equation, right? It might be, it depends on the value of m and c. I am taking c somewhere is there, so this kind of lines we will be getting. And here, let's say this point is x1 y1, so for this one is x1, so this point up here in the line will be x1 y1, right? This point up here will be x1 y1. So for the value of x1 we have this value of y1. So in here, if you see this variable, this was used to be called dependent variable, right? Dependent variable. Why dependent? Because it always changes with the value of x, but x doesn't have any limit. So this is called independent variable, right? This is called independent variable. So x is independent, y is dependent, right? So that kind of equations we used to have. Okay, and this aim here, right? This aim here, this aim used to be called slope of the line, right? This was used to be called slope of the line. This c was some constant which can be zero also, right? C is some constant which can be zero. So that's what we had in our linear line equations. Now the thing is, how do we use this for our class, like for this linear regression models to be built? Okay, so the entire thing is based on this concept only, y equals mx plus c. It is as simple as that. So we will have some kind of a equation which will be in the form of y equals mx plus c. We will predict the values of the data points that is being sent to our data set when it is deployed, and then we will get the values of y. Okay, so that's what is the whole concept of machine learning, linear regression. So linear regression is a technique to find relationship between two or more variables. Yes, right. So if we have more than two variables, then how the equation will look like? It will be, let's say y depends on more than one, right? So it will be mx plus ny, sorry, nz, something like that. So mx plus na plus let's say pc plus d, kind of this kind of equations, right? So here it will have three variables, three independent variables, x, a, and c, right? Three variables we will be having in that case, right? Three variables we'll be having in that case. So that's where this machine learning comes into picture, and that's how this machine learning thing works. Okay, that's how the machine learning works. Now let's see how we are going to use it for our model. So that's why, so this is called linear because it is based on the equation of a linear line. Okay, it is based on the equation of a straight line actually. Okay, so as I told, change in dependent variable is associated with the change in one or more independent variables, right? So that's the basic concept of the equations. Okay, next is this picture. This is called Rex Thor, the dog bearer. Okay, so if you see the right hand side, guys who are aware with Avengers, they must be recognizing the right hand side guy is some kind of a Thor. It look like Thor. He carries a dog, right? Instead of carrying a hammer, he carries or a stormbreaker. He is carrying a dog, right? So he is named as Rex Thor, the dog bearer. So there is in the, we know, right, there are seven stars in the planet which has some kind of a shape. So it is one of them. Okay, this is a star pattern actually. So why we are taking this here is, this is the data point, right? In the left hand side, this is the data point, and this is how the thing looks like. So if you draw this line, then this is, I mean, you see like there is a lot of difference between lines, right? So that's how it looks, and there is a concept of r square. R square means mean squared error. Okay, that is also known as goodness of fit. Okay, that we will be covering in the next sessions. So you will see when r square gets minimum, that means the model has huge error. So here see the r square value is pretty small, right? It is 0.06. That means this line up here doesn't at all represent this model. Okay, so that's how this linear regression works, and with the help of this goodness of fit r square value, we can somewhat check the model's performance also. So that is a statistical test. At the end of the class, I will be telling you that, like the theory behind it, how those are calculated, and those part. Okay, so that is what is about linear regression. It's that much easy only. Okay, it's nothing more complex. More, not much of a complexity is there in the in this linear regression. So it's far too easy. So next, there are a few examples of linear regressions. Okay, so where, yeah, I told, right, Ravi. So r square I will be coming later. It is a mean squared error. So it is a goodness of fit test. That is a r squared test, you can tell. So I will be coming to that in the last part. Okay, I will tell you the theory and everything also. No need to worry. Okay. So this is the regression is a technique that displays the relationship between y and x, as you already know. So if temperature drops down, the guys will start putting more jackets, I mean, more jackets to avoid the cold, right? To keep them warm. So that's a straightforward relation between two variables. This is an example of linear regression. Okay, temperature versus number of cones sold at the ice cream store. If it's gets hot at outside, then the number of ice cream sold will be more, right? Inches of rain versus new cars sold. So that means in the rainy season, guys would like to avoid going out without their car, right? So that's how. Daily snowfall versus number of skiers. So if snowfall is higher, number of visitors at the skiing park will be increased, right? So that's how this works. Now this is the base of it. So if you think there is a relationship between two things, regression would help confirm it. That means if at all there is a relationship between those lines, let's say I will draw you a plot first. Okay, so let's say here is a plot I am drawing. Come on, why it is too large? I want something smaller. So if you see there is so some data points, let's say this one, say this one, say this one, this one. So see, here is a perfect relation, right? But again, this is not a linear relation, right? So if you draw it otherwise, if we say there is kind of a this line goes in, so this is the best linear regression line that can be fit in, then also this doesn't seem to be a good relation between them, right? So linear regression will help you to understand if there is any relationship between two variables or not. Okay, so that's how linear regression works. So you will build a model. If the model performs poorly and no ways you can fine tune the model, that means there is not much of a linear relation between them, right? If there is a linear relation, then it will look good, right? So the goodness of it would look good. So here is an classic example. So if you see, the values here are categorical, right? Why categorical? Because y only has two values, y0, y1, right? Only two values. So in this two values, if you see, they are categorical values, and it comes under a lambda shift function, right? I mean, sorry, sigmoid function, this kind of right, as kind of a function. So this is called sigmoid function, right? So that's how this thing goes in. Okay, so here if you draw the linear regression line, it will fail miserably. Okay, because if you calculate the r square fit for this, it will be too low number, because it is not at all a good fit, right? So this one is example of linear regression, this one is for logistic regression. So to see how this linear regression helps here, if you draw this line, if you build this model using this line, then only it will be cleared that there is no linear relationship between these two data points. Okay, these two data points. Okay, so that's how it goes. Okay, so next we will be going to a few scenarios when we can use linear regression, and when do we go for logistic regression. Okay, these are a few types or a few factors which will help us deciding that. Okay, so see here, first of all, it will be continuous. For linear regression, the variables has to be continuous. That means it shouldn't be categorical or skewed at any 2 points, right? So it will solve regression issues. That means it should be a good fit. Okay, good fit to a point, to some data points. Okay, and it should be somewhat, it should be represented by a straight line curve. Okay, so in this case is match, so then it will be a perfect fit for linear regression. So it has to be continuous variables. That means the spread of the data, it shouldn't be skewed. So it should be somewhere, it should be spread out evenly among this in the xy plane. Actually, it should have a straight line kind of a relation between them, and it should solve regression issues. Regression issues means where we have a lot of data, we churn those data to find out some basic data, basic inference. Actually, when I say this, both of these are supervised learning algorithms, so don't confuse that. So here what we'll have, we will be, for both the cases, for both the cases we will be having this values, right? Like we will be having training values, right? But here we will have some output, that will be spread throughout the I mean that will be somewhat significant, not some classification things like 0 and 1. The gender split, male or female, it is a classification issue. A spam or not, classification issue. Predicting housing price, linear regression. Okay, this kind of things comes under linear regression. So if you see if you build a model of I mean housing price predictor, there has to be some kind of a relation between all the variables, right? But for classification, it has to meet some criteria. There won't be any relation between those criteria individually, but there should be there should be a skewed value, and the variables will be categorical. Okay, when I say variables, so can anyone tell what is a variable? When we are telling variable, which one we are telling, like what we are actually trying to tell here when we are telling continuous variables and categorical variables? What are those? So if you get a data set, let's say there are 10 rows with 15 columns, so which one are we are telling about target variables? Okay, those parameters which impact the outcome, like dependent variables. So let's say if we have 10 rows and 15 columns, then 14 columns in that will be independent variables. Those are x values, they can go anywhere. Okay, the variables, the target variables will be the dependent variables, right? When we say continuous and categorical, that is the dependent variables, that is the y values, that is the outcome values, right? Because independent variables can be anywhere, right? It can be anywhere in the plane, correct? So that's why when we consider fitting a model, we shouldn't be looking at the feature first. We should look at what kind of output we are expecting. So is the output is somewhat categorical or regression? What is it? The outputs will be in continuous variables. Let's say housing price. If you have 10 lakhs rows of data, so you are most probably will be having all the numbers between 20 lakhs to 1 crore, right? Depending on the scenario. So that's a continuous space, correct? But categorical things, when we are deciding on mail classifier, spam classifier, right? Spam or not, it's two values, 1 0 or 1, right? So categorical things, right? So that's how we decide on this linear regression and logistic regression. Okay, so it's y here. It's Nancy, it's y here. So when I tell the outcome, that is a y, right? That independent variable. For x, those will be independent ones. They can go anywhere. Those will be the features of your data set on which you will build the models. When you say y equals mx plus c, this x will be independent one. It can go anywhere, right? So you really can't judge from that, right? Because for a categorical, I mean, if you think for a spam classifier, what all things can be there? What all things? Okay, let's forget it. Okay, think about Titanic survival dataset. So let's say you have the dataset of surviving from Titanic mishap, and you have all rows in there, right? So the values will be like sex, age, which parts they were in, right? So those things will be there, right? So let's say we have a housing price dataset. Okay, so in the housing price, what kind of columns you will have? Let's say area. So let's say we have a point called area. Okay, we have something called garden space. Okay, we have number of flats, amenities. These all can be realistic features. These all can be realistic features of your housing price predicted dataset, right? So with the help of this, we will predict a housing price, correct? Let's say we have a survival dataset. Let's say cancer dataset. Okay, so for predicting cancers, we have a dataset like that. For that, we will have internal or external. Let's say some kind of some things like that. Come on, again it went to scratch mode. Internal or external, right? Then we will have a size. We will have malignant or benign, etc, etc. Okay, so what it will predict, yes or no. So you have a gland growth, is it a cancer or is it not? So yes, no. These variable types are called categorical ones. Okay, this kind of variables. So let's say if you are trying to buy a house somewhere in Mumbai, this value will range from 1 crore to 5 crore, and you are most likely to get this area because of this different size, different types of area values. You will get almost all the values between this range. Let's say 1 crore to 2 crore. Let's not go to 5. Let's go to 2. Okay, so you will get all kind of values. So this is the things. Okay, so that's how you need to predict which one to use, right? So usually fixed number or possible. No, Saran, actually categoricals will be skewed. Okay, so it can be more than one also. Let's say we have, when we are thinking about this kind of categorical problem, it can be yes, no. It can be yes, no, or moderate like that. So it can be anything. It will be fixed. Okay, as you rightly told, it will be fixed. But for continuous, it will vary. It will be in a range. Okay, so that's how we decide if the data set that we are having is categorical or continuous. Okay, so based on that we decide, is it a regression problem or is it a classification problem, and based on that we are going to choose our models. If it's a regression, then we are going to go with this linear regression. Otherwise we are going to go with logistic regression, naive Bayes, or xyz. Okay, that's how. Okay, let's go for some let's advance with the course actually. So here is something that I have already discussed, right? We have already discussed, and that's why I took some time, because this thing. So that's the line equation. These are the some variables. These are called observables. This red points. This line is called line of linear regression. That means this is the outcome of your model. These points will be observations, right? And this will be regression line. And how do we decide if the regression line is a good fit or not? We use least square method. Okay, least square method that we'll discuss. Okay, so how do we do that? It's time to discuss that. I will show you with the graph. So let's say we have this kind of a line. Okay, let's say we have a point here. This is x1 y1. Okay, we have a point here. This is x2 y2. Okay, we have a point here. This is x3 y3. Okay, let's keep it to 3 lines. Okay, and somewhere down here, based on this line outcome, okay, this one is regression line. This will have separate kind of xy value. So for this one it will be somewhere here, for this one it will be here, and for this one it will be here. So these are like, here is the y value, here y value for this will be somewhere here, for this value will be somewhere here. So mean of them will be this one. Okay, let me change the color. Okay, mean of them will be this 3, so somewhere around here. This is the mean. Okay, this is the mean of y. Okay, which will denote as y bar. Okay, we will denote as y bar. Okay, now see the basic concept. How do we calculate? Okay, the basic concept of how do we calculate this? Okay, how do we calculate the r square? So these points, if you see, these blue lines are called error from line. Okay, error from regression line. Okay, if I write the equation, that is, we are going to, so as you know, the point distance, how it looks like, x minus x1 y minus y1, right? So that is basically this. So here x1 will be common in both, so it will be the value outcome of this AC line, that is squared error SE for line SE. I am scrolling it a bit up. So we will, what we have, SE of line will be y1 minus y squared plus y2 minus y squared plus y3 minus y squared up to n. This is the standard line error, because this is, if we consider this as y1 and all these values are x's, right? So when I write x, when I write y, that means y actual. Okay, when this y3 means y predicted. Okay, so sorry, I just reverse it. Okay, this is y actual, this is y predicted. So when I say y1 y2 y3, these are these points, right? So these are the original points that we have. So it will be y actual. Y means y predicted, that is outcome from this line. Okay, so y actual, y predicted, like that. Okay, for x1, for x2, for x3. Okay, this is what is denote squared error from the line of linear regression. Okay, this is what is denoted by this. Now I will change the pen color. So if we see squared error from y bar, that is y mean, that is from this red line. I was using a red, let's go back. So this is the point, this is the red line. So this one is the squared error from line. So here is the point. So this one will be the squared error from the mean of the data set. Okay, this is the squared error from the mean of the data set. So what we will have, we will have y1 minus y bar square plus y2 minus y bar square plus dot dot up to n, right? Now understand one thing, this value over here is how likely, how, what is the error between the linear regression line and the data points, right? This value up here is to find out the central tendency of the errors, right? So if you find out mean of these values, this y predicted values, and if you find out the difference between the actual points and the y predicted mean values, that means this is the variance. Okay, this is the distance and this is the variance. Okay, this part is the variance from all y values, this is the distance from each and individual y values. Now in order to get the r square estimate, that is the good fit line, or if it's a good fit or not, what we do, we calculate this value, that is SE line divided by SE y bar. Okay, we have this kind of a value. So what this denotes, how unlikely the line matches the actual values. Okay, this is what we denote by this part, right? Now if you want to know how good is the model, what we do, we subtract it from 1. This becomes our goodness of fit. For statisticians named it as R squared, or it is also known as least, this is also known as least squared error method. Okay, so this up here denotes goodness of fit. That means how good our model is. Now see what happens to this. Okay, after this I will pause for questions. So the value that we have, right? So the value that we have is somewhere like 1 minus SC line. So 1 minus SE line divided by SE y bar. So if AC line is pretty smaller, right? What does that mean? The line is a really good fit. So this is small divided by AC y bar. This will also get very small, right? If the difference between each and individual data point is small, this will also get somewhat small. A small number by some number will yield you a small, even a smaller number, right? So that will approx reach to 1. Okay, but if for this equation, the the SE line gets higher and we have a CY bar which will get even higher, which will get somewhere around this, right? So, but it shouldn't be, as this is the higher but less than AC line, so we will have a high value up here. In the AC line we will have a high value. Okay, so this so how it works, this AC y bar, let's say for this equation, if we go back, if the points are even more down, right? So from, if the point is somewhere here, so somewhere here, all the values will be bigger, right? Based on this AC bar and the AC line, all the values will be bigger. So when we divide two big values, it will almost come to 1 and r square value will approx to 0. Okay, so that's what means when r square is small, bad fit. Okay, when r square is large, good fit. Okay, that's why this value r square is named as goodness of fit. Okay, so that's what is about this goodness of fit equation. Okay, these things I already told, this xy things. Now here is an example for you guys. Okay, so we have a few data points, we have plotted all this in the plot. Okay, we have plotted all these data points in here. Okay, now we will see using linear regression how do we calculate this. Okay, so x bar y bar is there, that is the mean of x and mean of y. Mean of x is 3, mean of y is 3.6. Now this is the line, this is the line, and this is the mean point is described with this red point, and this line, right? This green line is for the I mean the mean line. Okay, this is the mean line that we have, that is the y bar that we have. This is the mx plus c line that we have drawn till now. As we know from maths, this is the equation for m, that is the slope. That's how we calculate. So once we calculate m, you will see the value here. I am just scrolling through. Okay, these are some calculations, so I am not wasting time. So that's how we find out the value of m. Okay, so what does that mean? Let me show a few use cases. So if this is the line, now we need to find out value of m. M is x minus x bar into y minus y bar divided by x minus x square, x minus x bar square. Okay, now if we go in, so x minus x bar, when we calculate, that is the difference of the data points from its x mean. Okay, x mean. So these are the data point differences. We calculate this here, we put into the equation, then we go for difference of y, that is y bar, because we need to calculate y minus y bar here, right? So this will be the differences. So this one will be the difference, this one will be the difference, like that we will calculate. Okay, so that's how we will have y minus y bar. We already have x minus x bar, we will square it out here. Then we will find out m by summarizing all this. We will sum all these things up and we will divide it by sum of this thing and we will get the output. Okay, we will get the output. So here m value goes to 0.1. Okay, now y will be 3.6, m will be 0.1, x will be, let's say for 3 we are calculating. Okay, for 3, x equals 3 we are calculating, because as we see, for x equals 3, the mean is 3 and 3.6, right? So for x equals 3, the mean, we are calculating based on the means here. Now we will get the c value here, that is 3.3. Okay, so our straight line equations now becomes y equals 0.1x plus 3.3. Okay, so that's how we do calculate our linear equations. Okay, so this is the linear equation that we got from this data set. Okay, now what we will do, we will try to predict the values of x equals 1 2 3 4 5. Why this formula? That is the formula for m actually, Ankur, that's why. Okay, so that's how. So now what we have, we have the straight line equation, we have the actual values of x and y's from this data set, that is from x equals 1 2 3 4 5. We have the values of y 4 3 4 2 5, right? Now we will predict using the equation that we got to test our model how good it is, how good our model fits our actual data points. Okay, so this is the line y equals 0 points y equals 0.1x plus 3.3. so 1 2 3 4 5 we have. Now if we go on calculating all these values, we will get something like this. Okay, so this is again calculated wrong, this will be 3.4. anyways, just leave it. Okay, no need to worry about it. The values here are might be here and there, values here might be here and there, don't think about it, it's fine. If they have made some mistakes might be, so just ignore this. So we will have these values as an outcome from our model. Okay, now we will find out the r square. Okay, we will find out the r square. Okay, so we will go to it and we will try to find out the r square values. Okay, so as you know, I told yp minus y bar square by y minus y bar square, right? That is r square, and it should be 1 minus. Okay, that's what would be r square. So y predicted minus y mean divided by y minus y mean square, like that. So okay, it is somewhat okay, got it. So in this equation that I have shown, if you subtract 1 from it, it will be something like this. Okay, if you subtract 1 and if you solve the equation, it will be something like this, or else you can go with the equation that we have taken also, both are fine. Okay, this is the minimalized version. So when we say that, that means, when I say that, so we have 1 minus AC line by AC y bar, right? So if we solve this, it will be AC y bar minus AC line by AC y bar, right? So what is AC line? Is y1 minus y square, right? What is AC y bar? Y minus y1 minus y bar square, right? If you equate, how it will look like? If you equate how it will look like, it will look like y1 minus y square divided by, sorry, how it will look like is y1 will cancel out, so we will have, sorry, I wrote it wrong. What we will have? We will have, sorry, y minus y bar square divided by AC y bar. What is that? That is again y1 minus y bar square, right? That's what we will have, right? So when we do this, we get this equation. Okay, so that's why r square is written like this. Okay, that is also an equation. So if we go and calculate, we will see the r square value what we are getting. It is 0.36. Okay, so that is a small value, so this line is not good. So in the next step, what we will do, So we will just turn the line. Okay, we will just change the line equation, and we will just try to check how our model performs. Okay, so till we get a good r square value that is almost equals 1, we will keep on rotating the line till it fits the entire data point. Okay, till it fits the entire data point. Okay, that's how this goodness of fit works. Yeah.
Can you just take out to the slide where the M formula is given? It's a statistical formula. Something
Yeah,
x
right.
minus x. Yeah, can you just check it out?
Yeah, yeah, this one, right? X minus x bar,
Yeah,
y
right.
minus y bar by x minus x bar square. Yeah.
So when I'm changing n, I'm changing x even, right? If I change it, I'm thinking very mathematically. If I change
Yeah,
m, the formula,
yeah.
my x values should also change as well as the y values.
No,
That's big since
no.
the
Only
formula
y
is
value will
printed.
be changed, right? No, no, no. Only y value will be changed, right?
Okay, so
So
means
when we
only the
say
y minus
y,
y bar section will change
correct.
in
Yeah,
that
think about it.
formula.
Think of just if you go mathematically, x points won't. So see, this is. I mean, if you try to fit it with the, I mean, see, so if someone is from stats background, he will get this far too easily, or if someone has done some study before coming to the class of stats, it will be really easy. If you think from the maths point of context, then we are not at all worried about goodness of fit, right? We will get some equations, we will find out m and c values, and we will just go ahead and fit the line, right? That's it, our job is done. We no need to check, even we no need to check if it's a good fit or not, correct? Now this goodness of fit testing comes into place when we are working with a set of data points where we are worried about the model that we have created, the hypothesis that we have taken. So this is basically the null hypothesis. You can consider it like that if you go to the stats. So see, when we come to machine learning, one thing has to be remembered. It is, I would say, for my experience, it is 50 to 55% of stats, 30 to 35% of algorithms, rest of the portions are for your intuitions and programming. Okay, so that's how it works. So that's why stats needs to be crystal clear for machine learning. It has to be. So what happens is, when you try and predict the values of y, and if you try to see if the model fits well or not, right? So you now, here comes the picture. So how you can change the line to fit, make it better. Okay, how you can change the line? X value won't change if you, because x values will be fixed, because you have already been provided with a data set. What it can change is the outcome values, right? X will fix, but the outcome from the linear regression line, I am not talking about the target variables that is already there in the data set. Okay, I am talking about the predicted values that you are predicting with your model. X won't change, this y alone can change. That's what the concept of linear equation, right? Y is dependent variable on on x, right? X won't change. So if you change x, the whole data set will be lost. So what it will do, you can change the m and c values to find a good fit for y. Okay, x bar won't change, Azam, because x will always be fixed. Y bar will be changed because the output of your linear regression line will be changed. Okay, so that's how we keep on changing our models. We keep on changing the hyperparameters. That's what these are called. This m and c are called hyperparameters to a model, right? So when we change m and c, the entire equation of y equals mx plus c will yield you some other result. So that's how you can tune in y, the output value. You can tune in to try and match with the exact data set that you have. So if y bar changes, y will automatically change, right? So that means it will help you in two ways. It will help you in reducing the squared line error. Also it will help you in reducing the error between the mean and the data points. Okay, that's what this works. That's what this linear equation works. And for that to change, you need to change the m and c values. The hyperparameters will get changed. Then you apply the goodness of fit. You will see if the value is coming near equals 1, then it would be a good fit. If it doesn't, then it wouldn't be a good fit. You would need to go for another iteration. Okay, so that's what it go that's how it goes in. Okay, that's what the concept of this is. Okay, so is this clear now, guys?
No, here m is a mean, right? This m point 0.1 is a mean, right?
No, m is the slope, right?
Slope.
From
Okay.
the straight line equation y equals mx plus c, the m is the slope, right? M is not the mean.
Okay. How about the C? How are you going to calculate C here?
That's a random variable, right? You can change it according to your need. So if you need it bigger, so it is a constant, but it can be changed also, right? You can change c, because c, if you want to change the line, how can you change it? You need to change m and c. So let's say some point is sits at 0 0, right? So you need to make c value 0. Simple. Yeah, c equals y minus mx, correct. So once you find out the m values, you can find out the c value. So c also will get changed if you change m, right? That's what the idea is. Okay, so that's how this things works. Okay, so
So
that's how
ba-
it is.
so basically, you will try to fit all these points in that good fit. So based
Not
on that,
all, but we will
it
try to
makes
maximize the r square value. Okay,
so whichever the good fit from there, we'll take the value of C.
correct,
That
correct.
okay.
Now I will go to how it is applied to machine learning. Okay, this is all the stats one. It is not, machine learning hasn't started yet. Okay, now I will show you how you can do this. Okay, so let's go ahead with this. So as you might be already aware, I discussed in the last class about the terms like features and there are a few terms, right? Features, target variables, outcomes, hypothesis, and all those. Now you will see those in action. Okay. For machine learning, what we have for linear regression, actually, what we have, we take for machine learning in general also, we take a hypothesis. Okay, and hypothesis will be h theta x. Okay, and when we write the equation for linear regression, it should be theta 0 plus theta 1 x. This theta 1 is equivalent to m. This theta 0 is equivalent to c. Together, this theta 0 and theta 1 are called hyperparameters. With trial and error, we can change these values of theta 0 and theta 1 to get a good h theta. That is, this h theta value will be the predicted value. This will be the predicted value. Okay, so that's how this predicted value will be calculated for a machine learning. For machine learning, that's how this h theta of x will get calculated. Okay, so h theta of x will be equals theta 0 plus theta 1 of x. Okay, that will be the equation when we come to the machine learning world. So what do we do now? How do we apply x? So when I say x will be the feature vector. That means columns of a data set, right? That's what is called feature. So this h theta x we will calculate based on the features. So everything here is a vector. So when I say theta 0, this is constant, plus theta 1 x1 plus theta 2 x2 if we have more than one feature, theta 3 x3, and this will go up to theta n xn. Okay, that's how this equation will look like when you try to write this in a machine learning format. Okay, so this h theta x will be our hypothesis. This will yield you the values of predicted y, values of predicted y, right? What will be the equation? This will be the equation. So if you carefully see this equation, x1 can't change. What can change is theta 0 and theta 1. So in real world, how do we go of it? First of all, what we do, we take a constant value of theta. That is, theta 0, we can make it 0 or 1. 0 is the standard approach to start with. So then what we will do, we will calculate, we will take some arbitrary values of theta. Okay, to calculate this equation, we will take out the h theta of x, that is our predicted value, using this equation. This theta vector, this theta vector is based on, we will take some, so this theta vector is also called weightage vector. Okay, what do we mean by weightage vector? Think about survival data set. Okay, think about house price, house market. I mean, what should you think about? What should you think about? Let's say, I mean, housing price calculator. Let's go with the classic example only. Housing price. Now, for housing price, just, I mean, for housing price calculator, as this matter that what color is the building? What color is the building? So, when you are going to buy a flat, will that matter to you? If the building that you are going to buy, I mean, the price of it, it can matter to you, that's obvious. But will the price depend on this? What color is the building? Price won't take this into account. So we can vanish this variable. So we can take theta of color to be 0 because this is nowhere related in the data set, right? But if you see area, that is a huge point. So we will give it a good weightage. So let's say theta A, we will give it a good weightage. So that's how you need to, yeah, you can have it 1 also, you can have near to 1, anything. So it will be depending on your model. I will come to it. So this theta values will be calculated based on the model that we have. Okay, this theta value we will keep on changing. So in order to, so what is the basic? Again, I am repeating these things. Luckily, you no need to code it or you no need to do this manually. This will be taken care by Python itself. The scikit-learn package will take care of these things, this tuning, this theta parameters. Okay, our objective would be to get a good fit of our model by changing this theta parameter. Let's say if by mistake, so this color variable, right, this will have some arbitrary values, right? So what we will do, we will have pink, green, black, like this. We will convert this into categorical values. So there might be hundreds of colors from 0, 1, 2, 3, 4, like that. So if you by mistake apply a very high weightage to this color variable, this color vector, so let's say theta color, if you have taken a very large value, so when the color value reaches about 100, it will hugely destroy your model, right? Because that is not at all taken into account while deciding the price of the house, right? So in the next step, what you would do, you would do this theta hyperparameter tuning. You will check for this unusual, I mean, check for the values when you won't be getting this kind of a error, and you will try to get a good fit of the line. Okay, you will try to get a good fit of the line. So when the algorithm works, what it does, it will take into account all features, then it will predict value, then it will check for fit. Good fit line will be returned. The best fit line from all the equation will be returned. So all this feature vectors that we have, all the theta vector that we have, it will change on its own and then it will return you the value. Okay, so that's what will be the task of this linear regression equation. Now, as a machine learning engineer, what would be your say in this? Your say will be to check these things, okay, to check the values. Do we have this colored data set? Remove that, no need to give machine the extra headache. Do so how does the model reacts, how you can make the performance better? For this house, one thing we all check for, right? Price per square foot, right? We always check for this one, correct? If this value is not there, if the feature is not there, introduce it. It will hugely increase your your model performance, correct? If you don't have this amenities field, amenities does make your house price go from 0 to hero, right? Because if you don't have a library in your if you don't have a library or open playground in your complex, versus if you have it, your model will change radically, right? So amenities will play a good role. So amenities, if the number of more the amenities are, the bit higher the prices are. Okay, so that's how, and that's what will be your job, to check the values that is being returned And yes, exactly, we would need to select a proper model will be selected by the machine learning algorithm only. We would, yeah, your task will be to validate the requirement, validate the model. Theta value will be linear regression, yes, right, by the algorithm itself. This theta value will be taken into account. Okay, your task will be to prune that algorithm, because the machine won't have the domain knowledge, the machine won't be having those much of knowledge as of you, right? So that's what will be your task. Your task will be to tune the model. Your task will be to find the best fit. You can introduce features to the dataset also, right? We have seen, like, we can do that. I have shown you, right? So these things will take into account. These things will help you in deciding all these things. That's how you will decide the h theta that you are going to take. You will, that's how your machine will help you. That's how your algorithm will help you to decide this. Okay, we can change the base alone based on our knowledge, yes, right, but this will be taken care by the model itself. Okay, the model will return you the best fit. So no need to worry. This theta values manually will be changed by the algorithm, and it will return you the best fit. So how it will return the best fit? It will use two concepts called cost function and, so when I am saying the model will return you these things, it will use these functions to return you the good fit. Okay, these things just remember. Okay, these things just remember. Or what you can do, if you forget this, just go ahead and Google this a bit. You will have a really good picture of it. Okay, so that's how this thing works. Okay, that's how this machine learning things works. That's how from y equals mx plus c can be transferred to a multivariate machine learning, and you can apply it to apply the machine learning model to it. Ankur, all variables can change. You need to figure out the best variable. Okay, the best variable that will introduce more. Like for approving a loan, you will take credit score into account, right? Credit score into account. That will help you in applying the loan. You will need to check if the guy is salaried or professional, right? That will help you. Okay, so these kind of things you need to check to do build a good model.
So you want to say that
Okay.
which variables are the related each other, so we have to find it out, and so that it will be good, we'll get a good fit line, right?
Yes, correct. So how you can find that out? You can find that out with correlation matrix, right? If
Yes.
there is any relation or not, right? So that's why I am trying to focus on this, trying to focus on the stats concept hugely. What this correlation means, how this machines can be treated, how this R square value can be calculated, like that. Okay.
So one thing here, which before starting anything, so we have to first check is to go to the check for R square, correct? Whether data is good or something is there, right?
If you don't have a model, right, how can you check it? So first task will be to build a model. Then you can check for
Correct.
the R square value, right?
Mm-hmm.
Related values should be passed as dependent. Yes, right, Ravi. So that's how. So you need to find out which values. So see, this will come in two ways. First, stats will help you. Next, your domain knowledge will help you. Okay. Once you have this two, this will help you to get the good model. Okay. Okay. So that's how.
Okay.
Yes, Nancy. So hypothesis is just a random guess. Okay, let's say the thing I was telling, like India will win the World Cup. That is a hypothesis. Okay, it's a random guess. So if you are familiar with mathematical induction, right, how we used to do, we used to take a null hypothesis that will be true for x equal n equals 0. Then we will prove it for n equals 2. Then we will prove it for n minus 1. Then we will say it is true for n also, right? Like that we used to do mathematical induction. So all these things that we take into account is a hypothesis. So that's just a wild guess. So when you are saying h theta x equals theta 0 plus theta 1 x1 theta 2 x2 like that, so that becomes our hypothesis, because we don't know the values of theta 0 theta 1 yet, and we are going to predict something. So now based on our testing, the goodness of fit testing, or how we do it, I will show you right now. Goodness of fit testing, how good the model is, how good the hypothesis is, that's how it works. Okay, so it is basically just a wild guess. So it will be the first equation that you derive from. So this is theta was theta 0 theta 1. Well, you need to start from some value, right? So that's what I told, like you using trial and error, you will visit all the values of theta for which the cost function will get minimized. Okay, so the first hypothesis is will be the null hypothesis. So for that, let's say we are taking theta 0 as 0, so that will be the null hypothesis. Okay, then we will keep on continuing this. So that's what is about hypothesis. Okay, so that's how we have it. Yeah, no mentions. Okay, so now let's see what is cost function. Okay, so we have seen this r square, right? R square is goodness of fit that we have seen, right? If you now what we will do, we will calculate cost function of h theta x. What will be the cost function? How do we go about it? So if we have m number of data points in our bucket, then this will be the equation of cost function. Okay, so what is it? R theta is square. This is for each and individual point value of r square, we will sum it up and will divide it by twice the number of data points. Now our target will be, our model's target will be to minimize this, to get the best model. Okay, we need to minimize this cost function value to get a good model. Okay, so for that what we can do, as I was telling, for goodness of fit, we need to change theta values to achieve this. Now graphically, if you see, I will draw some kind of a plot which will be known as, which is known as contour plot. If you don't know it, don't think of it. Okay, this kind of plots are called contour plots. Sorry for my bad drawing. So let's say this is the mean of the data point. Some data point is in here. So by changing the theta values, we will come inside. We will come here, then we will come here, then we will come here, then we will come here, like that. Okay, so this is called gradient descent algorithm. This is not at all required, just telling you the basics. This gradient descent just to show you what is it. So using this gradient descent, we try to arrive at the minimalistic cost function. Then we will have the values of theta, like from the gradient descent algorithm itself, we will get the values of theta for which the cost function gets minimized, and then we will apply those theta values into this equation. So that will yield you the machine learning model that you are trying to build. So the concept is, using gradient descent, we will minimize the cost function for the data set. And after that, once we get the hyperparameter values, that is the theta values, we will replace those in the main equation, which will yield you the best possible values, the best possible equation that can be derived from the model. Okay, so that's how your entire linear regression algorithm works. Okay, so how do we go about it? Let me tell you in 3 simple steps. First step, we will take a null hypothesis that will be theta 0, theta 1 x1, theta 2 x2, like that, based on the number of features that we are going to supply to the model. We will find out the value for the predicted value, that is the value for the h theta x for all the data points. Then the next step will be to calculate the r square value for each individual sets. Okay, so we will have some kind of theta 0 values, right? So for that we will calculate the r square values for all theta sets. We will sum it up and then we will find the minimum value. So how do we find the minimum value? We do it using gradient descent. So gradient descent itself has a very large base. I am not going into that much detail, that won't be required. So it will be, there will be derivatives and all involved to get you the minimum value. Okay, to get you the minimum cost function value for some theta value, you will get the minimum cost function, which will then yield you a good result. Okay, which will then yield you a good result. So using that, you can, so using that you will get the value of it. Okay, so using this using those theta values that is returned by the gradient descent algorithm, you will get the model equation. So you will arrive at your original model, and after that you can start predicting. Okay, after that you can start predicting with that model. So whatever unseen data comes into picture, it will be predicted, and with the help of this gradient descent and goodness of fit test, it will yield you the ideal theta value of theta. Okay, ideal value of theta. Okay, so that's how we have it. Okay, that's how we have it. That's what is about this linear regression as a whole.
Regarding the hypothesis equation, we saw that h naught x is equal hx is equal to h naught plus h1x, and as well as it goes on, right? So if I
Yes, h theta x equals
want to
theta 0. Yeah, right.
right. So now we are right now my objective is finding out the theta naught values for individual prediction for x, right? Is
Yeah.
it what I'm doing? Okay, fine. So after that we are trying to minimize it, right? That's
We
what
are
gives me the
trying to
best prediction.
minimize the cost. We are trying to minimize the
Cost
cost
function,
function.
right?
That is, we want to minimize
Okay.
the error in the model. That's why
We want
we are not
we want to
minimizing
minimize.
the theta values.
Okay, so how it is different from R square, what we did earlier for the linear regression model? Like in R
It's a
square, I was seeing that we were trying to make it as nearer as to 1. But right now I am
yeah.
like trying to decrease it to almost nearer to 0. So
Yeah,
how
so
it is,
if you
how can I relate
see, right? Yeah, if you see here, I have taken a summation of it, right? And I have taken a summation of it and I have divided with a 2m. So that is what the cost function look like. So it is nothing but finding the best R square value. That is R square. If it goes near equals 1, then that will be the best fit of the model. And if as I am dividing it with 2m, it's a very large number, so it will be minimized, right? So that's why we are telling that we need to minimize the cost function. As we are taking the summations, that's why it is like that. So when I say summation, that means for each an individual point we will be calculate this r theta square values. Okay. So if what is the thing is, if we have this fancy equation of r square, right, this AC line by AC y bar, right? So here now for AC line, instead of y minus y1, we will have a theta value included, right? So where is it? Yeah. So y actual minus y predicted is now h theta x. So we will have a theta component for each of these equations, right? So that's why I have written it as r theta j. Okay. So that doesn't mean that it is for all other points, but it is for the entire equation. Okay. So if I calculate this value, this r square has to be somewhere near around 1 to get a good fit. Okay. So that's why we are, when I say minimizing the cost function, means not the value. Okay. It's the whole idea that r square has to be near equals 1. So that's what is referred to as minimizing the cost function. Okay. It is not like that we are reducing the value of r square. We are not looking for a small value. When I say minimize this, that means we are minimizing the value of cost function to get a good fit. Okay. So that's how the things are. The
uh,
r's
just to add up, Abhishek, what you consider better, like making r square almost equal to 1 or cost factor almost equal to 0? Which one would be I would be considering as a better fit? Or
for
is
same
it
thing, right?
interdependent? Is it interdependent? Like if my r square will be almost equal to 1, then my cost factor automatically will go down to 0.
So that won't happen, right? From the equation only you can see. So the idea is you need to have a r square. That's what I am trying to explain, right? When I say minimize the value of cost function, that means get the best fit out of it. So how you can get the best fit out of it? By getting this r theta square as the highest, right? So that's what it is. Okay, so it is, we are not like that cost function value we are trying to reduce it to 0. We want to find out some cost function value for which the r square will be near equals 1. So that's how it works. Okay. Minimize, don't take it as the term goes. Okay. But cost function, as the name indicates, we should take its minimum value. Okay. So minimum value means best case. For r square, that is, there are other estimates also for this error. Okay. R square is not the only one. So we have log likelihood and others also that you will see in the later classes. So in the all the cases, I will use the term like minimize the cost function. So when we say minimize the cost function, that means try to get the best fit out of it. So for r square, that is least squared error, when r square is really equals 1, and as we are dividing it by 2m, right? So it will be smaller. So that way we need to calculate. So r square has to be 1. For getting a best fit, r square has to be near equals 1. Okay. So that's how it works. Okay. So is this clear? That's not much we are doing. What we are doing, we are at first we are calculating the coefficients. Okay, the theory part that I have told till now, it is just to visualize that. So if you see, we are taking a data set that is x equals 1 2 3 4 2 1 to 10 and y some arbitrary values. We are trying to calculate our line from it. Okay, we are trying to calculate a line equation from it. So see, for the first step, what we are doing, we are trying to calculate the coefficient of it. So from the formulas that we have seen, np dot mean x, np dot mean y, like that, those things we have calculated, and we have calculated the calculated using the same formula that we have. So ssxy divided by ssxx, that's how the formula was, right? That's how the mathematical formula of slope is. So b1 here refers to the slope, okay, and b0 here refers to the coefficient, so that is y minus mx, right? So these things we have calculated, b0 and b1, and then we have plotted this x, y, and b, right? We have passed in x, y, and b to the plot regression line function, in which we have calculated the predicted y values, that is b0 plus b1x, okay. Then we have plotted those values of x and y predicted with a green line, okay, with a green line. So this is the predictor line, okay. In the x-axis we have set the size, and y-axis we have set the cost, and we have shown the line. So that's how your models will look like in the real world, okay. So these data points will be your feature vectors, and that's how your model will look like, okay. That's how your model will look like. And and we have printed the values of estimated coefficients as well, okay. So that's how you by yourself can build this. Now in the next step, what you can do for getting linear regression, you can try adding the r square to it and looping it through, okay, looping it through all the steps, but that won't be required, as we already have this functionality available in scikit-learn package, okay, in the scikit-learn package. So when we see examples of logistic regression, I will show you this, okay. So we have seen two kinds of linear regressions, right? For one type of linear regression, I have shown you like theta 0 and theta 1 x1, okay? For the other one, I have shown like there are x1 to xn values. So the first one is called single variable linear regression.
So y equal to mx plus c is a single variable linear regression, correct?
Yes,
And
yes,
theta
correct.
1 is the multi-variable linear regression.
No, not like that, not like that. It will be always of the form, I mean, mx plus c, okay? So if you have only one independent variable, that is single variable linear regression equation. If you have multiple, uh, yeah, univariate and multivariate, right? So for multivariate you will have I mean more than one those things, right? Those, what are those called? Those are independent variables, more than one independent variables. Yeah, so more than one independent variable, multivariate, a single, only one value we are taking, that is univariate, okay. Now we are looking at this fancy Boston house data set, okay. So this is for calculating house prices. So if you see here, these are the data description. So see, this is our target variable, median value of owner occupied home in thousands. So whatever values you see, those are in thousands, okay. So LSTAT is percentage lower status of the population, and all those kind of stuffs are there. There are some fancy explanations are there. So what we will do for the first example, we will take these two variables like LSTAT and MEDV. Okay. So let's see how it works. So also, in order to go through that, the checking correlation is a very important thing. Here it is not given. It is just to illustration purpose, but in the real world you will need to do it. Okay, you will need to check that. Okay, so here is the data set. As you all know, we read it using pd.read.csv. We read that, we check the step, we check the first 5 rows, then we are checking the mean, median, mode, and standard deviation, this equations. So now what we are doing, we have taken out the two in the dependent and independent variables. So LSTAT here will be independent variable, and MEDV will be dependent variable. So this is what we are going to find out. So here is how we read the files, right? Read.csv. Then we are seeing this data.shape head and all those. Then last we are checking the distributor stats. Now here we are taking out the independent variable here and dependent variable here into another data set, because this is a univariate example. So we will take only 2 data points. Okay, we will take only 2 data points. Now see here, we are seeing a kind of a, we are now plotting the data points, right? We are plotting the data points. So see, this kind of equations are there. Now there you can see the some kind of straight line will get automatically fit here, right? Let's see how it works. Okay, Okay, next is preparing data. So what we are doing now, what will be our next task? Our next task will be to prepare the data to see if there are any anomalies or not. So we have taken out LSTAT and MEDV, these 2 points from the data set that we have, okay. Then what we are doing, we are now doing a train test split of 80-20. As I shown you in the last class, we are taking out the split. Now see the size, it is like that. So we have 404 values for training and 102 values for testing, okay. So when I told you, right, for scikit-learn we have everything handy. See now what all we have wasted time for last 2.5 hours comes down to this single line: regressor is equals linear regression. That's it. All the things that I explained is there inside this linear regression model, okay, linear regression function. What we are doing, we need to pass the x values, x and y values. So x train it. So next line, what we are doing, we are fitting the line, right? Regressor dot fit x train y train, right? So now we have a model ready. That is the theta parameters and everything, those things are done already, and we have a linear regression model in hand. So now we can use this to predict the outputs. So see, these are the coefficients and intercept values that is being calculated from the model itself, okay. These are the regression coefficients. So if you count the regression coefficients are basically the values of theta that it has taken for all the iterations, and intercept is the intercept value that it has chosen, okay. Now we have this y predictor. What is the y predicted? uh, 13 not aligned. What is it?
So you want to say the C is the coefficient, that is the constant, right?
Yeah, 1 second. Y pred equals predict progressor dot predict x test. Yeah, so what is the problem? Yeah, sorry, go ahead.
That coefficient is the C is the constant, right?
Yeah, yeah. So again, I told, right, like Vibrant white is not okay. Okay, see, so coefficient is fixed for a iteration, right? But we can change it. That's what
Correct.
the whole idea is. So that's what
Yeah.
is regression coefficient. So these are the iteration values for each and every iteration. This type of values got changed. Okay, so that's why this matrix is thrown out. And intercept is 37.9. That's how. So next task will be to get you the predicted values. Okay, we will now predict the x test. I mean, predict the values using this model. Okay, so that's why. So but this is not working somehow. I'm not sure why. It was running before. I think I haven't run something. That's why. Let me run this once more. Yeah, okay. Oh, okay, not x test. Sorry, I messed it up. Sorry. Yeah, see, this regression coefficient is single value, right? The earlier why it was showing multiple values, because I ran these examples also, this multivariate is examples, right? So those regression coefficients were for all the terms that we have, that I will come to later. So this regression coefficient, as you see here, returning single value, right? So this is the regression coefficient value that you have. Okay, so that's why it was not running. Okay, so this is the value for regression coefficient for the single one. I was just out of context. I was thinking that I am explaining multivariate, but this is a univariate one. So that's how it will be. Okay, so for a univariate one, it will be returning one value. That is it. This is the last value of regression coefficient. Okay, m is the intercept value. That is what is called intercept. Is m is called intercept. Okay, so that is the value of m. So now our equation be like y equals 34.33 x plus c. X is LSTAT, like that. So next what we have done, we are seeing the y predicted values, okay, and we have y test values. Okay, now what we can do, we can plot this also. Okay, we can plot this also. How do we plot it? We can plot it like this. Give me a few minutes. What is happening? There's no attribute ends with. What does that mean actually? Again, same error. Okay, give me a second. I will fix this. Just a second. Oh, okay. No. Why we have this else stat? Okay. Why train name is also coming, right? That's why it is not taking into account. So why that is coming? Okay, xtrain x is caps and xtest x is caps. Yeah, fine. So next, if I print xtest, what is happening? Okay, I'll start that first column is coming, right? So leave it. First row, leave it. Still start is coming. So what I was trying is I was trying to plot the x predict and y predict values to show you guys how good the predictions are. Okay, anyways, that is not being and that is not happening somehow. I might be doing some silly mistake. I will check and tell you. Okay, not an issue. I will check and tell you. So the let's move on for now. So
Yeah,
yeah,
can you please explain that parameters for the linear regression? What is
which parameters?
yeah, that those parameters were passing through. So is there an additional parameter we have to pass, or this is the minimum parameter we need to pass? X
These are the
copy
minimal
true.
ones. These are fine. These are fine. No, these are
First we
not
have to
not anything. Okay, these are not anything. These don't think about it. This is the model that is being returned. Okay, these are the models that is being returned. That will always be true. So these are some of you advanced level of things. So this we can check later on only. Okay, so these are some advanced levels we can check later. No need to think of it now. So just think one thing. This is the line that we need to write. Okay, x train y train value you need to pass. Then the linear regression model will pass you this kind of a linear regression model. Okay, this equation will pass you this model. Then you can have this. So these are controlled. You can control this by passing the parameters explicitly here, but that is not advisable. You should leave it up to the machine. Otherwise, the machine performance might get might be hampered. Okay, so that's how. Okay, it will return you some intercept and coefficient values. So next step will be you can predict the values of x test and y test like that. So that's what it is. Okay, so that's how this works.
so X
Okay, so
test
that's
is
how
a
this
user
works.
defined. So X test is the user defined parameter, or it is
Yeah,
by
so
constant?
this is the train this is the train test value, right? So why should it be constant? You need to pass it, right? So you when we discussed yesterday that we need to split the data set into 80-20 percentage of x train, y train, and x
Correct.
test, y test. So these are the value
Agreed.
names, right?
Okay.
Right? You got it?
Yes. Thank you.
Yeah, I understand this part. Like what you are, the phase that you are going through is because you are saying too many things that you are getting confused, right? I know that. No issues. It happens.
So basically, what we are trying to do, what is our problem here? Like, what problem statement between the
So that's it
two?
told, right? We need to find out this MEDV value. That's what we did, right? For all this long. That's what I explained. So see here predicted value is 27.37. Here it is 28. So I was trying to plot this, but this is somehow not happening. So here it is 23.9. Here it is somewhere around 27.6. So I will plot this. You will get a clear understand. I will plot x test, y test, and this x test and y predicted, so that you can get a clear picture of it. Okay. Okay. So that's how is about linear regression, univariate linear regression. Okay. So now if you check the statistics of it, so that's how you check it. So from scikit-learn, you need to import the metrics package, and in the metrics we will have mean absolute error, mean squared error, and so these things we will have. So first one, see here the mean squared error that we have, root mean squared error, it is too large, right? So this is a good fit for our model. So okay, so this is a good fit for our model. So that's how these things are. calculated. Okay, so that's how these things are calculated. Okay, next
No,
is linear regression.
one question. Like, see, we are plotting with between the two, like LSTAT and MEDV, right? LSTAT is our X.
MEDV, right?
LSTAT is our X,
Yeah, yes,
independent
right,
variable, and MED is a dependent
right,
variable.
correct, right,
So based on that value, we are trying to figure out what is the corresponding value for MEDV, whether it is going up or down.
right,
Okay.
right. So here is the equation will be. Yeah, for multiple linear regression, again, we will have the same thing into picture. Okay, here instead of taking one, we will take all, and we will see how the things differ. Okay, how the things differ. We will see that now. So let me run it once more. So we are reading the data here. Okay, next step, we are dumping the last last column, right? In the first one, we are dumping the last column. Why we are dumping the last column? Because that is going to be our target variable. So we won't be having it in the trend set. So we have dumped it over there. Okay, we have taken out the y variable, that is the last column, in a separate list of y, and in the x we have all the features. So x is becomes our feature vector, y is our target vector. In the next step, again 80-20 split. Okay, again we have 80-20 split. Okay, then we have we are printing the values. 80-20 split we have. Now the difference is here we have all the variables in x train and y train. Okay, we don't, I mean, in x train we have all the features. In the earlier example we had only one feature, but here we have all the features. Yeah, so in x train now we have all the features into, we have all the features. Now we will pass the x train and y train values, and we will run these things. Okay, we will run these things. So see here we have created a regression line. Again, as a similar way, we have taken the regression coefficients, and we have taken the regression coefficients. Here we have multiple columns, so multiple regression coefficient will be there, and we have the column names also. So that's what we have taken. So 12 columns, 12 multiple regression coefficients will be there. So these are the theta vectors. Okay, these are the theta 0, theta 1, theta 2, theta 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, these are the theta vectors here. So if you see, there are some negative weights also, so that means these are insignificant. So they are I mean, for those the values got I mean, what, for larger value of those, the value got decreased. So that's why we have a huge negative parameter for those. Like let's say for NOx, for this NOx, what is NOx? If you see here, nitric oxides concentration parts per 10 million, so that is toxic, right? So if the value is more, the housing price will go down. So that's why it has a huge negative parameter. Okay, so that's how in the real world machine learning models work. I will start with regression, logistic regression session. Okay, so one thing to understand, first thing is regarding machine learning, right? So broadly there are two types, like supervised learning and unsupervised learning, right? So for supervised learning, we will always have a definite objective. It can be something, a continuous set of variables, or can be categorical variables. Okay, and for like unsupervised learning algorithms, we will always be having indefinite output, let's say cluster of points kind of things. Okay, that will be I mean, for supervised algorithm, whatever data we use, it will consist of a level. It can be a continuous set of variables, or it can be categorical, that doesn't matter. Okay, so it will always be, the data will be definitive. It will give you some kind of a output. Now if so why do we need this kind of a different set of algorithms, right? When we are dealing with linear regression, why don't we have, or why do we have this logistic regression, which is a classification algorithm? So the thing that you need to understand, for linear regression, if the data is continuous and spread across a good amount of range, then only the line can help you in predicting the values, right? But instead, if it's a categorical problem, like where the data is skewed in two ends, or two three ends, like let's say values of 0 and 1 are the best scenarios that we have. So typical examples of logistic regression would include, typical examples would include, like uh, tumor prediction, is it a malignant or benign one? Okay, it would be spam classifier, it will be fraudulent transaction detection. All those kind of things will come under logistic regression. So as you can understand from the name itself, here the data will be too skewed, right? It will either have a yes or no value, or you can say it like 0 and 1. So if you have, let's say, 10,000 data points skewed between 0 and 1, there cannot be anything which sits in mid of it, right? It cannot sit between 0 and 1, right? So it should be at the two fag ends. So if you draw a line from two ends, what would do that would be horrendous for a linear regression model to fit in, right? So why so? Unweighted decision tree is something else and the logistic regression is something else. So it's those two are the different things. So don't just confuse the algorithms. Okay, so when I am going with one algorithm, stick to that. If there are any relations between them, I will also cover that, which is sadly there are nothing. Anyways, so to continue with it, for this kind of logistic regression problems, the data will be skewed between 2 points, right? So if we draw a line between point 1 to point 2, if it's a straight line, then also it won't fit the data. When I am telling this, what do I mean? I will shortly show you that. Okay, so what do I mean with that? The data will be skewed and the line can't fit it, right? So let me open this. Okay, when I say that it cannot fit the data, right? We saw for linear regression how the models worked, right, and how the data points look like. But let's say what we are talking about today is it will be some kind of a graph like this. If you plot the observations, right, then I mean when you plot the outputs in a graph, in yesterday also we did the same thing and we saw there was a continuous set of variables, but here what it will do, yeah, so it will be, let's say these are some data points which will be near 0, right? These will be some data points. So the output of this will always stack to 0 and output of all this will be stacked to ones. Like that, this kind of a set will be there. So if you draw a straight line, it would only fit 1. It can fit max of 2 values. It can fit max of 3 values, like that, right? So in that case, what would happen? The model will fail radically because the error percentage will be huge, right? And it won't be fitting a good model. So that's why we won't be able to use linear set of regression, linear set of models to fit in this kind of a requirement. Instead, we would need this kind of a curve, right? See, now this fits in perfectly, right? This fits in perfectly in the under training example. So this curve is again called, sigmoid function, right? This x-shaped curve, S-shaped curve. So what is the features of it? It is an asymptotic curve, right? When do we say asymptotic? That means it will never reach 1, it will never reach 0. Okay, so what it will do at positive infinity, at positive infinity, it will asymptote to 1. At negative infinity, it will asymptote to 0. Okay, so it will never match the lines, but it will be asymptotic. So in this kind of shapes, we can have some kind of a good fit for this kind of classification problem. Yesterday's thing was based on a straight line equation, right? It was a y equals mx plus c. This kind of a straight line equation was yesterday's topic of discussion. But today's topic of discussion will be this kind of a asymptotic curve. Okay. So before going to this, I will be covering one more. Okay, I will come to that later. So this curve equation is this 1 by 1 plus e to the power minus x. So this curve, as you see, it will asymptote at the positive and negative infinities, right? So if you see e to the power minus x, then if you set the value of x as minus infinity, what would happen? A very large number will come at the denominator part, which will force this value to go to 0, but it won't be 0. But as you know, infinity is a big number, so infinity plus everything will be infinity itself, right? So it will be very near equals 0. But if it is positive infinity, then e to the power minus negative infinity will be too small to be considered as 0, right? So this value will asymptote to 1. So that's how the sigmoid function works. And we will establish our logistic regression functions and everything based on this function itself. Okay, this function itself. So now what I will do, I will go to the PPT and will cover the things that are there. Okay, then I will again come back to the curves and all. So this is how the basic concepts of logistic regression stands. So this is how this sigmoid function comes into picture instead of a linear regression line. Okay, so I explained the basics of it. Now let's see with an example. Okay, so someone is asking you to, hey, see, I want to buy a property which will have a bigger garden area for some amount of money. Okay, so what we will do, we will do a simple linear regression, right? So what we will do, we will have the dependent variable as property size. So we will have an independent variable of money. So it's obvious, right? If you want bigger garden area, that means your property size has to be bigger, right? So you need to spend more money than before, right? So again, it has many other many other criteria, but let's have this fixed. Okay, let's say the locality is fixed, the area is fixed, that the village or the town or the city is fixed where they're trying to find the house. So if you consider there are only two external variables, that is money and dependent property size and money, then in that case what we will have is we will have a linear equation between these two, right? So their linear regression will perfectly fit in. Yes, Giri, so that's what I told. So property size, so that's how it is. So next point will be, so bigger garden area means there will be smaller house area. So we are I mean, what we are doing here, we could have taken a multivariate solution here, but we are going for a small part. So we are breaking it into chunks. Okay, so when we are searching for bigger garden area, what does that mean? That means the house area will be smaller, right? So in a property, if a house is there, let's say we want to buy 1,000 square feet of 2,000 square feet of property. In that garden area we want of 900 square feet, so the house area will be shrunk to 1,100, right? So that's how. So here also a linear equation exists between them. Why? Because if you make the garden area large, the house area will come down, right? So house area and garden area size will also have a linear kind of equation. This can be solved using linear regression. So this kind of problems can be solved using linear regression, because this is not categorical. The data will be continuous. So the value, the size values or the price values, when you plot it, it will be, so it will be uh, linearly dependent between them, and as it is a continuous value, so linear line will fit it. There might be errors, there might be estimation errors and all, that's fine, but it will fit a linear model, so we can predict those kind of things using linear regression. So what we can say from this, like, if the guy who is asking you for buying a house, if he spends X amount of a money, he can buy Y area of a house. Okay, Y property area he can buy. So this one you can comment from linear regression. But let's say the guy wants to ask you, so the property will have a good neighborhood, will the location be noiseless suburb or a busy bustling city? So how the properties, what is the location of the property, that kind of preferences someone wants to ask you, then you will be in a soup. So see this problem statement, will the property have a good neighborhood or not? What the values it will have, it will have a categorical value 0 1, right? So again, if you plot here, if you plot those 0 1 things here, like I saw, like I described in the plot before, it will be skewed in 2 points. So if I draw a linear line, it will feel radically, right? You can't predict it. So if I go back to my plot, let's say we are trying to deal categorical problems using a linear regression model. So I will draw it again. Okay, so let's say these are a few values. Okay, these are zeros, these are one. So I have a data set where this neighborhood is also given, and neighborhood is given as like good neighborhood or bad neighborhood. So this is good, this is bad, this is bad. Now let's say I draw this line. Okay, so now let's say some property is bad. So but what it will do, let's say we want to know if the property has this kind of a value, then what is it? So it will predict the values in here, the y value will predict in here. So will be this one will be your value. So what can you comment on this? So the value coming will be around 0.3 or something. So there will be a lot of error, but it should have been coming as 0. It will get worse till you once you move to the top of the line. So it depends on the line that you draw actually. So Come on, why it is not going? Yeah. So let's say some point here for x here, the value will be coming up here, right? So this will again go to a good property, but there it should have been a bad property. So this kind of problems won't be, you won't be able to solve using linear regression models. Okay, this kind of problems you won't be able to solve using linear regression models. So in this case, you need that funky S-shaped curve, the sigmoid function curve that we shown here. Okay, so that's the whole idea. So now we will see how we can have it. Okay, so this kind of a classification problem, linear regression won't be able to answer. So you would need to apply logistic regression models to this, and this will help you in answering classification problems. So this is the never-ending loop that it will go on. Okay. So will the property have a good neighborhood? Will it rain tomorrow or not? Is the mail spam or not? This kind of small questions, this kind of small classification questions, it can answer. Okay. So let's go ahead with this PPT. Okay. So see, machine learning, supervised, unsupervised. Supervised is again divided into two broader categories: regression, classification. Regression we already covered, linear regression. Today we are going to cover logistic regression. That's another classification problem. There are many others. We will come to those one by one, but these are some major chunks. Okay, so a statistical classification model, as you already know, this machine learning, heart of machine learning is stats. Next is deal with categorical dependent variables. Explain this. Could be binary or dichotomous. So that means it should be having two values, not more than two. It could be multinomial. Yes, obviously it can have only one feature of x. It can have multiple features x, right? So yesterday we saw how it does for univariate and multivariate machine learning linear regression models, right? Same thing applies for logistic regression models also. So x can be only one feature or x can be a set of features. So that's where that way it can be either multinomial or it can be univariate. Okay, it can take both continuous and discrete input data. Yes, because this kind of a S-shaped curve can also fit continuous data also, but again in that case it will have a lot of errors, right? So continuous variable, if you plot using a S-shaped curve, it will be giving you some model, but the error will too high to explain. Okay, so that's why we don't really specify it. So we only consider of this categorical data. Okay, for continuous variable also you can plot this, but it won't be helpful because it will be having some problems, right? Because it won't be able to take care of continuous variables. Okay, so that's why we have linear regression models. Yes, sure. So for multinomial, it is like, let's say we are trying to find what should we find? Spam classifier. Let's go ahead with the example that we have. Okay, so for spam classifier, if we think there is only one feature to be, that is count of spam words, right? If we think this is our only feature, so what do we mean by spam words? It will be misspelled words, right? It should have walk like this. It should have sell, buy, money, transfer, bank details. This kind of words are very commonly noticed in spam classifier, right? So if we want to build a spam classifier using only count of spam words thing, right? Only count of spam words thing, then it will be univariate. Now, if you have noticed spam emails, it has one more feature also. Like for spam emails, the sender address will be fishy. The sender address will be fishy. What do we mean by fishy? The domain name will have some absurd kind of a values. It might not be a permanent domain, right? So if we take that also in account for building a spam classifier, it becomes multinomial. Why multinomial? Because okay, let's so why multinomial? Because we know we denote feature vector by x, right? So if x contains only one value of x1, then this is univariate. Okay, because the number of independent variables in here is only one independent, right? So whatever has to change will change with the value of x1 only. But if x contains more than one, that is x1, x2, xn, so it might happen that among these n features, all n features are useful. It can happen, or it can happen some, let's say 10 features are useful. Okay, others might be junks, but it has 10 features, so 10 independent variables, right? So as we have 10 independent variables, what it does, it will have like 10 layers of x versus, so it will have a 10 independent variables, so the y value that we are going to predict will have multiple features in it, right? Will have multiple features in it, so we need to fit in more than one feature vector in our machine learning equation. So if I go back to this equation, like we see here, this is the equation for linear regression, right? So if we have something like this, 1 plus e to the power minus, I will come to the derivative, I mean machine learning form later. Like this, if we have, then it becomes a multivariate problem. This is a univariate problem. Okay, so that is how it depends, because here it output of the model will depend on more than one independent variables. So that's why this is called multinomial. Okay, so that's what the idea is. That's what is about multinomial and univariate things. So here also we can predict, here also we can have this kind of we can use clustering algorithm to predict the data. Okay, we can use this kind of algorithm to predict the data. Okay, so for clustering, what happens, as a point came in, I will show you. For clustering, divide data in unique sets, right? So that is what is called clustering. So the sets can be 0 1 also, the set can be cat, dog, fish also, right? So the both type of problems can be solved using clustering, but for classification it won't fit this purpose, right? That is the whole base of our statistics. So for clustering we will have a different set of algorithms. There if you see, there no kind of a machine learning model will be there. There will be a generic set of steps that we need to follow. Stats will be there, but it will be in the minimalistic part. Okay, so that's how it works. Okay, let's go ahead. So this is a tool for applied statistics for discrete data analysis. You already discussed. Gives outcome in terms of probability, right? That's what it does, right? So what the model will do, the model will give you a probabilistic output. Like let's say for this email to be spam, the chances are 70%. We will convert that to 1. We will see this. Okay, so this is again based on probabilistic models only. Okay, so this logistic regression will be, the probability will play a big role here, because see, one thing you need to understand, when we are going for logistic regression problems, yes, this the equation that I have shown, this will be the curve equation that we have. That's true, that's not a problem. But the thing is, when you are predicting the output, so what this value will predict, this 1 by 1 plus e to the power minus x, it will never predict 0 or 1. Perfect 0 1 1 it would never predict, right? Because it is an asymptotic function. So at and infinite values you won't be giving to the function, then the function will stack, the function will be looped in for forever, right? So it will output some values from 0 to 1. So that will be the probability of that problem. Let's say the email probability of probability of email being spam, right? So this kind of outputs it will give. So when it gives greater than equals 0.5, we can consider this to be 1. Less than 0.5, we can consider it to be 0. That's how the math tells us. So this is again, this kind of things will predict the probability of the event being happening. So probability theory also will play a big role here. Okay, so that's how this works. Okay, now let's go ahead and take an example of it. So see, spam email classifier example we have. After this example is done, we will go to the maths of it, right? So this is how it is. So this is how the spam classifier we will build. Okay, so there are a series of steps for every machine learning problem. Okay, so understanding the variable, this is always needed. This is always needed, right? Analyzing the variable that I am telling from the first class. To be a good machine learning engineer, you have to do this. Then the stats knowledge will come handy as hell. Okay, so for basic simple problems, you won't be building complex models. The simple linear model will fit in. But when you go for a few advanced field, like researching on this kind of things and all, for building face recognition and all, you will see how complex the stats can get there. Okay, draw regression curve. So if you, whatever model you are doing, if it has a definitive curve, so just draw it. Okay, just draw the data points in it and just try to fit in a line. Let's see how the data looks like. how the model looks like. Does a linear model fits it? Does a logistic model fits it? Or it's nothing? There is no relation. It is a clustering problem. So then this case we need to check always for all machine learning problems. Next is find out best fitted curve using maximum likelihood estimator. So this is basically log estimator. Okay, so this is we find out log of odds to predict the value. That is what is maximum likelihood estimator. So maths behind it is a bit complex, so I won't go to that. So just take my words for it. If you want to go through it, you can check it. So maximum likelihood estimator, as the name suggests, it has likelihood, this name, right? So what is a likelihood of an event? I will tell you just a short story. So we all know, right? There are two terms with probability theories, odds and events, right? What are odds? Odds is the chance of event happening, right? That is what we call as odds, right? So when do we say that? That means what is the chance of the event being happening divided by chance of event not happening, right? That is what is probability theory. That is what is maximum likelihood, or that is what is odds is called. Okay, that is what odds is called. So this thing, this maximum likelihood estimator is entirely based on that. Okay, so we take log of it to uh, to minimize the impact. So we will see why we take log, we will see later. Okay, for logistic regression, why we take log, we will see that. Okay, for now just think that it is log of this kind of an equation, log of probability of odds. Okay, that's what we take. So that's how maximum likelihood estimator itself uses the log because of that reason only, and that's why we use it. Okay, we will see. Okay, so I will go ahead with the example step by step. So if we see, we have independent variable, we are taking univariate one because solving it manually will be a hectic part. So we will take univariate logistic regression here. So we have count of spam words. Okay, that's what is our independent variable, as I told. So most common spam words will be buy, get paid, guarantee, winner, unlimited, those kind of things, right? If you see, buy this watch for rupees 1, buy this thing for rupees 2, get this thing free, give me your shipping address, like this kind of mails are always spams, right? So that's why we have defined this kind of a most common spam words. So we will restrict our search to this kind of words. Okay, this kind of spam words, we will take some arbitrary counts and let's see how it works. Okay, so now we will have dependent variable, that is probability of mail being spam. That will be binary or dichotomous, right? So that means it will have either 1 or 0 value, right? It will either be a not spam or it will be a spam. So we are taking some estimates. Okay, we are taking some estimates. Our estimate is if the value is greater than 4, then it will be a spam. If it's not greater than less than, if it's greater than or equals 5, it will be a spam. Otherwise it will be a not spam, right? So this zone is safe, this zone is red. Okay, now what we will do, we will take 10, 13, 8, 9 mails where, so for the first one we have 2 spam words, so the probability will be 0. This is our label data that we are preparing. This is the label data that we are preparing. So in the real world you will get this data. So you no need to prepare this, but here as we are doing manually, we are preparing this, that I will show you also. That kind of data we have it. Okay, so we have 6 words and thus mail is spam. We have 8 words and thus mail is spam. 1 word, it's not a spam. 7 words, it is a spam. 3 words is not a spam. 9 words is a spam. 8 words, still it is not a spam. It can be some definitive mails, right? Let's say we are trying to buy a laptop or something. It will be having all those kind of set of words. Buy, it can have in 8 places. So it is not a spam. We can have it, right? We can have it. So that's how our label data looks like. Okay, now we will plot this. So how we will plot? We will plot this probability of the mail being spam in the y-axis and count of words in the x-axis. Okay, count of y will be in the x-axis, right? So how the graph will look like? The graph will look like something like this. Okay, so let's say for 1 word the mail is not a spam. Okay, say 2 words, mail is not a spam. 3 words, mail is not a spam. So we all have y values to be fixed at 0, right? Based on output 0 and 1 and based on the count. So that's why we have this kind of a graph. Okay, we have 8 words but the mail is still not a spam, right? So we have here. Okay, but here if you see, for value for 3 words we have a spam, so it is here. For 5 we have a spam, 7 we have a spam, 8 and 9 we have a spam, and 9 we have a spam, right? So we have plotted this line. Now we will draw the regression line. So as you know, this will be, so we will plot this line, right? So why is it blue there? Anyways, leave it. So we will draw this regression curve to see. Okay, so these are kind of outliers to your data. So this has 8 words, but still, yeah, correct, it is outliers, Ravi. So it has 8 words, but still it is not a spam. Okay, so we have fitted this curve in here. Okay, now next thing is we will draw this log of odds. Okay, log of the line being spam or not. So we will get this line. Okay, if we plot this line log of odds, we will get this line. How do we get this line? We calculate log of odds of this mail being spam, this mail being spam, like that, and we come up with this line. So this is the, then this is the line for log of odds. Okay, that is how we draw this line. Now next will be, we have this sigmoid function, we have this log of odds. Okay, so now the next thing that we are going to do, so that's what we have. We have this log of odds. Now we will have a spam classifier. We will have some kind of a sigmoid function here, right? We will draw some kind of a sigmoid function here, right? So next thing is we will find out individual likelihood of everyone. Okay, which will be log of likelihood, right? So we will figure out individual males probability of being a spam or not. We will figure out that log likelihood. Then we will draw the line in the curve. In the next section, if you see, we will draw the, come on, where it went. Okay, we will draw the log of odds line. Okay, so this is the regression line that we have, logistic regression line that we have, and then we will draw the log of odds line in this case when we are going for maximum likelihood. Okay, so what does log of odd means? I already explained. Still, let's see some examples. Okay, so here, let's say this guy fishing 5 times a week, caught a fish 2 times, failed to catch 3 times. What is the probability and odds of getting a fish for dinner? So probability of getting a fish is 2 by 5, right? The probability of getting a fish is 2 by 5, right? Probability of not getting a fish is uh, like 3 by 5, right? For not getting a fish. So probability, so odds is chances for it. So chances that the guy will catch a fish is 2, and the chances that the guy doesn't catch a fish is 3. So odd for that event being happening is 2 by 3, right? Odd for the event that will happen is 2 by 3. So that's how we have for bettings, right? That's a good example. Betting is a good example of the logistic regression, but I am not encouraging to bet, as this is illegal. Okay, so here it is just for an example. So we have odds for every team winning and not, right? So how they do it? We do it using the team chances for being for winning, and the team chances for not winning. Okay, so that's how. Yeah, so log of odds is will be called the logit function. Okay, so odds and odds ratio we will have. Okay, so probable odds of catching a fish on sunny day is 2 by 3, and odds of catching on a rainy day is 3 by 2. That's what is some arbitrary numbers. So log of odds will be log of 2 by 3, and log of odds of catching a fish on rainy day will be 3 by 2, because you can really understand, right? So if the day is rainy, then it is a higher chance that we will get the fish. Why? The number of fishermen will be lesser there, right? So now odds ratio will be odds of getting a fish in a rainy day divided by odds of getting a fish on the sunny day. So which will come as log of 0.44, which will yield you some kind of a value. So that's what is about log of odds and log of odds ratio. Okay, so odd means chances for divided by chances against. So what is the chance of some team winning the match divided by what is the chances for that team not winning the match. So when a black horse wins the match, the guys who are doing a betting will be like showering in the money. But when it happens the reverse, the guys will lose all their money, right? That's what happens. So that's how this thing stands for. Okay, that's how this odds thing stands for. So that's how it works. So the higher the odd is, the higher the chances for winning or losing is, right? So that's what it is based on. Okay, that's what it is based on. So now we will see how can we use that in here. Okay, so see the logs or log of odds line we have drawn. Okay, it will be this represents log of odds for every mail being spam divided by chances for the mail not to be spam. Okay, So this measure will be arbitrary. We will for this curve, this is arbitrary, but this can be equally predicted, right? You can easily understand that. So that's how we plotted this log of odds line. When we go to the maths part, you will understand this better. Now let's say log of odds or log of odds will be what? Log of a mail being probability of mail being spam divided by probability of mail not being spam, right? So let's say if a mail is spam, so p of spam will come to 0 and 1 minus p of spam will be 0. So 0 by 0, what it would be? Log of 0 will be, okay, yeah, log of 0 by 0, right? This kind of things will be there, and it will asymptote at negative infinity. The log of adds value or odds value will asymptote at negative infinity, so it will be negative value. So we will consider negative values as 0 only, so we will take it as 0. So that mail is not a spam, because log of 0 by 1 will be log 0 minus log 1, right? From the logs equation we have, and that will be negative infinity, because log 1 is negative infinity, right? That's how, I mean, log 1 is infinity, right? But log 0 is 1, right? So here if you see log of 1 by 0, then it will be a positive infinity. So if the value is positive, then it will be trending to positive infinity, right? So if some mail is a spam mail, for this mail the value will be nearing to positive infinity. That's how this log will work, right? So that's how this log likelihood comes into picture. Now you need to understand one more thing. Let's say our model is predicting this value to be false, okay? So but the value is true, right? So the value is true, but our model is predicting it to be wrong. So we will use later on, we will use this concept of log of odds to build our cost function. How we will tweak it? We will tweak it like, if our value that it is the model is predicting is correct, that is if the value is 0 and our model is predicting 0, then we will give it a no penalty. It will be a 0 penalty, okay? But if it is otherwise, then we will give it a high penalty. We will use this concept to build on that, okay? So that's what will be the function of concept of cost function. Let me show you. This equation is a bit hard to write, so that's why I have it in my PPT. So this one, right? This one will be the cost function for logistic regression, okay? So this is how this will be. Let me write it also, no issues. So we have j of theta will be 1 by m, okay, summation over I equals 1 to m yi into log of h theta x, right? Log of h theta x, okay? So why so? I will explain. H theta xi actually, plus or minus, what we have, plus, in plus only we will be having, yeah, right? So we will have 1 minus yi into log of 1 minus h theta x, okay? So this h theta x is our, what is this called? This is our hypothesis, right? So h theta x our hypothesis, right? So what hypothesis will return? It will return the prediction. So now just pause for a moment and check if this equation makes you sense or not, okay? So what we have, just try and see. We have 1 by m summation I equals 1 to m. I will break down into parts, okay? I will break down into two parts, minus 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 minus, okay? Okay, sorry, I wrote it a bit wrong. It will be a minus up here, okay? It will be minus 1 by m. Why I am coming to it? Why do we use this cost function for logistic regression? Come into it. So the first part of the value is yi into log of h theta xi. So what is this? This is our prediction, right? So log of our prediction, it can be either 0 or 1, right? Let's say we are taking for 0, okay? And let's say yi value is also 0, okay? So this first term will vanish, right? If yi is 0, h theta xi is also 0, the first term will vanish to 0. For the second term, if you go, yi is 0, so 1 minus 0 into log of 1. What is this log 1? Log 1 is 0, right? So we will have 0. So if the prediction is correct, okay, if the prediction is correct, that is yi is 0, h theta x is also 0, that is a true prediction, cost function becomes what? 0. So no penalties. We are encouraging our model to use that because it has done the same prediction. If you substitute the values for 1 also, if it is for 1, then also it will be turned to 0. Okay, why it will turn to 0? For yi equals 1, the second part of the function will be removed. Okay, the second part of the function, that is this part, will be vanished because this is 1 minus yi, and if the yi value is already 1, this function will vanish, and this will yield you the result of, and our model has predicted it correctly, so it will yield you the result of log of h theta xi, that is log of 1, that will go to 0. So we are encouraging our function to use this because if it is a true prediction, okay, if it is a true prediction, the cost function becomes 0, no costs are implied on the function, no costs are implied on the model, so we are encouraging our machine, go ahead, use that model. Okay, but let's say we have a reverse case of scenario, we have yi to be 1 but 0, but our h theta x we have predicted to be 1. So for 0, first term will vanish, it will be 0, plus for the second term what we will have, we have 1 minus yi, so 1 minus 0 into log of what we have 1 minus log, what was that, log of 1 minus, sorry, I just reverse it. Yeah, so what we have log of 1 minus h theta xi, so this is now 1, but this was supposed to be 0, so 1 into log of 1 minus 1 becomes 0. What is it? Positive infinity, right? We are and as we have minus 1 by m at the front, this will become negative infinity. So we are discouraging our model with this kind of a cost. We are telling, see dear, don't use it because it will yield you a high cost, that is of minus infinity. Okay, similarly, if yi is 1 and our model has predicted 0, then also if you put in the equation, you will see there is a huge cost of negative infinity to the model. Okay, so that's why we use this log of odds concept to use it here. Okay, to use it here. Okay, to build the cost function for logistic regression, and this whole concept that I explained is the cost function of logistic regression. So if our model is correct and makes a prediction to be prediction is correct, the the cost function will be 0. If it is wrong, then it will become negative infinity, which will yield you a very high cost value to the function, and that will be dangerous for the model. So the model will try to readjust its theta parameters to find out a nice and healthy equation to fit the curve. Okay, so that's how cost function works. So as we're going through this log of odds thing, just explain this. Later on we will see the equation for logistic regression also. Okay, so that's why this negative infinity concept comes into picture. Okay, yeah, so that's how we have for cost function. Let's go ahead with this log of odd thing. Now see, we have plotted this log of odds line, which will be negative infinity to positive infinity. It will stretch out, then we will calculate the distance from the log line and this male classifier points. Okay, we will calculate this error points, right? The distance of errors from each and every point to the log of odds line. Okay, so we will have a sigmoid function now here. So here what we will do is we will see what is this sigmoid function and how do we use it here. Okay, so if you see the upper hand of it, L of e to the power k x minus xo by 1 plus e to the power k x minus xo, this is the logistic function in stats. Okay, so this is the logistic regression function that we have in stat. Now L will be curve's maximum value, k will be steepness, and x0 will be x value at sigmoid point. So x value at sigmoid point will be 0, right? Will be 0. So sigmoid point for a function will be 0.5, right, which will be a 0 value for the sigmoid function, not the predictions. Okay, not the predictions, like that. So we will replace these values. For us, the maximum value that we are going to use is 1, right? We are going to use is 1 for the ideal scenario, and stiffness will also be 1. So we will replace the values in that earlier equation, 1 e to the power k x minus xo by 1 plus e to the power k x minus xo. What it would become, L will be 1, xo will be 0, and so we will have L e to the power x divided by 1 plus e to the power x, which is same as this equation, right? Which is same as this equation that I wrote earlier, this equation, right? So it will translate to e to the power x by 1 plus e to the power x. So this is the equation that we are going to use for now. Okay, it has two forms. I will use the first form for ease of use. Okay, I will use the first form for ease of use. So anyways, you can write it, that's not a problem. So that's how we will have this e to the power x by 1 plus e to the power x, this sigmoid function we will be working with. If we so this thing I already have discussed, right? It will be a S-shaped curve. It will have a finite limit. It will be 0 as x approaches negative infinity. It will asymptote at 1 if it approaches positive infinity, right? So that's how this thing works. That's how this thing works. So what we will do, how we will map with this number, take any real valued number and maps it to a value between 0 and 1, right? It should be x, whatever value of x you give in this value, right? So let's say to the power 8. Okay, let me show you in a calculator also. So if we use e to the power 8, it will be 2980. If we divide this with 1 plus e to the power 8, then it would be say 0.9999, which is almost equal to 1, right? So if you give any real world number to the sigmoid function, it will yield you a value between 0 and 1. Okay, so that's why we use this sigmoid function, because it will map you to some value between 0 and 1, and based on the 0 and based on the output value, we can relate that to either 0 or 1. Okay, this will be so we will get the classification thing done very easily. So that's what is the main reason for using this kind of a sigmoid function for logistic regression. So there are two things. So first, whatever values of x you give, it can be continuous or categorical, but it will give you a value of 0 and 1. Second, linear regression can't fit this kind of a curve, because it won't always predict 0 and 1, right? It will predict a continuous set of data. So that's why we use linear regression in here. It is in the other words, in the other words, this is how the sigmoid function works. That's where the power of sigmoid function comes into picture. Okay, that's why in classification problem we use sigmoid functions. Okay, so next step, we have drawn the sigmoid function here. But this is probability as we discussed. So e to the power x here will be log of odds. Because why log of odds? Because we want to see what is the error in it. So that's why for instead of x we have put in log of odds. Okay, log of odds. So as I told, it will map it to a value between 0 and 1, right? So we can say either the mail is a spam or the mail is not a spam, right? So for the first, if you say for this example, we have 3. Okay, we have 3, right? Log of odds for this example will be minus 3.2. That's an arbitrary value, don't think of it. Okay, so let's say for this mail to be spam, we have a log of odds value to be 3.2. This mail being spam, log of odds is 3.2. If we substitute, this will be 0.03, right? So what will happen for this 0.03? This model will fail, right? Because 0.03 equals to 0. So some spam mails, we are calculating it as a non-spam, right? So our model will fail. So see here, we have a wrong prediction. So this log of odds line that we have drawn is not correct, right? So the theta parameters need to be adjusted now. Okay, so we need to rotate the log of odds line now. Okay, see, for this one, for this mail to be spam or not, it still predicts this mail. Actually, it still predicts correctly. So it is correct, but this one is a wrong prediction. So we would need to give it a shot, and we would need to try. And so the steps will be, first we need to calculate log of what's for each and individual values. Okay, each individual male values. So whatever values we get, and we can really easily understand that this value is not going somewhere, this value is getting reversed. So we are having too many bad predictions. So first we will calculate log of likelihood for each of the male being spam. So as I explained in the example, it is failing radically, right? It is failing radically, and the spam mails are translated to being not a spam, right? So next will be, we will calculate this kind of a likelihood function. Okay, so why this kind of a likelihood function? Because for the first mail, when we have the 0.01, that is the probability of the mail not being spam, right? That's what we have calculated for the first email, because it predicted wrongly, right? So we will subtract this from 1, and rest we will multiply. So that's how we get total value, and then we put a log on it. Okay, we put a log on it to find out log of likelihood of the entire data set. Okay, of the entire data set that we are working on. So we will calculate all these log values, we will sum it up, and we will see the log of odds value is 0. minus 0.084. So that means this is not a good fit, because we have a really small value that is coming into picture. So this is not a good fit of the model. Okay, next we will rotate the line to find the best fit. So when we rotate the line, we will take each individual examples in there, we will calculate their individual likelihood for each email being spam or not spam. We will keep on rotating the line till we find the best fit. Okay, that's how the algorithm will work. We will keep on rotating the line till we get the maximum log of log of maximum likelihood. Okay, so that's how we will do. So that's why we will do, that's how we will do this. That's how we will find out the logistic regression outputs. That's how we will find out the best fit line. Okay, so that's how this thing will work. Okay, so that's what is sums up this example. Now let's see how the cost function, I mean how the logistic regression function looks like. So as you have already seen, right? Yeah, so logistic function, right? What do we have? We have a to the power x 1 plus a to the power x, which again translates to 1 by 1 plus a to the power minus x. Now guys, now my question to you would be, how do we apply the theta parameters, like the weighted average to it, right? So for linear regression, we have seen that we have applied some weight to the theta parameters. Here also we will have the same thing. How do we have it? This is the equation that we use for machine learning. Okay, this is the equation that we use for machine learning. So here this x is feature vector, this theta t is theta vector, let's call it. Okay, y transpose here, because theta will be a vector of theta 0, theta 1, dot dot dot, theta n, right? Theta will be the vector like this, right? And x, the feature vector, will also be like this. So x0, x1 till xn, right? So in order to apply these two together, we would transpose theta. So how the theta transpose will look like? The theta transpose will look like this, theta n, correct? So now if we calculate theta transpose x, it would become theta 0, theta 1, theta n multiplied by x0, x1, xn. What is the output guys for this? Theta 0, x0, theta 1, x1, theta 2, x2, like this, right? Till theta n, xn. Here always we have x0 to be 1, which would make this equation to be 10 xn. Okay, this will be the equation for this. Now if we substitute this equation in this equation, 1 plus e to the power minus theta o, theta 1 x1, theta 2 x2 plus dot 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 theta n xn. Okay, that's how this equation will become. Now if you go back to the cost function objective, so if we have yi to be 0, and this model has also predicted to be 0, So h theta of x will predict 0. So the cost function will be 0. So the theta parameter values that we have chosen will be correct. But let's say yi is 1, but h theta x becomes 0. So based on these theta values, right? So if I go back to the cost function, you will see when we have log of h theta x, that will be in terms of theta, right? So here how the original equation will look like, it will be yi into, again you no need to do this, okay? I am just explaining for your ease of understanding. 1 by 1 plus e to the power theta transpose x minus, right? So that's how you will put these values, right? So this equation will yield 0 for correct prediction, so this theta values can be unchanged, theta can be unchanged. But if it's negative incorrect prediction, it will be a high value, right? So negative infinity means a big penalty, right? So this will enforce the model to change theta. Yes, Rabi, this is the hypothesis is h theta x will be 1 by 1 plus a to the power theta transpose x. This is the hypothesis for logistic regression machine learning model. Okay, this will be the hypothesis. So theta transpose x calculation I have shown. How we can put this into this value I have shown. So that's what is the concept of theoretical mathematical concept of hypothesis and of logistic regression looks like. Okay, that's what is about the concept of logistic regression looks like. Okay, so the next thing that we will do is we will check the demo of logistic regression. Okay, after this I won't be showing you the entire thing, I will just show you the basics of it. Okay, so I will just touch the basics of it because you will rarely do it manually, but just for showing you how this mail classifier or some other example can work with this, I will just show you. So we have this kind of a data set foo, where are something with 1, 2, 4, 5 values. So then we will plot the lines between A and B. So why this kind of lines are given? Yeah, till here it is starting. Okay. So see what we are doing. We are creating a logistic regression function. Okay. We are taking rho, that is the feature vector, and coefficients, that is theta. Okay. So y hat we are taking as coefficients 0. Okay. Y hat means the first prediction. Okay. Now for all the features we are calculating this y hat plus equals coefficients I plus 1 star rho 1. Okay, so then we are substituting this value. Okay, because this is theta transpose x into x, right? This line we are calculating theta transpose x, right? So theta 0 plus theta 1 x1 theta 2 x2 theta 3 x3, like that we are calculating here in this line, right? This is the y hat, that is the theta 0. Okay, this is the theta 0. Now we are returning this function, right? 1 by 1 plus e to the power minus theta transpose x. So we have theta transpose x in y hat, so e to the power minus y hat. Okay, we are returning this function, so this is our predictor function. Okay, now we are, anyway, so this is our theta transpose x. Now we are creating a trained data set. See, we have some arbitrary values with label data set, right? We have two features in here. So we will estimate the coefficient using stochastic gradient descent. No need to go into details, this would be not be needed. So stochastic gradient descent, when we say, okay, let me tell you one more thing. It will be asked frequently in interviews, why can't we use maximum like mean squared error in logistic regression? Okay, good point came in. I will explain this. Yesterday I have told you a concept of gradient descent, right? So gradient descent will be when you are trying to find out the minimum value, when you are trying to minimize some value, you will use contour plots. That is the gradient descent algorithm. So you will step down the curve according to the gradient of the curve. So let's say Do I have it in my PPT? Just let me check. If I have this curve, then it will save a lot of drawing efforts. Let me see. 1 second. Huh? No, I don't have it. Okay, I will just quickly draw this. Okay, so the cost function that we have for linear regression is mean squared error, right? So for categorical data, for this kind of a data where the values are categorical, if you draw that cost function, then it will yield some kind of a curve like this. Okay, this kind of a zigzag curve you will get. Okay, for the mean squared error function, why you will get? Because our hypothesis is 1 by 1 plus e to the power theta transpose x, right? So if we try to find out mean squared error, as we don't have a continuous set of value, the mean will always be in between 0 and 1. So it will it will always be shifting in between 0 and 1. It will never yield you a positive value. That's why you will some kind of get this kind of a zigzag curve. Now let's say you want to use gradient descent in this. So you are in this point. Okay, you want to find the minimum value. We can see this is the minimum value, right? So now gradient descent, it will descend, it will change the theta value, it will come to this point, it will come to this point, then it will start descending, it will come to this point. So this point, if you see, okay, let me take from this point. 1 second, this is a very short line. Let's say you are at the starting point here. Okay, so here if you see the value, it will see the value is not minimum. Okay, so it will change the theta, it will change theta, it will come down, it will come down to this point. It will see it is observing a decrease, right? It will even slide even more down, it will come to this point. Okay, this will be coming to this, then it will change the theta, it will see it is coming to this point. This point, as you see, has a lower value. When I say lower value than this point, then it will try decreasing theta again. So this will be higher value. So the gradient descent will now be a fool. It will be fooled up. It will be stuck in this local minima, whereas this is the main local point, right? It will be the main local. It will be a local minima. So these points, this one, this one, this one, this one, and this one, these are called, these points are called local minimas. Okay, so if you use the cost function for, if you use cost function of linear regression for this logistic regression, your function will get stuck into local minimas, which will be dangerous for you. It will yield you wrong values. You will never get the values that were truly correct. Okay, that were truly correct. So you will never reach to the actual minima that the model will supposed to have. Otherwise, when you see, instead, if you draw the cost function that we have shown you, right? So don't go for the cost function basic. I have told, I have proved also, right? It will asymptote to negative infinity at 0, and it will asymptote to positive infinity when it reaches 1. So this will be something like this. So from this also you can see the same thing, right? You can see the same thing. Like this is the cost function that we use. So here we will have a good minima which we can find out using gradient descent. So it will be these 2 points. These two will be minimum. This will tend to converge to positive infinity. This will go towards negative infinity. This will never merge. Okay, and for wrong values, this upper parts, these parts will go to meet positive infinities. Okay, so that's why we use this kind of a function for this kind of a cost function for logistic regression. It is a very frequently asked questions in interview. So answer it like, for just draw this graph, they will get impressed first. Next thing will be answer them. The for logistic regression cost function can get stuck into local minimas, so that won't be yielding the right values of theta. Whereas for logistic regression, if we go ahead and do use this cost function, write down the cost function, then it won't be getting stuck in local minimas, as the lines are pretty straightforward, right? So for sigmoid function, we cannot use the like cost function of linear regression. So that's how we have here. Okay, so that's what sums up the theory part. Okay, so let's go ahead with this. So this is the gradient descent formula that we are creating, okay, because this is not we are supposed to be used, okay. So now if we run it, it will have some kind of a error value kind of thing. So I am not explaining this. Now we will apply the same thing on a data set, that is a data set that is supplied with your material. That will be some kind of a diabetes data set, I believe. Do I have the file name hard coded? Okay, now we put all this into account and see we have a 874% of a accuracy score. Okay, we have a mean accuracy of 77.124 percentage. Okay, so how do we calculate this kind of a, how we are doing this? We are doing this with confusion matrix and all. So that's what basically is with this logistic regression demo. Okay, we are using n folds, that is 5. So that means for the gradient descent we wanted to descend for 5 times. So you see we have accuracy 5 times, we have accuracy, right? 5 different accuracies. Okay, we have it from this. So the mean accuracy is 77%. So this is just we implemented, this is the basic, just to implement the basic concepts. So if you see, for predictions we have this kind of logistic regression function, the like what we had yesterday, I mean the sigmoid function. Then we have calculating coefficients also, right? Coefficients also we have. Then for prediction we have the sigmoid function again. Okay, so that's how this works. So no need to go much detail into it, because we are not going to write this algorithm on our hand. So we will basically do one thing, we will go for a demo with proper files and proper data. But the data might not be meaningful, that's fine, leave it. But it, you will see what kind of a thing it, what kind of a value it yields, and how do you use scikit machine learning, this one actually. Okay, this example. So how you can use scikit machine learning package to work with logistic regression thing. Okay, so now what we will do, we will see how you can apply logistic regression to this. You will see getting done in 1 minute, right? One line of code. So that's the main funny part of machine learning. Even if I skip it, then also you can write the code, but you won't get the basic of it. So that's right. Anyways, so let's see, we are going to do with a what heart disease data set. Okay, I will open that up for you. Where it going? Come on. Yeah, I have this, I have this. Okay, so we for this example, right, we will be using a heart disease data set which will have 303 rows and 13 attributes. When I say attributes, that means the features. Okay, in this example we are going to build a classifier, so the which can predict if the person has a heart disease or not. Okay, if some person in our data set has a heart disease or not. So when we say the target has a heart disease, the value for that would be 1. Okay, and when we say the person doesn't have a heart disease, the value for which will be stacked to 0. Okay, so that's how we are going to build the house predictor, I mean heart disease predictor classifier using logistic regression. Next, okay, next is we are loading the heart data set here. Okay, pd.read csv, we are taking a glance of it, we are printing the shape and taking a glance. Okay, we are visualizing the target variable that we have, how it looks like. Okay, then we will be creating dependent and independent variables like we did. I am going to the example shortly, so I will example line by line, not an issue. This is just to give you a brief overview. Okay, we will divide the data into independent and dependent variables. Then we will split it into train and test set of 80-20 percentage, right? We will do that. Then we will train our model using these lines. So using scikit-learn logistic regression model, we are going to train our output model. Okay, then we are going to predict our values. Okay, we are going to predict our values. So next will be calculating accuracy. We will use some precision recall and confusion matrix. I will cover that. Then I will tell you how do we calculate the accuracy. Okay, then using ROC curve, we are going to ROC means receiver operating characteristics. So this kind of graphs, electronics guys must have been pretty well known curve for them. This is some kind of a frequency thing. Okay, frequency graph. So this graph will help you to understand what percentage of the data is covered under the logistic regression curve. Okay, so that's what we are gonna do next. Okay, That's what we're gonna do next. So ROC car, if I tell it shortly, it plots the true positives and the against the false positives. Okay. So when I say true positive, false positive, what does that mean? I will tell you when I explain this confusion matrix. Okay, then you will have a clearer picture of it. Okay, so true positive, false positive, these are some things of like a classical confusion matrix. Okay, let me tell you first, then we'll go to the example. Okay, so last concept for the day will be confusion matrix. Okay, so confusion matrix, do I have this ready or I need to write? Let's see. Yeah, I have it. Yeah, so this is basically confusion matrix. Okay, so how does it look like? If you see, so the left hand side of it, right? So this part. Okay, so we have actual no, actual yes. That means the label data, the output of the label data that we have. So actual no's and actual yes. Then for this part, we will have predicted no and predicted yes. Okay, this is our model output. This is our prediction output. Now, if the model is, if the actual is no and the model is predicting no, then that is a true negative because the answer matches. So when the answer matches, it will be true. So true, negative, true, positive. Okay. When it doesn't match, so no and yes, so false, positive, and false, negative. Okay, right? So false positive and false negative. So these are what these are what some values are. Okay, so these are what some of the values are. Okay, so these are just random values, don't think of it. So how the namings will be done? It will be true negative, it will be false positive, it will be false negative, and it will be true positive. So how the namings are done? If the prediction matches, then it will be true, t will be at the beginning. Then what is the predicted value? Based on that we will calculate. So true negative. Okay, if it doesn't match, it will be false by default, false positive. Okay, here false negative, here it will be true positive. Okay, this will be some kind of a measures. Okay, next we have accuracy. Accuracy will be total correct predictions by the machine, that is true negative and true positive divided by total number of samples that we have, total number of data points that we have. That will be the, Ravi, we have this in the data set, right? These things we will have on the data set, correct? From Excel file we can get it, right? From Excel file we can get the count of zeros and ones, right? So that's how. So it will be divided by total number of predictions that we make, so that will yield you the accuracy. Okay, next is precision. Precision will be correctly predicted positive observation, that is true positives divided by total positives. So total positive, how much it will be? It will be false positive and true positive. So it is a measure how the machine is performing on the positive results. Okay, the next is recall. This is the sensitivity. You can this is the, I believe, no, Rohidas. So it will be, it is in the, so guys, can you confirm if you are able to see this confusion matrix in screen or not? Yeah, fine. So recall is for sensitivity. So when we say sensitivity, that will be correctly predicted positive observation divided by all actual positive. What is that? So how many correct positive prediction the machine has done, that is a TP, right? Divided by what is the actual positive, what is the actual positive outcomes that machine should have made. So those will be false negative, right? Because false negative will be those cases where the machine predicted it to be negative but it was positive, right? So false negative plus true positive, here the machine predicted correctly. So we are getting a measure of correctly predicted value in precision and recall. Then F1 score will be average of these two. Okay, weighted average of these two. When we write F1 score, it will be 2 into recall into precision divided by recall plus precision. Why? Because in this we will take into account the true positive predictions of the machine. Okay, and we will find out a ratio of it. So for accuracy, calculating accuracy of the machine, we use this formula, and for calculating F1 score we use this formula. So F1 score indicates how good the machine is at predicting true positives, right? Why this F1 score is needed? Because sometimes it might happen the accuracy is too high because it has predicted all the negatives correctly but some positives got left out. But F1 score will point you out that error, like, okay, I see your accuracy is fine but your F1 score is not good, so you are not doing correct positive predictions, which will be a problem. So let's say when you are predicting some heart disease, okay, and you are telling, hey guy, you hey see here, you don't have a heart disease, right? But think of a situation when the guys, when that patient originally has a heart disease, but you fail to recognize that. That will be a huge penalty kind of thing, right? That will be a huge loss for the for the patient's family. So that's why this F1 score is into picture, which will yield you the weighted average of precision and recall, so that you can understand how the model performs overall for positive and negative production predictions, and how the model works for positive predictions alone. So that's how F1 score will be there. So we will use both this for calculating accuracy of the graphs. So when we go through the example, we will see how it does. Okay, how we do. Okay, so moving ahead, we'll go ahead with the example now. Okay, the hands-on example that we have. So this is the data set that we are going to look at. Let me show you once. Okay, so this is the hard data set that we have. So we have a few columns: age, sex, CP, TREST, BPS, cholesterol, FBS, REST, ECG, and all those kind of XYZ kind of things. Okay, how many peaks are there, slopes, and all those kind of medicinal terms. So for now, no need to understand, go into detail of these terms, but when you build a real model, you need to understand each one of this. Okay, we will just, this is a very old and very cleaned up data set, so we won't need data cleaning also. So I won't be showing you the data cleaning part, because there are no, actually there are no errors for this, because this is a very finely cleaned data set. But when you go for real world, when you work with real data, always go for data cleaning. That's the first part of it. That's the first part of machine learning. In the example, I won't be having a dirty data, so I won't be able to show you, but always remember that. Never take it as granted that the data will be fine. You need to observe the data. Okay, so always remember this part, because in net, whatever data set you get, it will almost be clean. Okay, only small things will be there, but that also won't be having much of here and there values. Okay, so let's go ahead with this. So pd.read CSV, we are reading the CSV file in it, right? We are checking the value. Then next, what we are doing, we are printing the shape. See here, 303 by 13. Okay, next what we are doing, we are checking a value count. So see, the target value has 165 ones and 138 zeros. Okay, 165 ones and 138 zeros. Okay, next what we are doing, we are plotting the values in a bar plot. So see, this has a value of 138, this has a value of 165. So just to visualize the data, okay, just to visualize the data, how the data looks like. Okay, how the data looks like, we will do that. Okay, next we will split the data into features X and target Y level sets, right? So we are creating a feature vector here. Yes, Veena, Seaborn is also a type of a plot. Okay, you can use matplotlib or Seaborn plot, but Seaborn is not much used. So Seaborn is a plotting library which was built on top of matplotlib to give you a for these graphs. Okay, so that is not much of a used. So for nowadays, okay, matplotlib is the most used plot that we have. Okay, that's how. Okay, so Seaborn was developed based on matplotlib only. It is not higher or lower kind of thing, Ravi. It is just a separate mapping. Sorry, what is this? Plotting library, separate graphing library. It also has the same kind of features as of matplotlib, but it is not much used. So see, one main thing in Python is open source, right? So you also can go ahead, take the matplotlib out, and you can build your own like some kind of a library and name it Ravi library. That you can do. Okay, so that you can do. So that's why this kind of things came out. Okay, this not much has a significance for us. Okay, so it also no need to go into detail. Chittaranjan, this is not a histogram. This is a bar plot. How histogram shows is different, right? Histogram will be showing you the frequency. It won't show you the count. It will show you as a frequency basis, right? So it is not a histogram. It is a bar plot. Okay. Okay, so next part is we are splitting the values into feature vector. That is we are separating the last column. that is the target value column from the data set, and we are passing this as a feature vector. So we will have X as a feature vector, right? Y as a target vector. So if you remember the slicing concept, so in the first line, what we are doing, dataset.ilog, then within square braces, we have colon, that is all the rows, then colon -1. That means remove the last row, remove the last column, right? So we have now feature vectors in hand. So that will be removing the target vector. That is the outcome vector that we are going to predict with the model. Okay, so we are removing that. Next step, we are taking only the last row, last column, that is dataset.ilog, then with this square braces, so colon, comma, -1. So that means colon means all rows, -1 means the last column. So in Y, we will have only the last column. Yes, Rahul, X is multivariate. So this is an example of multivariate linear logistic regression that we will see. So the earlier one that I have just skipped and showed you, I will revisit that once also. Okay, let's not worry about it. I will show you this, then there I will show that one also. Okay, so we have a feature vector here. Then next we have a target vector. Okay, we have a target vector, right? We have it. Then we go into creating the model. So here is the model that we have create. Next is we will go and create. We will go ahead and create a train test split. Again 80-20 split. Again 80-20 split of the data set, right? 80-20 split of the data set. So from sklearn.model selection, import train test split, X train X test, Y train Y test, and then we are splitting the data into 80-20. Okay, we are splitting the data into 80-20. Okay, so we have now splitted the model. We will use this X train and Y train to train our model. That is to create our model. So from sklearn.linear model, we have imported logistic regression. Okay, we have named our variable log model equals logistic regression. We have created an empty logistic regression model. Then we have created log model dot fit X train and Y train. That's how we fit a model, right? So when you fit this model, it will return you all this basic all this outputs. So it is basically a model, okay, which has all the theta parameters of theta parameters absorbed and all those kind of details. It has, the model has it. Okay, so now using the model we will predict X test. Okay, we will predict X test. So Y prediction will be our X test. Okay, so for finding the accuracy, we have a function called score in the log model. So when we pass X test and Y test, it will automatically calculate the predicted values, that is Y predicted, and it will yield you the result. Okay, so what it will do, it will take the X test, that is a feature vector, into account. Okay, then it will apply the logistic regression function that you have already created or fitted. Then it will automatically calculate the Y predicted value, will compare with Y test and give you the percentage. Okay, it will give you the percentage. Ravi, the model won't work because this is a pandas data frame, right? So it won't work because if you have any data, let me show you. That's a good point you made up. So let me just quickly run it. See here, it is not able to predict it, right? Because input contains NaN infinity or a value too large for D type, right? So it has Na, so it is failing. So why it is failing while predicting? Because the Na value was in the later part, right? So it came into picture when we went ahead to predict the values, right? If we put the Na value somewhat up higher, then it would be failing while fitting the model. Okay, like that. So not showing here, showing that, I believe you must have got it, right? So that's what it will happen. So here only numerical values will work. So just to tell you one more thing which this dataset doesn't have, instead of 1 and 0 in sex, right? If you have male and female, okay, this you will also see. You will have strings. It won't work. Okay, it won't work. So what you need to do, you need to convert those string values into categorical values. That is a part of data pruning. I have shown you that also when we covered the pandas basic, right? I have shown you that also, how to create categorical values, right? Just revisit the example if you don't remember. Okay, so these things, this data pre-processing, data manipulation and wrangling, you would need to do as in each and every step of your data scientist of your journey as a data scientist. Okay, so that is pretty much needed. That is the first step. I am repeatedly I will tell this: building a fancy model won't yield you good result. It is the good data that will yield you the good result. Okay, that it will be the fresh clean data which will give you the best result. It won't be the fancy model. Okay, because here the program is data driven. Okay, so if you don't give it good data to eat, it will be it won't be able to eat the data, and it won't be able to give you the outputs, right? So that's how. So the petrol that you supply to the machine learning model has to be clean. Okay, that has to be clean. Okay, that shouldn't be having any kind of a dust. That's why we have petrol pumps for our cars, right? The think like that only. Okay, so it has to be clean thing. Okay, so that's how you need to keep your engine clean. That's it. So next thing is confusion matrix. Okay, so that is a true positive and true for true negative, false negative and false positive. This kind of values are there. So this is a confusion matrix that is being printed out. Okay, next thing is we are getting a classification report. Okay, so this is the all the values that you have seen: precision, recall, F1 score, and support. All the values that you see are printed out using this classification report function. So what you do, you just pass in the predicted value and the actual values. It will print you all these things. So these are based on those formula only. You can recheck also. Let's say let's go for precision. Okay, what was the formula for precision? It was true positive by true positive plus false positive. So 20 by true positive, 20 plus 25. So 20 by 45 was it? What is it? Sorry, I made a mistake, I believe. This will be true positive, true negative. Okay, what is the total of it? Okay, true positive, false positive. Sorry, 20 by 26. Where is it? Yeah, so the precision is true positive divided by true positive plus false positive, right? So 20 by 20 plus 6, that is 26, right? So 20 by 6, 20 by 26 yields you 77, right? So that's how you calculate precision. Recall and F1 score will also match your formula. So for recall, it is 67 because it is true positive plus true positive plus false negative. So it will yield you around say 67% like that. So this will match. Okay, this will match the formula that we have. So that will print this output. And this is the last thing. So this is from sklearn. We are having a ROC curve. Okay, that is receiver operating characteristics. So how our model performs. Okay, what is the percentage? Okay, what is the percentage? So if you see, not going into this detail, this curve you will really plot. Okay, not going into the detail of it, just I will just give it an overview. FPR, TPR, and threshold, these are some terms for ROC curve. No need to go into detail. So if you pass the y-test value and the predicted values, then it will give you all this. FPR is false positive rate and TPR is true positive rate. And this is again based on confusion matrix only. Okay, so no need to go into much detail on this. So then we are plotting the true false positive rate and true positive rates, and we are checking the value under the curve. So this is the value under the curve. If you go ahead and calculate, it should be 0.74 as this curve tells. So our curve that our model that we have built has an accuracy of 74%, which is good enough for this. Okay.
Just a quick info, guys. If you're looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. Now, let's continue with the session.
So that's how we have. Okay, that's how we have. And this is the best accuracy that we can achieve from our model. Okay, so that's how this logistic regression works from scikit-learn. From scikit-learn, that's how you can use logistic regression to work. Okay, so see here we have some Pima Indians diabetes data set. So this will be this one. So this is this data set. Okay, this is the target value of 1 and 0. These are some fancy column names. Okay, so we have this data set. Okay, we are reading the data set. We are loading the CSV file. Okay, so load CSV. Let's go to the definition. Load CSV will be for reading the file, right? This will be this one. So pd.read CSV. It's nothing else. Okay, then next will be For I in range, ln of dataset 0, str column to float, dataset comma I. Because here we have some column in string, okay? Some column we have in string. So we are converting those to float in order to have it in so that we can apply machine learning. This is not at all required for pandas. So just this is just to make the model work. We have did that. We did that, but this is not really required. Okay. So then what we are doing, this part ignore this, not required. So here we are passing it to evaluate algorithm, data set, logistic regression, n folds, L rate and n epoch. Okay. Now let's go to evaluate algorithm. Let's see what that, okay, normalized data set, what is that model? Then it will be zero best index, actually 0, 1, 2, 3, like that it will rename actually Ravi. The pandas will do it like that. Okay. So here what we are doing in the evaluate algorithm, we are creating folds. Okay. So we are creating cross validation split and we are creating n folds just to run the data set 5 times. Okay. So for fold in folds, we have train set and test set split. Okay. Then we are predicting the value using this algorithm. So in this algorithm, the algorithm would be written. Okay. Where is the algorithm now? Actually, this file that I have, it is not the correct file. That's the problem. Okay, so this is the algorithm. Okay, logistic regression algorithm. We have trend data, we have test data, and all those things. Okay, so see, here is the curve. Y hat will be predict row comma coef. Coef will be coefficient. Okay, first let me go to this. Coef will be coefficients SGD, that is stochastic gradient descent. Train, L rate, and n epoch. Okay, these are theta values that we are passing. I mean theta values we are trying to calculate. These are just variable names, no special significance. So once we go to coefficients SGD, this one. So see, for the theta 0, I am initializing it to 0. Okay, that's what we do. And then for the vector, for the number of vectors, right, number of features that we have, for that we are calculating the coefficients. Okay, we are calculating the coefficients. Okay, so this is the value of coefficient. If you go into the maths, then if you calculate the theta values, this will be how it is coming. Okay, we're using the gradient descent formula. This is how it will be coming. And this will be the gradient descent formula for calculating coefficient. This is not required, so no need to go into detail. Just see how it works. Okay, so here it is calculating the each of the coefficients. Okay, each of the coefficient is calculating. So this is the theta vector. So see, this is the basic thing. Using gradient descent, we will calculate the theta so that it returns you the optimal theta value. Okay, so that it returns you the optimal theta value. So that's the idea. So how we are using gradient descent here? We are calculating the predicted values. Okay, we are getting the predicted values using this line. Okay, then when the predicted value is here, we are calculating the error for it. Okay, error is we haven't put in, so we have find out the difference, that is 1 minus that thing. Okay, 1 minus that thing that we have in our data set, right? In our cost function we have yi log of h theta x. So this is what is this. Okay, so this is the yi, this is the h theta x. Okay, so if it is 0, then it will be h theta x. If it is 1, it will be 1 minus h theta x. So this is that term. Now in the next part, we are calculating the coefficient from that. Okay, we are calculating the coefficient from that, and this is the theta value that we are calculating. That's how coefficients SGD function works and will return you the theta values. Okay, after that, see, come back to here, you will see after calculating the theta, we are passing it to predict the output value, because now we have a predict value. See here, here is the sigmoid function. Okay, Ravi, you are asking about sigmoid function. This is the sigmoid function. So y hat equals coefficient 0. That's what we do, like theta 0 equal to coefficient 0, that is theta 0. Then for I in range len of rho minus 1, we are keep on appending the values, that is theta 0 plus theta 1 x1, theta 2 x2, theta n xn, right? So here we are doing that. Okay, so coefficients I plus 1 means theta 0, theta 1. From theta 1 we are starting, because theta 0 we already have it, because x0 will be 1, so we are skipping it. So it will be theta 0, that is this one is theta 0, and this one is from theta 1 to theta n xn. This one is calculating that. Okay, and adding it. Okay, so theta 0 plus theta 1 x1 plus theta 2 x2 till theta n xn we are calculating in this line y hat. So we have theta transpose x ready now. Okay, then we are passing it here. So 1 by 1 plus e to the power minus theta transpose x. We are passing it here, right? So this is the predict value. So this is the sigmoid function that we are using. And this predict we are also using while calculating coefficients because that would be needed. So that's what I was trying to explain you. So h theta x we will substitute in the cost function. So using gradient descent, we are calculating coefficients values. Okay. And then we are making our predictions and we are calculating our accuracy scores. Okay, accuracy scores. So that's how this algorithm actually works. So this much of a complex task was simplified by scikit-learn, and you need to write only one line in order to find out the values. Okay, in order to find out the values. So that's how this logistic regression actually works. If you want to calculate, if you want to relate the maths and stats, that's how you can do it. Okay. So decision tree is again used for classification, or it can be used for regression also. The same algorithm, it can work for both. So decision tree is that much of a powerful tool. Okay, so it can be used for both classification and regression. But for ideal scenarios, we use it for classification because it suits it better in a better way. Okay, regression also you can use, but it is not suited. It will still yield you some result, good result, but still it is not preferred. If you want to go for a regression kind of thing, go for linear regression. Linear regression that would help you getting much better result than decision tree. Okay, so decision tree can work on basically both continuous values and categorical values. Okay, so it can work on both of this kind of data, and how it can work I will just show you in a few minutes. Okay, so these are just basic things. Logistic regression, the decision tree. So decision tree is nothing but a, so see how a tree grows, right? Tree has a root at the bottom, then as it starts growing it will be divided into branches, right? Branches will again be divided into sub branches, like that a tree grows, right? So here also we have the same approach. Okay, here also we have the same approach. Just a minute, I will take up my pad. I want to show you something. I will just draw a picture that will help you to understand this decision tree clearly, and you will see why the name is decision tree. Okay, why the name is decision tree. So if anyone here from computer science background, you must have learned binary trees or n-ary trees when taking classes, right? When taking data structure classes in the college level, right? So this tree is also similar to that, but there the branching was based on some decision. Here also branching will be based on some decision. Okay, so how the branching is done, we know if some condition is set to be, I mean if some value is set to be smaller than the root, then it will go to the left hand. If it's not, if it's greater than that, it's gonna go to right hand, right? That's how it used to work, right? So if I just draw a small thing, so you will see why this name decision tree is so is used here. Okay, you will see that. So let's say we have a root node. Okay, we will have a root node, that is this node will be blank. Okay, this node will be blank, and here we will have it, this is called root of a tree. Okay, in the, it will go to left, it will go to right, it will have some nodes, intermediate nodes. Okay, the values of intermediate nodes, then it will again branch, it will go to left and right, like that it will go on till it reaches the endpoint. Okay, till it reaches the last level. So this level is called root level, right? This is called root level. This is called the leaf nodes. This is called leaf nodes. What do we mean by leaf nodes? Leaf nodes are the end nodes, right? After this the tree cannot branch anymore. Okay, these are called branches of the tree. These decisions are called branches. Okay, so branches will be based on some decision. Okay, let's say, so if you consider this from a top down approach, if you reverse it out, you will see almost a tree like structure, right? First root is there, from that as a tree grows, it will be divided into two parts based on some conditions. So there will be branches, there will be leaves also. So see, so the tree starts from a root level, right? So root level is the starting point of the tree. Now it will keep on branching based on some XYZ decisions. Okay, and wherever each branches ends, those are called this all these things, right? All these square boxes are called nodes. Okay, these square boxes will be nodes, and each of these nodes represents a scenario. Okay, so each of this node will represent a particular scenario. Okay, so that means that will be your output. So each of this node means some of the outputs. So let's say the classification problem of mail classifier. If I draw it, so it will have a leaf node, right? That mail classifier will have a root node. So this is root. Root doesn't have anything. It is just the mail object. Okay, so the one of the lines in the CSV. So then it will branch. Okay, it will branch like spam words. We used it, right? So spam words greater than 3, spam words less than 3. Okay, so here if I come, it will be spam, it will be not spam, like that. Okay, it will be not spam. So this is a state, this is a state. Okay, this is a scenario. Now if we come here with spam word 3, and if we have some other conditions also, then we will keep on branching. Okay, so wherever we found this nodes will be a individual scenario for that data. Okay, for the data, this nodes will be the individual scenarios. And where the tree stops, okay, where the tree stops, like for this case, if I remove this line, so it's here. So wherever the tree gets stopped, those nodes are called leaf nodes. So they will be your ultimate outputs. Okay, they will be your ultimate outputs. That's why this is called a like decision tree, because this structure branches in and out like a tree. So there will be root, there will be branches, there will be leaf nodes, there will be nodes, and everything will be there. So this is how a tree grows. Okay, now let's go ahead with the PPT. Let's get into detail. How do we use it? So see, this is an example. So age less than 30, if it is a yes, then it's a lot of pizzas. So first we are checking, is a person fit or not. We are checking if the person age is less than 30, right? So if it is a yes, then we are checking if he hits a lots of pizzas or not. So generally less than 30 guys will be fitter, right? So if he doesn't eat some junk foods daily, so that's what we are checking. If he eats it, then unfit. If it doesn't, he is fit, right? But for less than if it's greater than 30, then you need to exercise, because after 30 your health starts degrading. If you does, you are fit. If you're not, you are unfit. So that's how a decision tree grows. That's how a decision tree works actually. Okay, so for random forest, what we have, random forest will be having multiple decision trees. Okay, it will have multiple decision trees. Then we will be calculating all the decision output of the decision tree. We will take all those, we will merge those to get some accurate and stable prediction. Okay, so this is but what the problem with random forest is, why we don't prefer it, because random forest, as we have multiple decision trees, we will be having a problem of overfitting, because we have n number of decision trees based on number of features. So if we create a decision tree for each of the features that we have, it might overfit the training data. So it is a good algorithm, but for data science or machine learning anywhere, you need to use it carefully. So that's why we kind of try to avoid this. Okay, we're trying to kind of avoid this. So there are many scenarios when you need to include multiple decision trees. There you need to take care of the decision tree sizes and all. Okay, so that's why for the beginners it is not it is not advisable to go for random forest at the beginning, because random forest can have a problem overfitting. As you can see, if you have 5 features in a data set, and if you create decision tree for each one of them, right? Let's say for age, so here we have seen age less than 30. If you try and create a larger decision tree, if you start from age less than 10, then 50, then 15, then 20, 25, 30, if you keep on growing the age group like that, if you, let's say in the data set you have, so in this you let's say you have something called like age, and in the data set that you have number of, let's say, a number of age groups, and you are creating models for, you are creating nodes for each of the age groups. So then that data will be overfitting. Okay, naive bias is another like classification algorithm. Okay, so naive bias, as you know, right? In the probability theory, we have conditional probability theory, we have it, right? Bayes theorem. So that is what is the basic of this naive bias theorem. So what we have, probability of A given B has happened, then the how we write the formula, probability that B probability of B given that A is happened, multiplied by probability of A divided by probability of B. This is what is the basic of naive Bayes theorem. Okay, so this is this takes into account some historical knowledges. Okay, so as you see, you are trying to predict probability of some event A with respect to probability of and you know that that B has already happened. So you are taking this as a historical factor. Probability of B given probability of A has probability of B provided A has already happened. So this is a historical factor. So you need this historical knowledge in your when you have this historical knowledge, then you can go for naive Bayes theorem, like let's say for cancer prediction, right? So it doesn't mean that a test, if it comes to be positive, will definitely mean that that someone has a cancer or some other diseases, right? So what you can do, you can I mean, if you have this so let's say in past you have seen like guys like 70% of guys who has a positive result in the test. So let's say in past you have seen the 30% of the guys having positive test means they have a cancer. So in those cases, naive Bayes you can use, because you need to have a historical thing. And next thing that you need to take care of is the features in the data set should be unrelated to each other. Okay, it shouldn't be related, because as you can see, like this depends on some other, so feature X depends on feature Y. The probability of feature X depends on if feature Y is present or not. So that's why the features should be like unrelated to each other. Otherwise, it will be a problem, and this the theory will fail. Okay, so this is a classification based on Bayes theorem, as I already told. Presence of particular feature, this also I told, right? So presence of a particular feature in a class has to be independent of any of the classes. So any calculated feature shouldn't be there. Otherwise, this will fail, because that probability it will yield as 1. So see, probability of disease you know as 0.1, and probability of disease bar, that is 1 minus probability of disease, is 0.9. So you know that probability that someone has tested with positive, given that he has the disease, is 80%, and it is the reverse. Like probability of negatively tested having a disease is 20%. So this kind of historical knowledge you will need. So these are the historical knowledges that you have. Okay. So let's say you are running a diagnostic clinic, so you are gathering this historical data to find out the actual values. Okay. So that's what we have. So this is what is the basic of this thing. Now first we will go for decision tree, then we will be going for the example. Decision tree and logistic regression you can use anywhere. So you just need to practice it, you will get the idea better. So whatever can be solved with logistic regression can be solved with decision tree also. Okay, but building decision tree takes up some time. So for beginners, go for logistic regression, try to move into decision tree slowly, but decision tree will yield you accurate result, but you might run into overfitting problems also. Next is, let's say we are doing fruit classification. Okay, so we have color and diameter. Okay, we have color and diameter, these two labels. We have color green, mango, yellow, lemon, and all these things, and diameter of those are 3 and 1. Okay, so this data set is not clear, so let's just adjust it for a moment. I will explain how it works. Okay, so before that I will show you all this. So how this decision tree works, and how do you know when to stop, right? So we have a factor called entropy, information gain, and gene impurity. Okay, so you need to check those things. So if you remember the laws of thermodynamics, right? What does entropy says? Entropy is entropy will be zero if the set is perfectly ordered, right? Entropy will be zero if the set is perfectly ordered. It will be high if the set is perfectly disordered. So you need to calculate entropy. There is a formula I will show you shortly. So from that entropy, you need to calculate this information gain. These formulas I am coming to it. So you need to go on calculating this. So if any point you see the information gain is not something positive, then you need to stop it, because there is no need of splitting the tree, because that's not gonna yield you something, right? So that's how you need to figure out about this decision tree. So see, this is the ideal scenario. Is diameter greater than equal to 3? Then if it's less than 3, then we have only cherry, right? Because it is have R1 and cherry, so diameter of cherry is 1, so it will be cherry. If it's greater than 3, then we have two options, like mango and lemon, right? Like mango and lemon. So now we will be checking color. So if the color is yellow, then we will say it's lemon. If not, then we will say it is a mango. Okay, So that's how this decision tree works. That's how the decision tree is built. Let's see with the example now. Okay. Before that, these are a few terminologies: root node, leaf node, parent, child, and branch and subtrees. You can see like these are all related to the like present world only. So the root node, leaf node, I have already covered. Parent and child node, like the predecessor node is called parent, the successor is called child. It's that simple. Okay. Branching and branch and subtrees are, you can see like if you it can have multiple subtrees. So so these are branches, as I told. So this left subtree can be one subtree, this right subtree can be one, this subtree can be one. So it is basically independent parts of the decision tree. Those are called subtrees. As you see from the tree itself, it's identical to the tree. In the real world nature, it's identical to the trees. So that's how. Okay. So next is coming two important terms: splitting and pruning. Splitting means dividing root nodes into different parts or the different child nodes, right? That's what is splitting. So splitting is the heart of decision tree, because if you don't split it wisely, then your decision tree can be a mess. Okay. So splitting is a part of it. So splitting means splitting the root node into splitting the root nodes into child nodes. Okay. So pruning, it will be, and random forest we would be covering in that much detail, so let's not worry about it for now. For now, just have this decision tree into mind. You will see you are getting confused with the decision tree alone. So let's just grab this concept first. Okay. Pruning, that's a very important thing. Okay. So if you are trying to build a decision tree, you can run into one of the two problems. Like you can either underfit the training data, or you can overfit the training data. So how does it happen? So if you see, like if you build a small tree, right, then you are not gonna fit the data, you are going to underfit the training data, right? But if you are trying to build a huge tree, like a huge bush kind of a thing, then you will be overfitting the training data, because you will analyze the data, you will break down the data into so much nested levels that it is going to overfit the data. So that's where pruning comes very handy. So for making ideal decision trees, what we do, we don't care about what are the levels, if it underfits or overfits, what it does, we don't care about it. Okay. We let the tree grow. As soon as you have decisions, we let the tree grow. Then we come back and prune the branches where we see the information gain is not that valuable, or where we see the information gain is, or entropy is too low to consider. So those things we can take care manually by pruning the branches. Okay. So that will make the tree shorter, which will in turn give you a good result, which will in turn give you a very good result. Because that in that way, what you can do I mean, first you can if you build a small tree, then you won't be able to optimize the tree, right? Because it will be small and it will be underfitted already. So if you build a big tree, a bush you can consider it as, so then what you will have lots of training example, lots of branches, lots of decisions that were there in the tree, and from that you can choose wisely, like which one to use, which one not to use. These are theoretical concepts, have these things clear. Because if when you go for interview, interviewers are not going to ask you how to make a decision tree out of a scikit-learn package. They know you know it, because that's just a one liner syntax. So they are going to hit you in this core concepts. Okay. They are going to hit you in code concepts. So they can ask you how to solve the problem of under overfitting in a decision tree, or underfitting in a decision tree. These things then you need to answer. We can have splitting, we can have pruning, we can check the entropy, information gain, and gene impurities, gene index values to check it out. Okay, to check that out. So if it's still splittable, then we can have it go ahead and we can split it. If the information gain is 0, then we can stop, then we can prune those branches like that. Okay. So that's how. And for all the algorithms, it's the same thing. They can, for linear regression and logistic regression, they can ask you why you don't use linear regression function in logistic regression, right? Cost function and logistic regression. Those things are theoretical questions will be asked. So they are not going to ask write a code that will implement decision tree. It's not possible for anyone. It's not possible to learn to write that entire code, but they might ask you for the algorithm. So go ahead and show them this. Okay, like that. You can say like I can show you graphically how a decision tree works, like that. Okay. let's go ahead and see how do we create a decision tree manually. Okay, I mean mathematically. Okay, so see, this is our data set: outlook, temperature, humidity, windy, and play. So these all are features from outlook till windy. These are all our features, and play is the binary variable that we are going to predict. So if the outlook is sunny, temperature is hot, humidity high, windy, it's not windy, should we play or not? So it's a no. So this is our labeled data set that we have. So now let's go ahead and see how do we decide whether we play or not. Given a condition, how do we decide if we play or not? And how do we pick this first and second things, right? How do we pick that? So like which one among them should you pick first? That means we need to start our branching from somewhere or something, right? So should we start branching with outlook? Should we start branching with temperature? How do we go about it, right? So we need to determine the attribute that best classifies the training data. What does that mean? Let's go ahead and see the answer. Okay, I mean, how do we decide where to split? So these are four things that we're going to check. Okay, so first one is entropy, that defines a randomness. This is a metric which measures the impurity, right? As I already told, so this is the first step to check the data. So what we can do, we can split the data based on anything, and then we can go ahead and check the entropy, and then we can decide on it. Okay, so and we can decide on it. So that's how we can I mean, that's how we can go ahead and do it. There is reduction in variance. So as you can understand, if this like, one second, getting a call, one second. Yeah, so reduction in variance, as you understand, like if you keep on reducing, I mean, if the entropy is reduced, then the variance will also be reduced. Okay, so we will be start to split the data based on the lower variance value. Then there is information gain, that is calculated based on entropy actually. And if you see, if where the information gain is highest, from there we will start splitting the data. Gini index is also the same thing. So that is again used in cart model of so decision tree in cart. When we do, like, cart means classification and regression trees. Okay, so when we use cart model of decision tree, then we do it. Then we use this, like, what this Gini index to have the Gini index to calculate this. Okay, and the how this Gini index is calculated, we will be seeing that in a moment. So I will write the formula and show you. Okay, let's wait for a few minutes. I will show you all this one by one. So let's go ahead with the example first. Why we using decision tree? Okay, so see, now entropy formula is here, right? Negative P of ES multiplied by log of PES minus P of no into log of P no. So that is how entropy is defined. That means we need to add the entire thing, like, and the probability of both the events multiplied by their log likelihoods. Okay, so that will get you the likelihood of the event. Okay, we need to add those both, and we need to put a negative sign I mean, we need to calculate the entropy like that. Okay, so P of yes means probability of yes, P of no means probability of no, like that. And if you going to draw this curve, then you will get, so negative sign is given just to make it positive, because log P can yield you negative result somewhere, because log value will be pretty small, so it can yield you negative. Just to make it positive, the negative sign is given, nothing else. Okay, if you draw this curve of this kind of a function, you will get this kind of a hyperbola kind of a shape, right? So number of yes, if it's 0.5, then entropy will be 1. So as you see, for 0.5, that is the perfect equilibrium, right? When the data is perfectly in equilibrium, we will have the highest value, that is 1, right? When the data, so that means here the disturbance of the data is highest, right? Because it has both the components, right? It is both the components. Why? So true and false are mixed, right? True and false are mixed, so it is the highest of impurity. So let's say if you have a 30% yes and 70% no, then also the data is somewhat skewed to to no part, right? It is not that much of a what should I say? It's not that much of a impure. It doesn't have that much of a impurity, so it's not in the what it's not in the chaotic state, right? So you will see the value is reducing. So if you have 0 and 1, for this the value is maximum, that is value is minimum, that is 0, right? Why 0? Because the data is in perfect equilibrium, because we have either all yeses or all no's. There is no other values, so either all yes or all no. So in that case it goes to 0. So that is the perfect equilibrium scenario, right? That is the perfect equilibrium scenario. So that's how entropy works. So entropy is a measure of impurity in the data set. So as it lowers, the value of entropy will be lowered. As it gets higher, the value of entropy will get higher, and the 0.5 it will attain its maximum value of 1. Okay, so that's what is about entropy. And how do we calculate? We calculate like that. So P of event multiplied by log of P of event minus P of another event multiplied by log of P of that event, like that. Okay, so is this clear now? Entropy is clear? Then we will go ahead, because we are going to build the entire model based on this entropy only. So if you see, this is the entropy calculation. Let's leave it, no issues. So these are entropy calculations. These things you can easily get, right? I'm not repeating these things, log additions and all. So this is just, we have just proven that this formula can be this formula yields you 0 or 1, 1 at 0.5 and 0 at 1. So that's what. So it's not that much. We'll just skip it. We will go to this much, right? This one, the main thing that we have in the question. So we have 14 instances of the data here. Now we have 9 yes, 5 no, right? So we have calculated the entropy to be 0.94 here, right? We have calculated the entropy to be 0.94. So see here, 9 yes, 5 no, that is chaotic. So value is really high, right? Value is really high. Now our object is to like divide it into subtrees so that the subtree can yield a perfect value. Let's see how we can do it. The initial entropy value is 0.94. Now we have this concept of entropy. Okay, like information gain, sorry. So information gain will be entropy minus weighted average into entropy of each feature. Let's see how do we calculate. How many features do we have? Outlook, temperature, humidity, windy, right? 4 features. We will calculate entropy of both, entropy of all. Okay, so here see, now this is the information gain. This is the information gain. How are we calculating? Weighted average multiplied by entropy of each feature. Okay, so we have 4 features: temperature, outlook, humidity, windy. Now in order to calculate like this information gain for some node, we need to split the tree. We need to start it from somewhere. Let's go ahead and start with outlook. Okay, so from outlook, when we started, we have sunny, overcast and rainy, right? Three things. So for each of the features we are going to do this. We are starting with outlook just as a basic. You can start with temperature also, that's up to you. This is not just that doesn't mean much. Okay, so outlook has 3 values: sunny, overcast, rainy, and it has some yes no kind of things, right? So for sunny, 2 yes, 3 no's; overcast, 4 yes; rainy, 3 yes, 2 no's, right? Let's go ahead and calculate entropy and information gain in this outlook node. Okay, so see, E outlook equals sunny is minus 2 by 5. Why 2 by 5? Because we have 2 yes, 3 no's, right? 2 yes, 3 no's. For sunny, 2 yes, 3 no's, right? So we have minus 2 by 5 multiplied by log of 2 by 5 minus 3 by 5 log of 2, 3 by 5. So 0.97. See, the value is getting higher. So in entropy for outlook equal to sunny is 97. For overcast, it is all yes, so it is 0. For rainy, it is 0.97, right? Because it has same thing, 3 no yes, 2 no's, doesn't matter, it will yield you same result. So this is entropy of each of these subsets. Now we are going to calculate their average weights. Okay, with their we are going to calculate the information gain from the entropy. Okay, so how do we calculate information gain from all this all this entropies of this outlook feature? As you know, it is weighted average. Weighted average means how many examples you have under sunny as yes no, right? So here see how many of this data has outlook sunny: 2, 2, 4, 1, 5. So weighted average for sunny will be 5 by 14. Number of that feature occurring in the data set divided by total number of samples in the data set, multiplied by what is the entropy of outlook being sunny? 0.97, right? We have calculated the information gain to be 0.693. Okay, this is not information gain, this is the information that we get from the outlook variable. Okay, this is the weighted average multiplied by this. So let me write it down to clear your doubts here. So for information gain, right, we have an equation like E of S, that is entropy of the sample minus weighted average multiplied by entropy of feature, right? So this part is called information, right? This part is called information. Why information? Because if you see this number, what does that mean? That this outlook feature in the data set has a weight of 69.693 in deciding the outcome of the data set. So this is called information that we have from the amount of information that we can get from this outlook value. Now what is information gain? It will be when we subtract it from entropy, right? Because the data set is already impure and we have some kind of information from a feature. If we negate those, then we get the information that is really meaningful to us. Because in this data set, right, in this data set, when we calculated entropy, we taken into account all this, right, all this 14, right, we have taken into account. Now now we have the total entropy, that is the total information, there is a total entropy of the sample space. Now we have the amount of information that we can get from outlook, only outlook, no other parameters are included, only outlook. What is the information that we can have, the amount of information that we saw to seem to be 0.693. But the entropy that we have in that, we already calculated this 693 part, right? We already had the 693 part included, because when we calculated entropy, we taken the entire data set into account. So if we negate this two, then we are getting the information gain of the data set. That means information gain from the outlook is 0.247. That's one measure. Okay, now next what we are going to do, we are going to calculate information gain for all other nodes in the similar way, and you will see the max gain that we can have is 247, right? We can have is 247. So max gain will be 247. So we are going to start splitting with outlook. We will first split with outlook, then we will check for the next is what, humidity, then we'll check for temperature. Like that we are going to create our tree. Now that's where we use entropy and information gain to decide on this data set, and we will keep on calculating this at each level to see if anywhere information gain becomes zero, we are going to stop it. Okay, so that's what is about the concept of information gain and entropy and how we can use it to decide the best feature. Let's go ahead. So for temperature, as you see, we have hot, mild, cool, three, right? So for hot, if you need to take out these data sets, no, no, yes, yes. So two yes, two no's. So it's in 0.5. So entropy will be highest for this. Like that, for mild also you can check, for cool also you can check. You can fit in into this formula and you can check the manual result also. That we can clarify the results. Yeah. Okay, so let's go ahead and see how do we split. So outlook, sunny, rain, overcast, right? As you see, that's what comes into picture when a entropy is zero, right? Outlook, entropy of outlook being overcast is zero, because all the examples here are are ES values, right? So when we start splitting on the outlook, what we will do for overcast, if the condition is overcast, we no need to consider any other variables into account. We can say the output will always be yes. So that's what happens when entropy becomes zero. Okay, so whenever you see outlook is overcast, tag that to yes, no need to check other conditions, so that we will stop here. If it's sunny or rain, we still need to go for other features to see if it's a yes or no. So let's see how we go about it. So now next is windy. Why windy? Okay, windy we don't have, but windy's information gain is in the second hand. Okay, windy's information gain is 0.048. So okay, so for humidity we have 0.152, right? We have 0.152 for humidity. we have 0.029 for temperature, and for windy we have 0.048. So the next two nodes of the split will be humidity and windy. Okay, humidity and windy. So windy here it is calculated in the same way, not explaining that. Let's go ahead, then we will be calculating with humidity and windy. Okay, so if humidity is high then no, if normal then yes, if windy is strong then no, if weak then yes. So if you go ahead and check, let's say humidity high, right? So how can we check this, right? How can we check this? So see here, if outlook is sunny and humidity is high, what is the output? Outlook is sunny, humidity high, output is no. Outlook sunny, humidity high, output is no. Outlook sunny, humidity high, no. Outlook sunny, humidity normal, yes. So if outlook is sunny and humidity is high, we are going to have a default no. So we no need to take into account other variables, right? But if it happened that for humidity high we have one yes, then we would have taken into account the temperature feature. Okay, but here we no need we don't need that. Okay, here we don't need that, because outlook and humidity, outlook sunny and humidity combination can yield you a perfect equilibrium state where entropy becomes zero. So you can stop it there. But if you didn't had this kind of a thing, then you would have gone for the temperature variable or the windy the temperature variable, right? So that's how it calculated. Now go for outlook. Is outlook overcast always yes, leave it, no issues. Outlook rain and there is a strong wind, right? Let's see. Outlook rainy, windy false, right? From where it got to strong weak. Okay, windy false, that means weak winds, we have yes. Outlook rainy, windy false, we have yes. Outlook rainy, windy, we have no. Outlook rainy, not windy, we have again yes. So if outlook is rainy, outlook rainy, windy true, we have no. Perfect equilibrium, no need of further split. So if we have outlook to be rainy and if the wind is weak, we are going to play. If not, we are going to we are not going to play. So that's what you can see from the data set itself, right? So thus the tree reaches. So if you calculate equilibrium of each of these nodes, you will, I mean, entropy of each of these nodes, you will get a zero, because the subset that the data contains here at this point of time, like what I showed manually, right? If you calculate entropy of it, you will see all the variables are the same result. So it will be having zero entropy. So the tree stops here. If it didn't had this kind of a thing, we would have gone for the temperature variable. But whereas this is not needed. Here, this is not needed. Okay. So that's how we have it. Okay, that's how we have it. So humidity and windy, Ankur, will always be on the always be down the outlook, right? That's what it is. So both are on the right left, doesn't matter, you can have it in the any way and anywhere, right? Why humidity below sunny, not windy? Because humidity's information gain is the highest after outlook, humidity is the highest, wind is the second highest, right? So we will go with the two nodes. When you are going to branch, it will have more than one branches, right? If for overcast it didn't had this, then we would have gone for windy here, here temperature, like that. So when you are branching the trees, you need to select the nodes having highest information gain. Okay, and the highest ones will always be on the left. So that's how you can exchange the right and left subtree also, that doesn't matter. It's just a you can take it in any ways, the result will be same. So after humidity we don't need anything, right? So humidity windy combination won't yield you any result, as you can see, because if it's sunny and based on humidity only, you will get the perfect equilibrium, so we don't need to go about it. Okay, that's right. Okay, so that's what sums up this example. Okay. Okay, so next we have confusion matrix, guys. This we have shown in the this we have seen in the last class, right? So not going to explain this here also, because it will be a repetitive thing, right? So here just a calculation I will show you. So see here we have a expected, so everyone remembers confusion matrix, right? True positive, false negative, true negative, everyone remembers these terms, right? So let's go ahead and see an example here. Okay, so we have a expected and predicted sheet where we have man and woman as predicted. So see, we have predicted three places we have predicted it wrong. Okay, and we have predicted 7 as correct. So accuracy of the model will be 70%. Okay, so as you know that, right? You know that already. So next is men which are classified as men. How many are those kind of instances? Man as man, 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 man. So 3. Woman classified as woman, we have 1, 2, 3, 4, right? We have 4. So, sorry, 1, 2, 3, 4. So, now if we men classified as woman, we have 2. Woman classified as man, we have 1. So now if we go ahead and build this, so this is your positive, this is your positive. So this one is true positive, that is 3. This one is woman, woman. So this is true negative, that is 4, right? We have this men and woman. So that is true negative, 1. This is woman, men. This is false negative. That is, this is false positive. This is false positive. False men calculated as woman, false. So false positive, 1. False negative, 2, right? We have it like that. Now we can go ahead. So this is how confusion matrices are made in the real world. Okay, true positive, false positive, like that we calculate. Okay, like that we calculate. So that's how we have this kind of the confusion matrices. So next thing is naive bias. Before that, we will see the example of the decision tree hands-on. Okay, so we have a banknote data set. Okay, it will be classifying the banknotes as true, false, like that. Okay, this is a banknote data set. Okay, now we are going to define a function to load the data. So this is nothing but pd.read csv. Okay, this is our own function we have defined. You can go for pd.read csv also. Okay, so let's not waste time on it. Okay, see, these are some calculations of Gini index and all those things. I will come to it later. Let me show you how you can use scikit-learn to. Okay, this is the, what is it? Okay, let me show you. So this is for loading the CSV files, not explaining line by line. This is for converting a column to float, string column to float, because decision tree we will work with data, not string. So we are converting string columns to float, because this is a CSV file, right? All those will be read as string only. We haven't used pandas. We have written our own function. So we would need to do change all these columns to real world numbers. Okay. This is for creating cross validation set. What is cross validation set? Let's say you have 1,000 rows of data to process. You don't feed the entire data to the model at once. Okay, you just you provide the data to the model in folds, multiple folds. What that would do, that would help you in gaining the most out of the model, because in the first model, whatever mistakes it does, it will learn, it will go for the second step, like that. Okay, so here we will be splitting the data into cross validation sets. Okay, next will be to calculate the accuracy, that is correct divided by expected by predicted correctly predicted value, number of correctly predicted values divided by the entire divided by the total number of what samples in the data set. So that is for that. Next is for evaluating the algorithm. Here I will take some time to explain this. Others are already, you have seen it multiple times, so it's the same thing basically, it's nothing else. Okay, so here you see that 80-20 split that you are seeing. So this is the manual implementation of decision tree. So that's why we are writing all these algorithms on hand. Okay, this can be done with scikit-learn in one liner also, that's also there. Okay, so that's all. Okay, next one is for this evaluate algorithm. We are splitting the data set into cross validation sets, right? We are now we are sending the folds one by one. Okay, we are sending each fold one by one to the machine learning model to predict the algorithm or to predict the output. Okay, so see, we are creating trend test split. Okay, we are creating trend test split of 80-20 in this function. So here we are doing it. Okay, for each row we are copying the row, we are appending to test set, and we are removing it from the train set, like that. We are creating train test split, and then we are passing this to the algorithm that we have. So algorithm is nothing but the decision tree that I am coming to it. So next is actual prediction, that is there in the data set. That is the last column, and there is accuracy, that is actual by predicted we are getting from the algorithm output, right? So that is the decision tree algorithm actually. Okay, that is the decision tree algorithm that we have. I will show you. So next is actual and predicted. We are just appending the scores. Okay, next is test split. See here, we are creating the test split here. Okay, we will be passing a 20 value here to get the test split. This is for getting the Gini index. Okay, for Gini index, the measure is pi into pj, okay, where for in the all sample it is the just pi into pj, that is weight of the group score by its relative size. Okay, so it will always be this way it will be calculated. So it's not much to be understood in detail, because you are not going to write this algorithms in manually. It's just gonna do, you just gonna you do with like scikit-learn, so it won't be used much. Okay, next is define a function to best split for the data set. So class values will be so we are getting a split here, no need to waste time here. I don't want to split the time, spend time here, because you are not going to write this manually. Okay, this is just to show you like how it works. And this is the split algorithm to split the left and right subtree. Okay, you can go through the code, let me know if you have any problem. We are building a tree with the help of the split function, right? We are passing each and every node, we are passing the root node, we are passing the max depth, min size, and we are started splitting this. Okay, we are splitting based on the Gini index. We will see how those are calculated. Next is these are for prediction. Okay, these are for predicted predictions that we have. And now the main thing comes into picture. This is the decision tree algorithm model. Okay, this is the decision tree algorithm model. Now next step will be to read the data set. Okay, so don't no need to go for the details of those algorithms. I will explain how it works in full. Okay, so we are reading the file with the load csv command. Load csv command, we are reading the file. Okay, then we are converting all the columns into floats. Okay, as I told. Then what we are doing, we are creating n folds. So we are taking three values: n folds, max depth, and min size. Okay, then we are going to scores. That is, we are going to calling the evaluate algorithm method that we have defined earlier, and from that, using all the concepts that we learned till now, it is passing data set. Decision tree is the algorithm name. So where is this evaluate algorithm? Yeah, so algorithm, it has decision tree. So here decision tree will be put, right? So decision tree we have defined, where we have defined here. So trend, test, max depth, min size, these values it gets. So first it passes the tree to build tree, right? So if we go to build tree, you will see this is the build tree. What it is doing, it is doing root equals get split train, right? So get split, if we revisit now, see here the calculation, if you see, it is calculating the Gini index and information gain for the nodes, and it is deciding the root node. Okay, it is deciding the root node, and based on the root node it will start splitting. Now next we are passing this root will be the feature name. Okay, root will be the feature name. We are passing it to the split function. So this is the root node, and from root we will be start splitting the data into left and right. Okay, we will start splitting the data into left and right. Okay, so then we will return the root, because when we build a tree, we always access the tree via root. We don't go to the leaf directly, that will mess up the tree. So that's what it is doing. So evaluate algorithm again. Now evaluate algorithm, what it is doing, evaluate algorithm here is taking the actual values and predicted values. It is calculating the accuracy, and it is sending it out, right? It is sending it out. So now we have printed all this. We have printed the accuracy for all the folds. Okay, all the folds, all the 6 folds. So see how the accuracy started to slowly improve throughout the folds, right? How it slowly improved, and the mean accuracy that we are getting is 97.299. Okay, so that's how this decision tree works in a real world. So again, this is not how you're gonna use it. You're gonna use it with scikit-learn. So just try one thing. So that's how you can do it. Anvesh and others, for Gini index. Gini index is a measure, again a measure that is used for, like in cart models, that is an metric that is used. It is same as information gain. So information gain and Gini index, anyone you can anything you can use. But for cart models, basically we use both, but somewhere we use Gini index only. So it is again based on the weighted average. Okay, so it is just a concept of cart models, nothing much, nothing much. Cart and decision tree are the same, Ravi. Cart full form is classification and regression trees. As I told you, right here, if you have, if you have house values, then also you can apply this decision tree. But that way, your tree will be really big. And if you start pruning the branches over there, it won't yield you any result. So generally, we don't use it. but you can use it for regression purpose also. So there it will, there also you can use it. Okay, so that's how we have for the decision tree example, and that's how it works. Okay, no need to go into much depth of this algorithms, the code that we have in this, because it is a high level Python code. So you can try and try looking through the code and let me know if you have any doubt, and also just try using scikit-learn decision tree algorithm. Okay, so that's what we have for now. Next we will be going to naive Bayes. So let's go ahead with the naive Bayes classifier now. Okay, so what is it, how do we use it, we have shown, right? Now let's get a deep dive into it. So naive Bayes will assume that presence of any particular feature in a class is unrelated to present of any other feature. In short we can say, in naive Bayes there will be no calculated feature. Okay, there will be no feature engineering will be there, otherwise naive Bayes can't work. Okay, so let's say here we have, for identifying an apple we have three parameters: red, round, and 3 inches in diameter. So these three all are independent of each other, right? These three are all independent of each other. So here we can use naive Bayes in this case of this kind of scenarios. So why it is naive, right? Because the naive Bayes algorithm will have many limitations, right? It won't be sophisticated, it won't be experienced like that, right? So that means in naive Bayes we are solely dependent on the past data that we have, the historical data that we have, plus we need to use the exact features which are given in the data set. We can't do feature engineering in that. So in many cases naive Bayes will fall short. So naive Bayes we generally don't use much, but still in some cases where we have this historical knowledge, in those cases naive Bayes proves to be good, so we use it. But in naive Bayes prediction accuracy can be really low. We will see that. Okay, next is the fundamental of Bayes theorem and its proof. Okay, so this I have already told. So let's go ahead and prove this. Okay, so calculate the probability of a second event B given that the first event A has already happened. Okay, so that means when this kind of so this is a concept of conditional probability. So how it works? It works in such a case where where we try to calculate probability of some event provided some other event has already been happened. Okay, so drawing a second ace from a deck given we got the first ace, right? So what does that mean? We already have drawn a ace from the deck. We will have 4 aces in the deck, right? So we have already drawn a first ace. Now we want to go ahead and draw the second ace. So it will directly become a conditional probability, right? Why? Because total number of cards in a deck will be 52, right? If we have the deck intact and if we try and draw the ace, in the first card that we are going to draw will be a ace, in that case the probability of it would be 4 by 52, right? It will be 4 by 52. But if we have drawn that card, then we will be have left with 51 cards, among which 3 will be aces. So the probability of drawing a second ace from the deck given the first ace is already there will be 3 by 51, that is 1 by 17, right? Yeah, correct. So that way this conditional probability works. So that means finding a probability that you having a disease when you are positive to that, right? When you are tested positive, but the test result can be non-negative, right? So like that. So if someone likes Game of Thrones, what is the probability that he will like fiction movies, right? So this kind of probabilities are called conditional probabilities, right? So here you need to understand, when we apply to data science we need to have a prior knowledge, right? We need to have a prior knowledge on what has happened in the past. So in that way only we can use this naive Bayes, when we have this prior knowledge. In no other cases we can use this naive Bayes theorem, because the entire theorem is dependent on conditional probability, which differs you to have a prior knowledge, a historical knowledge. So let's say we have we want to check if a person likes fiction movies or not, right? So how do we can't apply naive Bayes, right? We don't know anything. So when we know the person has already liked Game of Thrones, then what is the probability of him being liking fiction? that comes a conditional probability way, or that comes to be and that becomes a good example where we can use naive Bayes classification, naive Bayes classifier. Okay, so that's how this thing works. That's how these things work. Okay, so that's how it is. Okay, next if we go ahead and see like event, yes Ravi, somewhere it so in movie recommend so for recommenders there is a separate topic called recommendation recommender system, but yes, you can use naive Bayes to calculate those kind of predictions. So given up, if you have the prior knowledge, you can use it. Okay, if you have a prior knowledge of the system, you can use this concept there also in the classification, I mean in the movie recommender system. Okay, you can do it. Okay, next is so probability of A, given that probability of B is already happened, we can write it as probability of A intersection B. That is probability of both the events, probability of occurrence of both the events divided by probability of B. So that's what is the probability of A given that B has happened. That's what the formula is. Now, so that is the formula, probability of A intersection B divided by probability of B. Okay, that's the formula. So we can prove it like the earlier the formula that we have seen. From that to this we can prove this. There is a mathematical proof, not going into that detail. So I think we have it later. Yes, we have it. We will show you. Okay, for now let's assume this only. Probability of A that B has already happened is probability of A intersection B by probability of B. Okay, now let's go ahead and see some examples how this works. Okay, suppose we have a jar of 6 marbles, 3 black and 3 red. What is the probability of getting a black given the first one was black too, right? Let's go ahead and see how can we calculate this. Probability of A is getting a black marble, probability of B is getting a black marble in the second turn. Okay, so probability of A will be 3 by 6, probability of B will be 2 by 5. So A intersection B will be 2 by 5 into 3 by 6, that is half, so 1 by 5. So probability of B given that A has happened will be probability of A intersection B, that is 0.2 divided by 0.5, that is 0.4. So probability that the second marble will be black when the first marble is already black is 0.4. Okay, that's how these calculations are done. Okay, that's how these calculations are. Okay, next is John's favorite breakfast is cereal and his favorite lunch is pizza. Okay, probability of John having cereal for breakfast is 0.6. Probability of him having pizza for lunch is 0.5. Now what is the probability of him having cereal for breakfast given that he eats pizza for lunch is 0.7. Okay, so see here, when John given that he eats pizza for lunch is 0.7. Okay, pizza for lunch is 0.5. Probability of him having a cereal for breakfast given that he eats pizza for lunch is 0.7. Okay, so probability of John having cereal for breakfast, let's have it as A, 0.6. Him having lunch as pizza will be 0.5. Okay, so probability of B 0.5. Probability of A with respect to B, that is John having cereal for breakfast given B has happened, that is he eats pizza for lunch is 0.7. Now calculate the reverse. Okay, what is the probability of him having having pizza for lunch given he has cereal for breakfast? What is the probability of that? Let's go ahead and calculate that. So if you want to know the probability of having a pizza given that he has cereal in the breakfast, what is the probability? So it will be the reverse probability, that is probability of B by A. So here in this kind of scenarios, Bayes theorem comes into picture. Okay, this kind of scenarios, Bayes theorem comes into picture. Now Bayes theorem so here if you see both this event in the first run, we were able to calculate A intersection B, right? Because the events are interdependent, right? Because the events are interdependent. So, but here the events are totally different from each other, they are unrelated. So in these cases Bayes theorem comes into picture. Okay, so if we have a conditional probability of a when B has already happened, then using Bayes theorem we can find the reverse, that is probability of B given A has already happened. Okay, we can do that using Bayes theorem. So we know probability of A by B is probability of A intersection B divided by probability of B. B by A is the reverse way. From that we can come to this conclusion, like probability of B given A has happened is equals probability of A given B has happened multiplied by probability of B by probability of A. This line at the bottom is called as Bayes theorem. Okay, So this comes into picture when we cannot calculate probability of A intersection B, because the events are not the events are not related to each other. They are totally independent, right? In this case, or this kind of scenarios, Bayes theorem comes into picture. So probability of A given B has happened. This is the probability that we are going to calculate. Probability of B where given A has already happened. This is the probability of B being true given that A is true. This is the prior knowledge that we have. Probability of A and probability of B, this knowledge will also we have. Okay, so this probability of B by A, this is the historical knowledge that we have. Okay, this is the historical knowledge that we had to have for applying Bayes theorem into our algorithm. So probability of pizza given C as cereal for breakfast is 0.7 into 5 by 6, so that is somewhere around will be 3.5 by 6, so somewhere around 0.6, right? Somewhere around 0.6 it will be. Okay, so where do we use this kind of Bayes theorem, right? Find out a patient's probability of having a liver disease if they are alcoholic. So here in this kind of scenarios we have this kind of Bayes theorem we can use. Okay, so a patient has liver disease, so past data tells you that the probability of a patient having liver disease who walks into your clinic is 0.1. Probability of patient being alcoholic, these are from all past data that you know, is 0.05. And from the patients who are alcoholic, from them the patients who have liver disease, 7% of them are alcoholic. Okay, so this is our B by A. Now we want to calculate probability of a patient who probability of a patient who is alcoholic having a liver disease. What is the probability of a patient having liver disease who is alcoholic? Okay, that we gonna find out. Okay, that we gonna find out. So according to Bayes theorem, 0.07 into 0.1 divided by 0.05, so that is 0.4. That means, so if the patient is alcoholic, then their chances of having liver disease is 14%. Okay, so that's what is we find out using Bayes theorem. Okay, that's what we find out using Bayes theorem. So next slide, it shows you already the things that I have shown. So probability of A by B, this is the posterior, that is that the one that we are going to calculate. Probability of B by A, that is the historical knowledge that we have, the prior knowledge that you have, we have evidences of it, we have the past data records, like that. Probability of A, this is likelihood of seeing that evidence of your hypothesis is correct or not, right? That means probability of A is the probability. So this is what we are going to test, right? This probability of A we are going to test, and probability of B is likelihood of that evidence that we are using, that B has happened. What is the probability of that event being happened? Okay, so that's how is Bayes theorem. And it's just a 12th class math. We already have like we all already have done these things in 12, so that's this only. Okay, that's
So
what
it
is.
is a prediction, right? So
Yeah,
it
it
is
is
a
a prediction,
prediction.
right? So it won't be like our absolute value like others. The classifications that we have, it won't be absolute value. We will see. Okay, we will see with an example. Okay, so again the same example that we have. So total sample is 14, total yes is 9, total no is 5. So p yes is 9 by 14, p no is 5 by 14, right? Now, okay, so let's go ahead with the example for now. So let's just focus on this this example. So see, for outlook we have sunny, overcast, rainy. So 243 yes, and 302 as no, right? For temperature also, okay. So we create this kind of frequency tables for each of the conditions that we have. So for outlook, temperature, humidity, windy, we have created this kind of tables. Okay, now we will calculate the probability of each of the attribute. So probability of an attribute being sunny is 5 by 14, right? Because we have 5 examples for that. So that way we go ahead and calculate each one of them. Okay, we go ahead and calculate each one of this attributes probability. 5 by 14, 4 by 14, 5 by 14, like that. Okay, we keep on calculating this probability for each of the, we have this probability, we calculate the probability for each of the attributes individually. Okay, we create one by one. Then, so this will be probability of A. All these attributes will be probability of A. Now probability of each attribute, that is probability of B, will be should we play or not. So 9 by 14 or 5 by 14. Okay, now we are going to find out probability of A given B. Okay, that means here when we calculate probability of yes in Outlook sunny, that means what is the probability that the outlook will be sunny when it is given we are playing, that is 2 by 9. Okay, probability of no will be 3 by 5, like that. So if we keep on calculating this, then we will have all this p of yes no values. Okay, we will all have this p of yes no values. That means these are conditional probability of the events. Okay, probability of event A happening, that is probability of the event being sunny, the outlook being sunny when we are playing is 2 by 9. Like that we calculate for each of the steps, each of the attributes, we calculate all these things. Now we have to calculate probability of B, that given A is true. Like we will be playing when it is given outlook is sunny. We will be playing when it is given outlook is like overcast, like that. So we will apply Bayes theorem. So probability of outlook equals sunny is 5 by 14, as we know. Probability of temperature being cool is 4 by 14, like that we all know this, right? So now we just go ahead and multiply this result to have the probability of ideal condition, which will be 0.029. That is the probability of ideal condition. Okay, when we multiply all this, so that means those will be the ideal probability for each of the event being happened. Okay, each of the event happening. Okay, so outlook sunny is 5 by 14, temperature cool 4 by 14. So the we will just take the highest values from each of them. Okay, highest value from each of them, we will multiply those, and that will yield you the result of the result of ideal condition. So probability of ideal condition is 0.029. Okay, now ideal condition to play the game. So probability of outlook sunny when and play is given, play is yes 2 by 9, temperature cool, play yes 3 by 9, like that we have. So now we are going to calculate probability of playing a game in ideal condition. Okay, we will again multiply all these values to have a value of 0.033. So see here, we have probability of ideal condition into happens 0.029. We have probability of ideal condition when given that we are playing is 0.033. So we have probability of A by B, and we have probability of A into account. Now we will find out B by A. That means when what is the probability that we will be playing when there is an ideal condition? That will be XES into PES by PX, right? Px is again, PES is 9 by 14. So 0.033 into 9 by 14 by 0.029, which will yield you a 73% of a result. So that's what is about this conditional probability. So we have a 73% of playing when ideal condition is there. Okay, so that's how this Bayes theorem works. Clustering algorithms. Okay, those are unsupervised machine learning algorithms. Now, just to reiterate, what is unsupervised learning algorithms? Unsupervised, as the term suggests, there won't be any supervision for the algorithm or for the model to learn from something. The model won't have a definitive value to predict. The model will try and learn on its own to get the output. This kind of scenarios are called unsupervised learning. That means our model is working on to get something fuzzy, that is the clusters, right? So cluster means, what is clustering? Clustering means to divide data set into groups consisting similar data points. So that means cricketers, footballers, hockey players, lawn tennis players, they are all players, but we can cluster them like that. Okay, so all the cricketers will have the same kind of attributes, same kind of nature, that they will be playing cricket for their country. They are playing cricket, and they are I mean, their profession is playing cricket. So that's what their similarities will be. They will either be a bowler or a batsman, again subclusters among the cricketers. Like that we can think of it as clustering. Okay, so this kind of data sets are random in pattern, and we don't really have anything critical to predict in there, except this clustering. Okay, except to divide those data points into similar groups, as many similar groups as possible. Okay, so that's what the idea of clustering is. Okay, now cluster, if you see here, there are cluster of different colors, there are cluster of different colors of fruit, cluster of different types of garbages. So all this can be shown as clusters. Okay, so these are basically clusters, these are examples of clusterings. Now we will see how do we use it in machine learning. Okay, so use cases of clustering. If you see here, we have Netflix, we have Amazon, right? So there is a concept called recommendation engine or recommender engine. What it does, it recommends the products or movies to the similar type of customers. So what it does, it clusters all the products or all the movies that it has to some specific groups, and based on the liking of the customers it suggests. So if a lady logs in, if she has browsed through some lady's product, it will try and show her those kind of products as a recommendation, so that she might be buying one or two items from that list. Okay, for a man it might be cool, like it might be a belt, a wallet, specs, trimmers, and all those kind of stuffs will be shown for guys, or t-shirts for boys, like this kind of things will be happening. So these are basically two kind of filtering algorithms are used in this kind of recommendation engines. One is collaborative filtering, and another is content filtering. So what is the difference? The difference is, in case of collaborative filtering, the products that are recommended based on the customer type. Okay, if some customer has liked some product or bought some product, then the similar type of customer, how do they know similar? They take into account many parameters, let's say age, sex, and their work. Let's say someone is working in IT company and someone is a housewife, so their choices might differ, right? So that's how they show the products into products as an products to the customers, product as a recommendation to the customers. So the customers are grouped, then the products are shown to them. That is collaborative filtering. Content filtering is based on the contents. If someone has bought or liked some product, then the same those items will be shown to other customers, so that they might buy that. So content filtering based on the content, collaborative filtering based on the customer or target group. So that's how you can think of. So these are also some few examples of clustering that is being used in the real world. Okay, this kind of clusterings are being used in the real world. Okay, so Amazon, Netflix, Flickr, and all those cases, this clustering is used. Now we can see there are three types of clustering: exclusive, overlapping, and hierarchical. Let's go through those one by one. First type of clustering is exclusive clustering. That means there can only exist, or each data point of the total sample can exist in only one of the clusters. Okay, it cannot coexist in multiple clusters. So k means clustering is a good example of that. So what it will do, it will take the data points into account, the samples into account, and it will split the values based on that, and it will split it into as many clusters as possible. Okay, as many clusters as possible it will split it into. So in all those clusters will be pure clusters, and it will have only one type of data point. How we do k-means clustering we will see in the next few slides. Okay, so that is the idea of exclusive clustering. Now next comes into picture overlapping clusters. So here it will be overlapped in nature. In data science, we really don't use this kind of clusters. In our data science, the clusters will be based on exclusive and will be used maximum cases we will be use k-means only. Okay. Now for this kind of overlapping clusters, the data points are allowed to coexist in more than one cluster. So that means that means it is some kind of fuzzy clustering logic is being going on the behind of this going behind the scenes. Okay, so that is how this fuzzy clustering is done based on the data objects. It can belong to multiple clusters. Okay, next comes into picture hierarchical clustering. So how it is done? It is so the graph that you are seeing in the bottom of the screen is called a dendrogram. Okay, that is called a dendrogram. So how do we do it? First we group the nearby items that is possible. So if you see the leftmost picture, we have a, b, d, e, c and f. So a, b and d, e are pretty close to each other, right? So that A, B will be clubbed together in the same cluster. Okay, so A, B in one cluster, D in one cluster. Now C is near to B, F is near to D. So now in the next step, C will be included in the AB cluster and F will be included in the will be linked to the DE cluster. So that DE as a cluster, F as a cluster will form a new cluster. Okay, so that's what is being shown in the dendrogram also. So C comes into AB, so that is another cluster, and F comes into DE, so that becomes another cluster. So these are two clusters are there, two definitive clusters are there. Okay, and inside each cluster there are two segregated clusters. Now if you see in here, the distance between C and D is also minimum. So C and D is again clubbed and again another cluster is formed. So that's what the dendrogram also shows in the bottom and at the end of the picture. So the cluster DEF is pretty near to the point C. So those two clusters are also linked. So if you carefully see the dendrogram, you see there is an hierarchical relation between all this data point in this sample set. So this is again this is an example of hierarchical cluster. Okay, so this hierarchical cluster is also not much used in data science. So we will be only focusing on this exclusive clustering for this class. Okay, so this is what is the example of hierarchical clustering, and we discussed exclusive clustering and overlapping clustering as well. So guys, any doubts in here? So as we discussed, uh, exclusive clustering, and the type of exclusive clustering algorithm is a k-means clustering algorithm, right? So what is k-means clustering algorithm, how you can use it, and how the algorithm actually looks like, we will see that in next few slides. Okay, we will see that in next few slides. Okay, K-means is a clustering algorithm which focuses on to group similar elements or data points into clustering. Now you might be you might be wondering why K and why means, why no other name, right? So K in the K means represents the number of clusters that we are going to make. Okay. So if a data point has three clusters, that means it will be three means algorithm. Now why means? Because it calculates mean of the data, distance between two data points, and distance between mean of a cluster and each data point. It calculates the entire calculation of K means depends on the mean calculation. So that's why means. So that's what k-means clustering does. So what does k-means clustering do? K-means clustering clusters the data into k number of clusters. Okay, that's what is the use of k-means algorithm. How k-means algorithm finds this how this k-means algorithm how this k-means algorithm groups those into different clusters. It uses the difference between the mean of the data points and the difference between the mean of the cluster and the data points, and it keeps on grouping those. Now we will see the algorithm in detail in the next slide. Okay, I have a question like, is hierarchical is used in real world? No, Tom, it is not much used. There are use cases where it is used, but not much use for data science. Those are for astrophysics and high level of physics and maths research that is being used, and there hierarchical clusters do exist. Okay, so for machine learning it is used, but not for data science. Okay, for data science our world is really small. We only play with data, we only play with real world data, so there won't be much of an scenario like this. As you can understand, that's something when you work with electron, protons, neutrons, you might get those kind of things. Okay, that's what. So that's when you get those kind of things. Okay, next is this is an example like pile of laundry, so we just clear this thing. Next is business application of k-means. That means real world scenarios, where do we use it? So we use it for behavioral segmentation, like kids, adults, something like that. Sorting sensor measurements. Yes, we do take the sensor. We have a lot of sensors, right? So we take those data in and we can parse it using this clustering algorithm. Let's say this is a home. This is a big home. This is a multi-storied building. This is a small home. This is a hut. Like that, we can do detecting bots or anomalies. Yes. So the behavioral pattern of the users can be clustered, and we can directly see the anomalies when a bot entered in a system, right? Next is inventory categorization. That means we can group different items and we can keep the inventory like that. So how much item is needed for which item is needed in what quantity, we can take into account all those things. And bots and anomalies, we can directly segregate the human behavior and the bot's behavior from the if a bot enters in our system. So these, in these cases, k-means algorithm is really very helpful to cluster these things. These clusters means a lot. Okay, so that's how it works. Now we will be going through the example of k-means clustering. So any doubts till this point? Okay, let's go ahead with this example. So what do you see here? We see four balls in different positions, right? So how many clusters do we have here? Three. One, two, three. So here number of clusters will be 3 and k equals will be 3. So this is what we need to get from the data point. Okay, we need to segregate these three cultures based these three clusters using k-means algorithm, step by step. So this is the final requirement that we currently have. Okay, next is, what is the steps of k-means algorithm? We select the number of clusters to be identified randomly. Okay, so we select a value for k equals 3 in here. Then what we do, we select three random data points. Then we measure the distance between the first point and the selected three clusters. Okay, so we have k equal to 3. Then we will take a sample data point. Okay, then we will calculate all the distance, all the from that centroid, all the points distance will be measured, and based on the like distances, the clusters will be formed. Let's see how. Let's say we are assigning the first point to the nearest cluster, that is red. Okay, so for this point, this is the nearest cluster, right? So this is red, we are assigning it to red cluster. This we are assigning to purple, and this we are assigning to blue. Now we will see how we can go through step by step, and we can get this thing clustered into this four are red, this four purple, this four blue. Okay, so the first step will be, we assign the first point to the nearest cluster, that is the red cluster. Okay, that is our first point. Next is, we calculate the mean value including the new point for the red cluster. That means this one and this one are the two values. So this will be the mean point of the new cluster that is formed, right? This will be the new mean point of the new cluster. Now, which cluster does point 2 belongs to and how? So this cluster is, now for second point, we will calculate the distance between the between the red second red point. Okay, that is this mean point. Okay, we will calculate the difference between this point. So the idea of k means is, let me show you this first, you will get a clear idea for that. So see, initial cluster center is mu1 to mu k, where this all belongs to random number, I mean real number. Okay, then repeat until convergence. So till when should we repeat and what should we do? For every I, we need to set the distance or the minimum distance between a point and its mean of the cluster squared, and then for each j in the set we calculate the mu j. Mu j means, so j is the number of clusters that we have which will run till k. Okay, so we find the mean of each of the clusters. So we find a new centroid, and we find a new centroid, and then we assign that value to some clusters j. Okay, ci equals j, so we are assigning the value to the cluster, and then we are calculating the mean of it. So this is the two-step algorithm that we have shown. How it converges we might see in the next class, not today. Okay, because this might have you blazing. So what we are doing here, first step we are assigning this point to red. Okay, this fourth point to red, this point to purple, this point to blue. Now what we are doing next, from the first point we are calculating the distance from this red point, purple point and blue point. Nearest is red one, we are assigning this to red cluster. We are calculating the mean for these two. So these two are in a current cluster, so we are assigning a mean for it. So the mean comes in somewhere around here, just arbitrary value. Next what we will do, we will find the distance between the next point, that is this point and all these points from this mean point. So let's concentrate on this point only. So for this point we will calculate the difference between all these three values that we have for the cluster. So the minimum difference will be this one, so we assign this to red cluster again. Now we have 1 2 and 3 elements, we shift the mean, so it will be somewhere around here, right? So that would be the next step. The mean now shifts in, right? So mean now will be somewhere around here. So now we are calculating for this third variable. Okay, and again we calculating distance for these three centroids. We find this to be the nearest and we assign it to red also. Okay, so now the red mean shifted to here, so it is nearer to the red mean. So third point also gets into red point. Now the red mean shifts to somewhat right. Okay, now we calculate mean of this four and we have it here. Now we go to the next point, we calculate distance from this red mean point, this purple point and this blue point. We see the distance from blue point and this one is minimum, so we purple and this one is minimum, so we assign it to purple. Calculate mean comes in here. So this point now, so which cluster it should belong to. Okay, yes Tom, everything has an algorithm, we'll show you when we go to the coding example, we will show you, but for now please concentrate on this example part. Okay, because if you don't understand the math it will be difficult for you to understand the algorithm at the later point of time, and the code will just bounce back. Okay, so you need to have it. So to which cluster this point belongs to, this will seem to be this belong to this blue cluster. So this blue is now printed, and now this is the mean. So again what we will do, we will take this 4. So this all these 4 are located close to blue, right? So we will assign all this floor one by all this 4 one by one to this blue cluster. So that's how it will look like. So 6, right? So 6 is the 6 values are there in the blue cluster. That is what is the result from one iteration. Now what we do now, how this works, this key means when the convergence comes into picture, just have it in mind theoretically. So when this k means stops, ideally k means doesn't stop its iterations till it has all the data points are in equilibrium. That means the data points are not changing. Okay, so after we included this 4 points to the cluster, you see radically these 2 points distance from this blue one gets increased, right? So this points distance from purple one now much closer than its distance from blue line, right? So we will mark this cluster to purple. Then this point again we will, this will come to here, we will mark this to this purple cluster. So till like this it will start. Okay, so this time we will that's how we will be assigning the clusters. Okay, so that's how we will have the 3 points in a particular equilibrium. Now if you see here, all the points are located in their nearest clusters only, and we don't have any other alterations won't be there in this cluster, right? So that's what is k-means does. Okay, so first iteration it will do somewhat, second iteration it will do somewhat, and the third iteration it will give you the perfect result. So that is a 3 means. Now the next question comes, how to find the value of k? That's a big interesting question. So how do we know it? Okay, so to find this value of k, what we do, we take a value, we do use Witten trials in here. Okay, so what we do, we take all we take the value of k as 1. That means we think there are only one cluster. Okay, so what we do, we color all the points to red. Okay, because if we think that if we have one cluster, we paint all the points to red color. If we have two, then we have now again I lost my track. Okay, so for okay, let me restart from a bit earlier stage. So but how do we find out the value of k? Okay, how do we find out the value of k? What we do, for the previous example that we have solved manually, we see that k value of k was equals 3. But how do we know it? How do we calculate in the algorithmic perspective? We won't be knowing the data set that we are working on. How do we calculate? Okay, we use it and trial. We start from k equals 1. That means we suppose there is only one cluster present in the data set. Okay, so we paint all this to red, calculate mean. Now next step is to calculate the total variation. So we will calculate distance between all the data points from this mean point. We will see a large variation. We will change the value to 2. Okay, k equals 2. So we will have two clusters like this. So now if we have total variation calculated, then we will see it is somewhat better. Now we go for k equals 3. Okay, so now if we see the total variation, it is much better. Okay, now it will k equals 4, then it will still be better. Okay, so till like this we keep on continue. Okay, but how do we stop this algorithm from growing, right? It might go with all, it will go, it might go Charu, it's not variance, it is the difference between the point, distance between the point and the mean point for all the points, and we sum those up. Okay, this is different. This is not variance. And you can, variance won't solve here, so it is the mean distance actually. Now if we try with k, we will see the total variation is still better. But how do we stop? That is the main question, right? How do we stop? How do we know what is the point when do we stop? Okay, now this is a graph. If you see this graph, this is an elbow shaped graph of cost function for this. So this elbow where it comes in, the curve bends near the elbow. So this elbow point is the best case scenario. Okay, so this is the best number of clusters that can exist in a data set near this elbow point. Okay, so that's where when you see, so what do we point? We just plot the total distortion or the total variation in the data set with the number of clusters. Now if we keep on plotting this, it will bend at some point, and this bend is the ideal number of clusters. So that is 3. Okay, so that's how k-means works. So that's how k-means has its k-means knows where to stop. It has this elbow value. Okay, it has this at elbow point, it stops. So k equals 3 is the ideal cluster number for this. Okay, that's how it works. Y-axis is the distortion. That is the variation that we were discussing. Okay, so if we keep on increasing the clusters, at some after some point, the variation will be parallel to the x-axis. That is, it will have some definitive value of y. Okay, so it will be stuck at some point. So till which point the variation decrease, that is this elbow point is the required number of clusters that we take into account. Okay, so that is the idea of this k-means clusters. And for this example, if we plot this, the total variation, we will see for k equals 3, it is taking a slight bend, so we stop it right there. So that's how k-means understand where to stop. And at this point, we say k-means algorithm has converged. Okay, so that is the convergence criteria of k-means. So that's what it is. So do we have any doubts in this scree plot? Sorry, so what do we mean by scree plot? So what is your question, Charu? Can you tell me? Like scree plot. Okay, are you mentioning this plot? This elbow shaped plot? Yeah, correct. Yes, that is scree plot. So I was just thinking, where are you getting the term scree plot for this one? Okay, not an issue. Yeah, that is called scree plot. So this is basically used for factor analysis. Okay, so I don't want to go in details actually, but still let me tell you. So for multivariate statistics, right? Not for univariate, but for multivariate. So we have multiple variable values going in here and there. So that is a vector thing is going on there. So this scree plot is basically a line plot, and that signifies the eigenvalues of factors or eigenvalues plotted against their factors or principles. So that is the main idea. But as this scree plot bends in some time, so this is the same thing that we do in here, right? This is a multivariate analysis where we have multiple value of k. This is not univariate because there are multiple values of k might exist, and we are plotting the factor on this. So factor on the y-axis. So that's why this elbow-shaped scree plot is like is a cost function basically. Okay, next is what if we had our data plotted in x and y axis. Okay, so the same thing, right? The same thing. So what we will do, so let's say for here we have shown in a linear line, right? Like a linear plane we have shown. Now let's say the values are in this plane, xy plane. So what we do, let's say we start from k equals 3. So we will take 3 random points in there. Okay, we will calculate the point distance, as you know, that is Pythagoras, root over of b square plus b square. So we will find the distance between these points and its nearing points. We will then assign that nearest point to the cluster. We will calculate mean. We will keep on calculating the means and all and all and all. We will keep on going till this cluster reaches its like convergence criteria, until we have all the convergence criteria are met, until we have this happening. Okay, till we have this thing in till we have the I mean optimal number of clusters as an output. Okay, so that's how we can do. So now to summarize this k-means, that the examples that I have shown you earlier also. So how do we do? We randomly choose k examples as initial centroids, while and we keep on going in an infinite loop. We create k clusters by assigning each example to its closest centroid. Then we compute k new centroids by averaging examples in each cluster. If the centroids don't change, we come out of the loop. If the centroids keeps on changing, we continue the loop. So that's how k-means works. So till this point, everyone is clear. So we won't be doing it manually, Tom. Anyways, that will be done algorithmically, right?
consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo. And they are facing a major problem, and that basically is their customers are churning out to other competitors. Now, you as a data scientist at that particular company have to make sure to stop this churning out, and also how to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you'll go ahead and build the ML algorithms on top of this data set. So you'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right, and we'll be working with this customer churn data set. So this is our data set which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on, right? So yeah, so this is our first task, data manipulation. And to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd, and then I'll also load the numpy library. So I'll type in import numpy as np. I'd also need the matplotlib library. So I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read underscore csv, and inside this I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used. And then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year. And there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use dot ilog. I would need all of the rows, and I would need the 5th column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my 5th column over here. And I will store this in, let's say, C underscore 5. And I'll have a glance at the head of this, C underscore 5 dot head. Right, so we have successfully extracted the 5th column from this entire data frame, and this is the head of it. Similarly, we'd have to extract the 15th column and store it in customer 15, right? So if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0, right? I'll store this in C underscore 15, and I'll also make this to be C underscore 15. I'll click on run, right? So this is the streaming movies column and I get the same thing over here. This is column number 15 and I've extracted only this particular column from the entire data frame, right? This was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right. So there are three conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll given all of these three conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender and the gender needs to be equal to male, right? I'll cut this and paste this inside this. Of this, I'll use the AND operator and then given the second condition. So the second condition would go something like this, customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and given the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. All right. So I have all of my three conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these three conditions and I will paste them inside this and I will store it into a new object and name that object to be crandom, right? Now I will print the head of this, crandom.head. So we see that this, so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given three conditions over here and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the two conditions. So either the tenure of the customer needs to be greater than 70 months or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below and all I'll do is cut this and paste it inside this. Right. And I will store this in again crandom. Now let me again print the head of this crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here, Let me delete this from this. Right, so we have these conditions over here. So we'd have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes. Right, so I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just three records, or there are just three customers who satisfy all of these three conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these three customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these three conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here, and I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn, and then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers who will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'll have to create a simple bar plot for the internet service column. And Yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt dot bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in two parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this value counts, and from this I don't want the values, I just need the keys. And again I'd have to convert them into a list. So I'll use list over here. Now I'll click on run. Let's see what do we get, right? So these are the three levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has two things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421. And number of customers who don't avail the internet service are 1526. Right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, we had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the X label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. This would be plt.y label, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt dot title, and I'll set the title over here, and the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, This is where you understand all the patterns in the data set and you get insights from the data set. Right, so next up we have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So yeah, so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here. And the title of the plot needs to be equal to distribution of tenure. I'll do that. Alright, so I have created this plot and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right. And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot. And now all you have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data. We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. In columns, customer churn. What seems to be the problem over here? monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two, y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are X train, Y train, X test, and Y test. These are actually the labels which we conventionally use. I'll explain what these are exactly. X train, Y train, and then we have so this would actually be X test first, X train, X test, Y train, and Y test. So over here, X train represents all of all of those values of your features which are present in the training set. X test represents all of the features which are present in the test set. Y train represents all of the dependent values which are present in the train set, and Y test represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of X train and Y train. Let me also show you the shape of all of these. So X train dot shape. Let me do the same for the rest. X train dot shape. I'll make this to be Y train. I'll make this to be X test. And I'll make this to be Y test. Right. So X train, Y train. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. Sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have X train, Y train, X test, and Y test, then let's go ahead and build the model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail. Right? So this is the reason why we divide the data into training and testing set. Right. So now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X train and Y train. Right, so I've fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done. And for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this, and let me ease this to be in this over here. Right, so we get a root mean squared error value of 29.39. Right, so now let's say if we build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and if the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here, we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here, what we're basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test, right? So this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. Right, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set, and then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So x train and y train, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right, so this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again y pred. Right, so we have predicted the values now. Right, so when it comes to a classification model, we can use the confusion matrix. Right, so let me import the confusion matrix. So from sklearn.matrix, I will import the confusion matrix, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in y-test and predicted values are present in y-pred. Similarly, accuracy score, I'll do the same thing. Y-test and y-pred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651, and I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model, for the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charul, the question which you're asking, what if we had multiple independent variables, right? So over here, we have two independent variables. So this time the independent variables are monthly charges and tenure. And I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same. And the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model. I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion matrix and accuracy score, right? Now over here, again, I'm calculating the confusion matrix and this time I get an accuracy of 77.50, right? So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211. Right, so we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn dot tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree, right? And I'll go ahead and fit the model on top of the training set. So my tree dot fit, this takes in two parameters, which are x train and y train. I fit the model. Now it's time to predict the values. My tree dot predict, and I'll be predicting on top of the x test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion matrix now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys. Right, what we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the train data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part. Right, so because to the model building the, so it depends on your problem statement, Aditya. Right, so let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories, or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest, a random forest is always better than decision tree because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees. And the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same X and Y values. No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally, we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn dot ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and fit the model on top of X train and Y train. X train and Y train, I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion matrix over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in y test and y pred. Y test, y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. So you'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set, and then you'll break the values on top of the test set, and finally you'll calculate the accuracy. Right? So here, this is pretty much it for today's session, right? So this is your entire end-to-end project on the customer churn dataset, which comprise of data manipulation, data visualization, and implementing all of the machine learning algorithms. So this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier.
So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'll have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary and we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run and we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2 and house number 3 are our real world entities which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create two variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Right. So now over here, I'll just use the print function and type in enter your name, and after this I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object, right? And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard, right? So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created two get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly I'll create another method which would be put age and I'll pass in self inside this. So for this, it would be print of your age is. Let me again put in double quotes over here. Right. So your age is, it would be self.age. So we have created our class where we have two variables, name and age, and I've created 4 methods. And out of those, from those 2 methods, I'll be getting the name and age of the person, and the rest of the 2 methods would help me to print the name and age of the person. Right. I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the getName and getAge methods. So person1 dot get name. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right. So now it's time to get the age of the person. So I'll type in person1 dot get age. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right. So we have successfully created our class which would print out the name of the person and the age of the person. Right. So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here I'll just create the init method, and these are the parameters of this init method self. So, and after this it'll take in the name of the person, and after name it'll take in the age of the person, and after this it'll take in the branch of the person. Right. Now what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age, so self.age equals age, and then we have the final variable which is branch, so it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method, right? So we have created our init method, which is basically a constructor, and going ahead we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this we have age, so let me change this to be age over here, and this would be self.age. After this we'll have to print in the branch, so let me just put in branch over here, and this would be self.branch, right? So we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right. So what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use the super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import numpy as np. After this, I'll create my 1D numpy array. So a equals np dot array. Now I will give in a list of values. So this is my 1D array a, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name b. So again the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3, and the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 numpy array comprising of all the zeros. So there's a 5 cross 5 numpy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the numpy library. Let me just type in import numpy as np, and inside a I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out a. So we have successfully created our 5 cross 5 numpy array where all of the values are just zeros. Now let's say we have two numpy arrays like this. So this is our first numpy array, this is our second numpy array. First numpy array comprises of 1, 2 and 3. Second numpy array comprises of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7 and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the numpy library, import numpy as np. I will go ahead and create my first numpy array, a equals np.array. And the values are 1, 2 and 3. Similarly, I'll create my second numpy array which is b. I'll change this variable to be equal to b and the values are 4, 5 and 6. Now to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the numpy arrays which I'd have to add. So I want to add a and b, and I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a numpy array. So this is our numpy array over here, and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68, and I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this NumPy array. So 168 are the two highest values from this NumPy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as PD. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4, and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24, and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango, and orange, and the count of the fruits is 12, 24, and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width, and species. Now out of this, we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as PD, and after this, to load a CSV file, I'd have to use the pd.readcsv function, and I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this dataset. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal dot width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we given the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be pandas and numpy. So import pandas as pd and import numpy as np. After this, I'll load the iris dataset. So iris equal to pd dot read csv, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column. And the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame. And with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readcsv function. And I'll give in the name of the file, which is enhance.csv. And I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right, so we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here, right? So this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in two parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function, and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda, and then you'll give in all of your arguments. After that, you'll put in a colon, and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda, and I'll give the name of the variable to be a. I'll give a colon, and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10, and the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the numpy package. So I'll type in import numpy as np, and I would also need the matplotlib package. So I'll type in from matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x, and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here, and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt.plot, and I'll pass in x, comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt.x label. So the label would be x-axis. Similarly, plt.y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt.title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange, and we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. from matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list, right? So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop, and it will iterate through all of the characters in this string, and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0, and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string, it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1, right? So this is our numpy array which comprises of the numbers from 0 to 9, and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the numpy library, import numpy as np. After this, what I have to do is create my numpy array. So arr equals np.arange, and it will go from 0 to 10. Let me just print out this numpy array over here. This is my numpy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So arr %2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'd have to perform an operation so that we get the common items between two numpy arrays. This is our first numpy array. This is our second numpy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first numpy array and I'm storing it in A. This is my second numpy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two numpy arrays inside this as the parameters. So A, comma B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb, so we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as pd. Now I'll create the series pd.series, and I'll pass in the values, which are basically Mary had little lamb. Right, so this is done, and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now. Right, so this is my pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital. Right, and as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here. Right, so all of these elements have been converted into title case. So now we have the same panda series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3, and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this panda series. Import pandas as PD. Let me again create the series. Ser equals pd dot series, and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this panda series, I'll have to use the map method. So ser dot map, and inside this I'll again create a new lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In had there are 3 characters, a is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s underscore length. Let me load the package, import pandas as pd, and I'll also load the file. So pd dot read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here, I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s underscore length. So it'll be s underscore length. So this is how it goes. So iris dot rename, and the original column name is sepal dot length, and I'd have to change it to s underscore length, and I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1 dot head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the pandas library, import pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read underscore csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So x comma y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in xtrain, xtest, ytrain and ytest. So xtrain would comprise of all of the training values or all of the training records for the features, and xtest is basically the test set for the features. Ytrain is the train set for the target and ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of xtrain and ytrain, or in other words, I'm fitting the model on top of the train set. Alright, so now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x underscore test, and I'll store this in y underscore pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics dot mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start off by loading the requisite packages, which are numpy and pandas. So import numpy as np and import pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these four columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first four columns. So I'll just extract sepal length, sepal width, petal length and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'll have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics and we'll also get the accuracy score. Right. So this is my confusion metrics and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same and it comes out to be 91.11.
Just a quick info guys. If you are looking to get certified in machine learning, then Intellipaat offers a great course for you. You can check the link in the description box below. I hope this video was helpful for you. If you have any further queries, do reach us in the comment box below and we'll get back to you immediately. Thank you.